Hi friends, my name is Maruti and I'm the co-founder of Kraku. In this video, we'll be looking at 25 very important LRDI sets for CAT. All of these sets have been picked from the daily targets that thousands of students take every single day. For people who don't know, in daily targets, we give one test in quant, one LRDI set and one reading comprehension set every single day, and all of them have video solutions. These are taken by thousands of students every single day, and from all of these sets, we have picked the 25 best LRDI sets, which you'll see in this video. In addition to it, we also have released a video on the 100 most important quant questions for CAT. The link for that video is given in the description of this video. Please do like this video, please do subscribe to our channel, and please do share this video with your friends. In addition to this, if you're looking for free material for CAT, we have 3 free mocks. All of them have video solutions. In addition to it, we also believe that one of the best resources to prepare for CAT is the CAT previous papers. You can download all the CAT previous papers in PDF format on our website. You have to just Google search Kraku CAT previous papers. The link for the CAT previous papers is also given in the description of this video. So please do like this video, please do share it with your friends. If you have any doubts, please do comment below the video. In this question, we are told that there are 2 companies, X and Y, and they mix 5 different metals, P, Q, R, S, T, in different ratios. We are given the ratio in which the metals are mixed by weight in the case of X, and in the case of alloy Y, we are given the ratio by value in which they are mixed. For each of the 5 metals, P, Q, R, S, T, we are also given their cost prices per ton. For example, in the case of P, we are told that the cost price is 20 lakhs per ton. In case of Q, it is 25 lakhs per ton. In case of R, it is 15 lakhs per ton. In case of S, it is 30 lakhs per ton, and in case of T, it is 20 lakhs per ton. So let us first look at only alloy X. If you are looking at alloy X, now we have P, Q, R, S and T. By weight, we know the ratio in which they are mixed. The ratio is given to us, it is 20, 25, 15, 10 and 30. Now each of these individual metals, we also know how much they cost per ton. So if you are adding up the total weight, it is 20 plus 25 is 45, plus 15 is 60, plus 10 plus 30 is 100 tons. So suppose you are making 100 tons of alloy X. Then you have to mix 20 tons of P, 25 tons of Q, 15 tons of R, 10 tons of S and 30 tons of T. And what is the total cost? Then we are going to get the ratio by value. The 20 tons of P would cost 20 into 20, which is 400. The 25 tons of Q would cost 25 into 25, which is 625. And for R, it would cost 15 into 15, which is 225. For S, it would cost 10 into 30, which is 300. And for T, it would cost 30 into 20, which is 600. So the ratio by value is given in the second line. The ratio by value of all the 5 metals P, Q, R, S, T are mixed in alloy X is 400 is to 625 is to 225 is to 300 is to 600. All of them have a common factor which is 25, so you can divide to actually get the required ratio. But you at least understand the idea. Now let us look at the same ratio but for alloy Y. Now for alloy Y, you have again the 5 metals P, Q, R, S and T. But for this, we are given the ratio by value in which all of these 5 metals are mixed. So let us try to find out the ratio by weight, and this is the ratio by value. The ratio by value is 15 is to 35 is to 20 is to 10 is to 20. If you are counting the total, it will be 15 plus 35 is 50 plus 50 is another 100. So out of rupees 100, what is the amount of P that is mixed? So 15 rupees are spent in purchasing P. So the amount of P that is purchased will be 15 divided by 20. The amount of Q that is purchased is 35 divided by 25. The amount of R that is purchased is 20 by 15. The amount of S that is purchased is 10 by 30. And the amount of T that is purchased is 20 by 20. So if you sum all of this up, you will find out the total weight of the alloy, which costs rupees 100. So now that we have an idea of what the data given represents, let us go ahead and answer the questions that follow. The first question says that what is the ratio of the amount of metals R and T used in making alloy by company Y. So here we are required to find out the ratio of the amounts of metal, that is the weights of R and weights of T. Weights of R is 20 by 15 and weight of T is 20 by 20. So the required ratio is 20 by 15 is to 20 by 20. This is 4 by 3, this is 1. So the required ratio is 4 by 3 is to 1, which is equal to 4 is to 3. Let us look at the second question. Find the approximate ratio of selling prices of company X and company Y if both the companies sell their alloy at a profit of 25%. So let us first find out the cost price of 1 ton of X, and let us also find out the cost price of 1 ton of Y. Because the profit percentage is the same, the ratio of the cost prices will be exactly the ratio of the selling prices. So what we are essentially required to find out is the ratio of the cost price of 1 ton of X to the cost price of 1 ton of Y. Here let us assume that in the first case we are purchasing 100 tons of X. If you are purchasing 100 tons of X, you will need 20 tons of P, 25 tons of Q, 15 tons of R, 10 tons of S and 30 tons of T. So what is the total value or the total cost? We have just calculated it. For each one of them it is 400 plus 625 plus 225 plus 300 plus 600. If you calculate the sum, 625 plus 225 is 850, 850 plus 300 is 1150, 1150 plus 1000 is 2150. So 100 tons cost 2150. So what is the cost price of 1 ton of X? The cost price will be 2150 divided by 100, which is 21.50. Similarly, let us calculate the cost price of 1 ton of Y. Here we know that if you are purchasing 100 rupees, what is the total weight of alloy Y that you are getting? The total weight of alloy Y that you are getting for 100 rupees is 15 by 20. This is the weight of P that is there, plus 35 by 25. This is the weight of Q, plus 20 by 15, plus 10 by 30, plus 20 by 20. These many tons cost 21.50. So if you are simplifying this, 3 by 4 plus 7 by 5 plus 4 by 3 plus 1 by 3 plus 1, sorry, this costs rupees 100. This costs rupees 100. This is in terms of alloy Y. So if you are summing this up, 4 by 3 plus 1 by 3 is 5 by 3 plus 1 is 8 by 3. And 3 by 4 plus 7 by 5 will be by 20, 15 plus 28. So this will imply that this is 43 by 20 plus 8 by 3, or if you can simplify this, this will be 129 plus 160 divided by 60. This is simple addition of different fractions. So this would imply that 289 by 60 tons would cost rupees 100. We are ignoring lakhs and the other number of zeros because we are only looking for the ratio. So all of them will get cancelled. So 289 by 60 tons would cost rupees 100 for alloy Y. So 1 ton would cost 60 into 100, that is 6000 divided by 289. This is for alloy Y. Now if you are trying to find out the ratio of the cost prices, for X it is 21.50 and for Y it is 6000 divided by 289. So this ratio you can simplify as 21.50 into 289 is to 6000. You can multiply both sides with 2 so that you will get a proper number. So this will be 43 into 289 is to 12,000. You can use your calculator, and amongst the 4 options you will figure out that this ratio is very close to 29 is to 28, which will be the correct answer. Now let us look at the next question. Due to which of the following metals has the cost of making alloy X gone up by the maximum amount? So if you are calculating the cost of 100 tons of X, we have calculated that it would cost 2150 rupees. Now 2150 I think lakh rupees, but you get the gist of it. So out of this 2150, which metal is contributing the most? P is contributing 400, Q is contributing 625, R is contributing 225, S is contributing 300 and T is contributing 600. So the metal which is contributing the most is metal Q. Let us look at the next question. what percentage of total cost is the cost due to metals P and R of X. So again, out of 100 tons, what is the cost of 100 tons of alloy X? It is 2150. P is contributing 400 and R is contributing 225. So the total contribution of P plus R is 625 out of the total cost of 2150. This is the fraction. If you are trying to express this as a percentage, you have to multiply this by 100. You can simplify this, you can use your calculator to find out that this will come to approximately equal to 29%, which will be the answer. In this question, we are told that there are 36 workers who are working in a factory. They are sitting in a 6x6 grid. The naming of the grid is given such that all the columns are named from A to F and all the rows are named from 1 to 6. So there are a total of 36 people. So there will be 36 squares, and the workers start sitting at each one, at all the 36 squares. Initially, there were 6 workers who were having fever, so they are displaying symptoms. And if this is a disease which spreads from this is a contagious disease, so if you sit beside 2 workers for 1 hour, then you get infected, and then that person is also a sick person and he can also transmit the disease. Now the person can transmit the disease only if they are sitting adjacent to each other. They can't spread the disease via the diagonal. So if you look at it, there is E4 who is sick and D5 who is sick at 12 noon. So the person who is sitting at D4 will also get sick in 1 hour, and the person who is sitting at E5 will also get sick in 1 hour. But the person who is sitting diagonally will not get infected. They should sit exactly beside each other for 1 hour. So in the first 1 hour, there is nobody else who is going to get infected. Let us look at who will get infected after 2 hours. The only person who is sitting beside 2 people, 2 infected people at 1 p.m. so that he'll get infected at 2 p.m. will be the person who is sitting at D3. Now once this is done, you can again easily calculate who else is going to get infected at 3 p.m. So there are the person who is sitting at E3 will get infected, and the person who is sitting at C3 will get infected. At 4 p.m. for example, you will have the person sitting at E2 to get infected and the person sitting at C2 to get infected at 4 p.m. Similarly, the person sitting at C4 will also get infected at 4 p.m. and that is about it. There won't be any other person who is going to get infected at 4 p.m. If you are looking at 5 p.m, you need to find places which have 2 adjacent team members who are sick. So this is 5 and this is 5. As you can see, there are more people who are getting infected at 5 p.m. That is about it. There is nobody else who is going to get infected at 5. If you are looking at 6, there will be this person who is infected at 6, this person who is infected at 6, and this person who is infected at 6. At 7, you will have A5, B6, C1 and F4. These are the people who are infected at 7 p.m. If you are looking at 8, you will have these 3 people who are infected at 8. At 9, you will have A3. This is also going to get infected at 8 because you have 7 and 1. If you are looking at 9, you will have these 2 people who will get infected at 9, and this guy is going to get infected at 10, this guy also is going to get infected at 10, and this guy is going to get infected at 11, and this guy is going to get infected at 11. So basically we are just looking at the graph, we are looking at the grid, and we are jotting down at what point or after what hour does each of the person in each of the 36 squares get infected. So I have filled up the grid. So now let us go ahead and answer the questions that follow. How many 6 workers will be there in the factory till 5 p.m. So if you're looking at the number of people who got infected by 5 p.m, you have at X, that is at 12 noon, you have 6 people who are infected. At 1, you have to just count the number of people who are infected. So this is only 2. How many people were infected at 2? You have only 1 guy. How many people were infected at 3? You have 1, 2. So you have only 2. At 4, how many people do you have? You have 1, 2, 3. So you have 3 people. how many people were infected at 5? You have many people infected at 5. So this is 1, 2, 3, 4, 5. So you have 5 people infected at 5. So the total number of people who are infected by 5 p.m. are 6 plus 2 is 8, plus 2 is 3, plus 8. So there will be a total of 19 people who are infected till 5 p.m. Let us look at the next question. After how many hours will all the workers be sick in the factory? You know that after 11 hours, all the people are infected in the factory, and the last 2 people who are infected after 11 hours are the guy who is sitting in A1 and the person who is sitting at F6. These are the last 2 to get infected, and they get infected after 11 hours. Amongst the following, which worker gets sick the last? As we have discussed, the person who is sitting at A1 gets infected after 11 hours. So A1 is the last. Just for confirmation, the guy sitting at B2 gets infected after 5 hours. The person who is sitting at B5 gets infected after 6 hours. And the person who is sitting at C6 gets infected after 8 hours. So the correct answer is A1. How many workers who are not sick at 8 p.m. get sick by 9 p.m. So basically we have to look at the number of people who have 9 in the grid that we have filled up. You can see that there is A3 and D6. These are the 2 guys who are not infected by 8 p.m. but they were infected at 9 p.m. So the correct answer is 2 people. This is a question on magic squares. It is told that Gaurav is playing this game. So what exactly is a magic square? A magic square contains of a 3 cross 3 square. So let us draw one magic square. So it looks something like this. So it has 3 rows and 3 columns, and you fill in numbers from 1 to 9. All of them are filled in ones in the 9 squares, in the 9 cells, such that the sum of all the rows, that is the first row, the second row and the third row, all of them is the same. Same is the sum of all the columns, even they will be the same, and even the 2 diagonals, they will also total up to the same number. So if you are looking at what exactly will that number be, what is the sum of the first 9 natural numbers that we are actually filling? The sum is 1 plus 2 plus 3 plus ... till 9. This is the sum of the first 9 natural numbers. So this will equal 9 into 10, which is 9 plus 1 divided by 2. So this is equal to 45. So the sum of the 3 rows, for example, is the same, and it totals up to 45 divided by 3, so that is 15. So each of the row, the sum is 15. Each column, the sum is 15, and both the diagonals also the sum is 15. Now we have to arrange all these numbers from 1 to 9 in such a way that all of them will add up to 15. How are we going to do it? So one of the concepts that we should know in magic squares is that if you are looking at the squares, there are 3 types of cells. The first cell is the cell which is in the center. That is this cell. There is second cell which is called the middle. There is one cell which is in the center, and there are 4 cells which are in the middle. That is, they are in the middle of each of the side. And finally you have another type which is called the corner. And there are again 4 corners of this 3 cross 3 square. The reason this is important is because we can have multiple formations of these numbers from 1 to 9, but in any of the formation, the center only one number can go. In the middle, the only 4 numbers can go, not all the 9 numbers can go into the middle. Similarly, even at the corner, there will be only 4 numbers which can go. So let us try to figure out which are those 4 numbers. So let us first look at the number which goes into the center. Let us see if 1 can be in the center. If you have the number 1 in the center, then you have, if you are naming all of them, all the cells as A, B, C, D, E, which we are assuming to be 1, F, G, H and I, the cell in the center is very important because it is connected to one row and it is connected to both the diagonals. So if the number in the center is 1, it would imply that A plus I is equal to 14. These are the 2 corners of the diagonal. Similarly, it would imply that C plus G, which is the other end of the diagonal, is also equal to 14. Similarly, D plus F, which are the ends of a row, are also equal to 14. and b plus h is also equal to 14. So you basically need a pair of 4 numbers such that all of them will equal to 14. Now if you can see, you will not be able to find 4 pairs such that all of them will add up to 14. Why can't you find them? Because you will only find pairs which are 9 plus 5 and 8 plus 6. These are the only 2 pairs which are between 1 and 9 which add up to 14. So the number in the middle cannot be 1. Can it be equal to 2? In that case, instead of 14, you will need 4 pairs which total up to 13. Now if you are trying to find pairs which total up to 13 and the number in the middle is 2, you have 9 plus 4 as one pair, you have 8 plus 5 as another pair, and you have 7 plus 6 as the third pair. You are not getting the fourth pair. So the number in the middle cannot even be 2. Can it be equal to 3? In that case, the 4 pair should total up to 12. You can find 9 plus 3, but this is not allowed because the number in the middle is assumed to be 3. So none of the numbers which are in the other pair should be 3. So this is not allowed. Other than that, you have 8 plus 4 and 7 plus 5. So you have only 2 pairs which total up to 12, which don't include the number 3, which we have assumed to be in the middle. So the number in the middle cannot even be 3. Can it be 4? If it is 4, we need the sum of the 4 pairs to be equal to 11, which is 15 minus 4. And let us see if we can find 4 such pairs. You have 9 plus 2 as one pair. You have 8 plus 3 as another pair. You cannot have 7 plus 4 because 4 is assumed to be in the middle. So it can't be present in any of the 4 pairs. Then you have 6 plus 5. So you have only 3 pairs. So the number in the middle cannot even be 4. Can it be equal to 5? If you are looking for the number in the middle to be 5, then the sum of the 4 pairs should equal 15 minus 5, which is 10. Let us try to find 4 such pairs. You have 9 plus 1, you have 8 plus 2, you have 7 plus 3, and you have 6 plus 4. So here you have 4 pairs which total up to 10. So the number in the middle can be equal to 5. Let us see if it can equal 6. If it equals 6, the sum of the 4 pairs should equal 9, which is 15 minus 6, and none of the 4 pairs should have the number 6. So you have 8 plus 1, you have 7 plus 2, you can't have 6 plus 3 because the number in the middle is assumed to be 6, so it can't be present in any of the 8 pairs, and you have 5 plus 4. So again, this is not possible because you are only finding 3 pairs. Can it be 7? You can't have this to be 7 because you want the pairs to total up to 8 without having 7. So you will have only 6 plus 2 and 5 plus 3. You are only finding 2 pairs. So it can't even be 7. Can it be 8? If the number in the middle is 8, then you need to find 4 pairs which total up to 7, which is 15 minus 8. And you have 6 plus 1, you have 5 plus 2, you have 4 plus 3. So you have only 3 pairs. So the number in the middle cannot be 8. Can it be equal to 9? Then the sum of the 4 pairs should equal 6, which is 15 minus 9. You have 5 plus 1 and you have 4 plus 2. So the number in the middle cannot even be 9. So there is only one number which is possible, which can be in the middle, and that is equal to 5. So let us write down a new square and let us put 5 in it. So the number in the middle will be 5. So in any magic square which is a 3 cross 3 magic square, the number in the middle has to be 5 if all the rows, columns and diagonals have to have the same number. So the center has to be 5. Now let us see which numbers can be in the middle and which numbers should be at the corner. So let us see if you can have a number. For example, if we are growing with 9, can this number be in the corner? So if you are drawing another magic square, you know that center has to be 5. Let us look at the numbers which can be in the middle and numbers which can be at the corners. If you are looking at the numbers which can be in the middle, then let us first see where we can put 9. Suppose 9 is at the corner. If say you have 9 at one of the corners, it can be at any corner. We are not naming the magic square yet because naming the magic square will give rise to many permutations and combinations which we don't want. We are just trying to identify whether 9 can be at any of the corner. It can be at the left corner or the right corner or the bottom right or the bottom left. So right now we are just looking at whether 9 can be at any corner. If it is at one corner, then the number diagonally opposite to 9 has to be 1. Now if the number diagonally opposite to 9 is 1, you have two numbers, let us call them x and y, which are in the same row as 1. Now x plus y has to total up to 14. Now x and y cannot be 9 or 5. So the only possibility for x and y is 8 and 6. These are the only two numbers remaining. But if x is equal to 8, the column containing 9 and 8 will total up to more than 15. Even if x is 6, even then the sum of 9 plus 6 is already 15, and you will have to add a number which is in the middle. So this would imply that there is a contradiction if you are assuming that 9 is at the corner. So 9 cannot be at the corner, 9 has to be in the middle. So 9 has to be somewhere over here, and the number opposite 9 will always be 1. So 1 also will be in the middle. Now without lack of generalization, again, we are not naming the rows as A, B, C or X, Y, Z. We are just saying that 9 has to be in the middle of some row. So let us assume that that is 9 over here. This square can even be transfixed both horizontally as well as vertically, but even then the cells which are in the middle will remain in the middle. So 9 will be over here and 1 will be exactly opposite it. Now let us look at where the other numbers can go. So if you are looking at 8 next, the reason we are going from 9 to 8 coming from the top is because when the number is higher and you already know that the middle number is 5, there will be a lot of restrictions. So for us to find a contradiction is easier. It is easier to find a contradiction from 9 than from, say, the middle where it is 4 or 5 or 6. So with 9, for example, we could easily find a contradiction. So let us now go to 8. So now we know that one of the center number has to be 5 and the middle number has to be 9 and 1 somewhere over here. Now let us see where 8 can go. Now let us see if 8 can go into another middle number. So somewhere over here. It can be either 8 here or the remaining middle. Again, both of them are same by symmetry. So let us assume that it is the one to the left. If 8 is over here, then 8 plus 5 is 13. So the number opposite 8 has to be 2. Now once you know that the number opposite 8 is 2, now let us assume that the number at the leftmost corner is A. In this case, the number which is diagonally opposite it has to be 15 minus 5. So that is 10 minus A. So this will be 10 minus A. So the number in the left bottom corner, this has to equal 15 minus 8, that is 7 minus A. So this will be 7 minus A. And the sum of these three again has to be equal to 15. So what does this mean? This would imply that 7 plus 1, 7 minus A plus 1 plus 10 minus A is equal to 15, or this is 18 minus 2A. So this is 18 minus 2A is equal to 15, or A is equal to 1.5. So again, clearly there is a contradiction if you are assuming that 8 is in the middle. So 8 cannot be in the middle, 8 has to be at one of the corners. If you are trying to understand which corner 8 has to be in, this is 5, this is 9 and this is 1. 8 cannot be here, 8 cannot be here, 8 cannot be in the middle also. Why cannot 8 be in the corner which is just opposite 9? Because the sum of that row will be greater than 17, so that is not allowed. So 8 has to be in a corner which is significantly far away from 9. So it can be either at the left or it can be at the right. But again, for our purpose of trying to identify where it is, it doesn't matter because it is just a mirror image of the magic square. So you'll get many permutations whenever you are either rotating the magic square or you are doing the mirror image. All of them will essentially be the same magic square which is turned around. So in this case, let us assume that 8 is at the left corner. So 8 has to be at the left corner, then 2 will be at the diagonally opposite corner, but both of them will again be at corners. Now let us look at where the remaining can be there, which is 7, 6 and 4 and 3. If this is 8, 8 plus 1 is 9, so this has to be 6 because the sum of the row has to be equal to 15. So 6 also is at a corner. Now 6 plus 5 is 11, so 4 is the number which is at the end of the diagonal, so 4 is also at a corner. So the remaining two cells have to be 3, which is 8 plus 4 is 12, so 15 minus 12 is 3. This is in the middle, and 3 plus 5 is 8, so 15 minus 8 is 7. So 7 also has to be in the middle. What we are essentially saying is you will get some permutation of the given magic square either by rotating or by taking a mirror image, but in any magic square of this form, 9, 1, 3 and 7 will always be in the middle of a row. So these are the 4 cells which we are saying are the middle, and 8, 2, 6, 4 will be at the corners. So these are the 4 cells which are at the corners, and in all the magic square the number in the center will always be 5. So this is basically what we are saying. Now let us go ahead and answer the questions that follow. In the first question, it is given that if the entry of the cell CZ is 4, then what would the entry in AY be? So let us first draw a magic square and let us try to find out. So this is the magic square. The number in the center will always be 5. This is A, B and C. Now we are putting the numbers, the alphabets. So we are naming all the cells. This is X, Y and Z. Now that we are naming all the cells, we can't immediately put down all the numbers that we have put in our in the cell which we have drawn just for representation. So anyway, we are told that CZ is equal to 4. So this number has to be equal to 4. So the number which is in AX will be 15 minus 5, that is 10 minus 4. So this is equal to 6. Now what should the number which is there in AY be? So we are looking for a number over here. Now if you are looking at the representation that we had, the number in the corner is 6 and the two numbers which are beside it are either 1 or 7. So the number in AY has to be a number which is in the middle. So the number in the middle is 1, 9, 3 and 7. But out of 1, 9, 3 and 7, you could see that 6 is always further away from 9 and 6 is always further away from 3. So 3 and 9 are not adjacent to 6. Here we are looking for AY which is adjacent to 6. So it can be either 1 or 7. So we can actually fill in both the diagrams of the magic squares which actually satisfy this. So let us first put AY is equal to 1 over here. If this is 1, then the other middle has to be 7. So this is 6 plus 7 is 13. So this is 2. 2 plus 4 is 6. So this has to be 9. 7 plus 5 is 12. So this has to be 3. 6 plus 1 is 7. So this has to be 8. So this is one magic square. You can put the exact mirror image and you will get another magic square. But in this case, you will get AY to be equal to 7. So you have A, B and C and you have X, Y and Z. So here it is 6, 5 and 4. In this case, AY we are putting to be 7. So the other one which is BX will be equal to 1. So 6 plus 1 is 7. So this is 8. 8 plus 4 is 12. So this is 3. 1 plus 5 is 6. So this is 9. 7 plus 6 is 13. So this is 2. As you can see, both of these magic squares are very similar. They are just a mirror image. They have been transposed across the diagonal. Once you transpose them across the diagonal, you will get the other square. But anyway, the cell AY can be either 1 or 7. It can't be any other number. So the correct answer is 1 or 7. Let us look at the next question. If the entry in cell AZ is not 2 or 4, then the entry in cell CY cannot be. So again, let us draw another magic square and let us try to figure it out. So in any of the magic square, the number in the middle is 5. We'll again draw A, B or C and X, Y and Z. Now we are telling that the number in AZ, this is not 2 or 4. So it is not 2 or 4. So the only corner numbers that are remaining are 8 or 6. So this is 8 or 6. Now we are told that which of then the entry in cell CY cannot be equal to. Now we are looking for what this number in CY cannot be equal to. So let us see what the number can be if it is 8. Then we'll consider what the number can be if it is 6. If it is 8, we are looking for a number in the middle. The number in the middle is 9, 1, 3 or 7. And the number in the middle is not adjacent to 8. The cells which are adjacent to 8. So if you are looking in the representative diagram, 1 and 3 are adjacent to 8. So it can't be 1 or 3. So if the number over here is 8, the number if AZ is 8, then CY has to be either 9 or 7. Because you are looking for a number in the middle and that number in the middle should not be adjacent to 8. 1 and 3 are adjacent to 8, so that is not allowed. Now let us see if the cell AZ is 6. That is the only other remaining possible number which can be in the corner. Now again we are looking for a number in the middle, so it can be either 9 or 1 or 3 or 7. And again you don't want it to be adjacent to 6. Adjacent to 6 are 1 and 7. So the numbers which are adjacent to 6 are 9 or 3. So basically the number CY can be either 9 or 7 or 3 or 9 or 7. Why is this the case? Because if it is mentioned that AZ cannot be 2 or 4, AZ has to be either 6 or 8. because there are only 4 numbers which are allowed to be in the corners. They are 8, 2, 6 and 4. So if it is not 2 or 4, the number AZ has to be either 8 or 6. If it is 8, CY has to be either 9 or 7. If it is 6, CY has to be either 9 or 3. So the only possible values of CY which are allowed are 3 or 9 or 7. 3 or 9 or 7 can be CY. So the number which is not 3 or 9 or 7 should be the answer. So in this case, the answer has to be A, which is 1, because 7 is allowed, 9 is allowed and 3 is allowed. So the correct answer is 1. Now let us look at the next question. If 3 is not present in row B, then which of the following numbers are definitely not present in row A? So let us again draw another magic square. So this is the magic square. Again you have 5 in the middle. It is always there in the middle. You have the rows as A, B or C, and you have X, Y or Z. Now we are told that 3 is definitely not present in row B. So 3 is not present over here. So 3 is either over in the row A or it is in row C. Basically it is in the middle. We can consider both the cases. So this is 3 and this will be 3 plus the number opposite 3 is 7. Or it will be, let us draw another diagram. So again you have this as 5, 3 is at the bottom and 7 is at the top. Now we are trying to identify which of the following numbers, the numbers given, cannot be in row A. If you are looking at the options, 4, 6 and 8 are in the corners. We are not very concerned about the corners. What we are sure is 1 has to be in the middle, and the only numbers which are remaining in the middle are both in row B. So 1 can be over here or 1 can be over here, which is the same even in the second case. 1 can be over here or 1 can be over here, and it will be 1 or 9 which are exactly opposite each other. So what we are essentially saying is that 1 will definitely be in row B, it will not be in row A. So the correct answer is 1. It can be either 1 or 9. Now let us look at the next question. Which of the following numbers should definitely be present in a corner cell? So again, as we have discussed earlier, we can divide the 9 cells that are there in a magic square into 3 different categories. One is the number at the center. The number at the center will always be 5. The numbers which are in the middle are always 9, 7, 3 and 1. The only issue is we don't know which middle these will go. Because of symmetry, they can be either at the top or to the right or at the bottom or to the left. Any of this it is possible, but they'll always be in the middle. Similarly, we have 4 corners and the numbers which can be present in the corners are 2, 4, 6 and 8. Again, there are 4 corners. These can go anywhere in any of the 4 corners based on what is the rotation that is there in the magic square, but they will definitely be in a corner. So if you're looking at the options given, 9 is not the case because 9 will be in the middle. 7 also is not the case because 7 also will be in the middle. 3 also is not the case because 3 also is in the middle. The only number which will always be in the corner is 4. If you have an option which is either 2 or 4 or 6 or 8, that will be the answer. In this case, we have only 4. So the correct answer is 4. In this question, it is given that there is a jailer and there are 8 inmates in 8 cells, that is cell 1 to 8. And all of them were standing in a row. Now what is not known is which direction were they facing. Some of them were facing north and some of them were facing south. Every inmate of the cell was asked to answer how many people were ahead of him, and so each one of them has given a particular set of numbers. For example, cell 1 guy has said that he sees 6 people ahead of him. So this would imply that there was 1 guy behind him in the direction that he is facing. Similarly, cell 2 guy says that there are 2 people ahead of him and 5 people behind him, because the total number of people in the row, in the line is 8, including the person who is actually saying it out. So without him, there will be 7 people. Some of them will be ahead of him and some of them will be behind him. So we have the numbers that each of the 8 inmates have actually called out. Now we don't know the directions in which each one of them was facing, and we don't know their respective order. The question involves, what we are supposed to find out in this question is, what is the arrangement, that is who is standing where and in what direction are they facing. One additional information that has been given is that the number of inmates facing south was not more than 4. So what we'll do is simple. We'll first write down 8 blanks. This is 1, 2, 3, 4, 5, 6, 7 and 8. Now in these 8 blanks, we'll try to arrange the inmates according to where they are standing in the row. We are not particularly concerned about which is the north direction and which is the south direction at the start. We'll try to identify where each one of them is standing and what is the relative direction in which they are facing. Are they facing to the left or to the right? That is, over here we'll put the number and over here we'll give a direction. So a direction arrow this would point that he is facing on the right side, and a direction this side would mean that he is facing on the left side. What is not clear as of now is whether right is north or left is north. That we will come to later on. So for example, if you look at it, there are 2 inmates that you should immediately identify. The inmate in cell number 5 says that he sees nobody ahead of him, which would imply that all the 7 people are behind him. Again, why are we saying there are only 7 inmates? Because including the cellmate 5, there will be 7 other people, so the total will be 8 people. So he has to find 7 people. Some of them will be ahead of him and some of them will be behind him. If he says that there is nobody ahead of him, it would imply that all the 7 people are behind him. So we can assume that the person to the leftmost is the person who is in cell number 5. Why is it left side and not right side? Because it doesn't matter. It doesn't matter because the relative direction in which he is facing will be to the left side. Because we are not yet saying that which direction is north or which direction is south. We are just saying that cell number 5 is at one end of a line. Which end of the line we will come to later on. So cell number 5 is standing at one end of a line. We are assuming that this is the left end of the line. And because he sees nobody ahead of him, he is pointing to the left. He is facing the left side. And the person who is in cell number 6 sees 7 people ahead of him. So he is also at another end. So this will be the second end, and this guy is also facing to the left because he sees all the people ahead of him. You might argue that why is this not the case where you have another 8 guys, 8 cells, 1, 2, 3, 4, 5, 6, 7 and 8, in which there is cell number 5 to the rightmost and cell number 6 to the leftmost, and both of them are facing to the right. What we are essentially saying is both of them are the same case. As long as you don't fix which is north and which is south, it doesn't really matter whether you are going with the top case or the bottom case. So for now we are going to ignore this, and whenever we are deciding on what is north and what is south, we will figure out the relative direction. So anyway, we know that 5 and 6 are at 2 ends of the row. We also know that both of them are facing the same side, such that there is nobody ahead of 5 and there are 7 people ahead of 6. What is the next thing that you should see? The next thing you should see is the person who is in cell number 1 and cell number 8. Both of them are saying that they see 6 people ahead of them. This would imply only one thing. This would imply that there are 2 cases. Either cell number 1 is over here and he is turning to the right, in which case he sees 6 people ahead of him, or cell number 1 is at the penultimate from the right and he is seeing to the left, where again he sees 6 people ahead of him. The same is the case with even cell number 8. It can be that the person who is in cell number 8 also is standing at the second place from the left. He is also facing to the right because he sees 6 people ahead of him, or he is somewhere over here, where again he is seeing people to the left, 6 people ahead of him. So we don't know who is standing where relatively, but we know that both of them are standing in these 2 places. We'll try to identify which who is standing where, but for now we know that both of them are standing in the penultimate places from the left and the right. We also know the direction which they're facing. We know that the guy who is standing to the left is facing the right direction, and we also know that the guy who is standing to the right is facing the left direction. Now there is one more clue that has been given. It is said that there is no 3 consecutive inmates are facing the same direction. What does this mean? This means that the guy who is standing third from the right is definitely facing the right direction. This person, for example, can't face the left direction, because that would imply that there are 3 consecutive guys, all of them from the right, who are all facing the same direction, which is facing towards the left. That is not true. So we know that this guy is standing, he is facing the right direction. And how many people are ahead of him? You can say that there are 2 people ahead of him. The guy who is either 1 or 8 and the guy who is from cell number 6. So let us see who is having 2 people ahead of him. There is only one person who says that there are two people ahead of me, and that is cell number 2. So this is filled by cell number 2. Now we have 3 places left. Let us try to identify even the others. Now if you're trying to find out who else we can identify, because we have found out the person who has said there are 2 people ahead of me, let us try to identify who is the guy who is saying there are 5 people ahead of me, because again 2 plus 5 is equal to 7, and 7 is a key number. Why is 7 a key number? Because every inmate sees 7 people other than him. So when you have identified the person who has seen 2 people ahead of him, we can even identify that there is a person in cell number 7 who says that he sees 5 people ahead of him. So of the 3 places remaining, which is the only place where you can see 5 people ahead of that person, it will be this place where there are 5 people ahead of him, and those 5 will be to the right. So there is 1, 2, 3, 4 and 5. If he is standing in any other place and whichever direction he is facing, he will not be getting 5 people ahead of him. So this would imply that even the guy who is from cell number 7 is facing to the right, and he is also seeing 5 people ahead of him. We'll again use the same trick that we have used earlier, which is that because this place and this place, the guys who are to the second and third from the left, both of them are facing to the right, it would imply that the guy who is standing next to this person, the person who is from cell number 7, would be facing left, because you can't have 3 arrows in the same direction in a consecutive place. Now this guy who is 4th from the left, how many people does he see ahead of him? He'll see these 3 guys ahead of him, that is 1, 2, 3. And let us look at who is the person who has said that I can see 3 people ahead of me. That is the person from cell number 3. So this is going to be cell number 3. Now there is only one cell remaining, and who is the occupant who we haven't filled in? It is the occupant from cell number 4. This is cell number 4. Which direction is he seeing in? If you look at what the cell number 4 guy has said, he has said that he sees 4 people ahead of him. Now to the right of cell number 4 there are 3 people, and to the left of cell number 4 there are 4 people. This would imply that even he is seeing to the left. Now we have filled in all the details, all the places. There is only confusion about where the guy from cell number 1 is standing and where the guy from cell number 8 is standing. And we also have to figure out which direction is left and which direction is right. If you look at the total number of people who are facing left, that is this direction, it is being faced by cell number 5, it is being faced by cell number 3, it is being faced by cell number 4, it is being faced by 1 or 8, the guy who is second from the right, and it is also being faced by cell number 6. What does this imply? It has been given that the number of inmates who are facing south was not more than 4. So facing left is definitely not south, because you know that there are 5 people who are facing left. So this is north, and the opposite direction, this is south, which will have actually 3 members. So now we have filled in all the details that we can fill in. Let us go ahead and try to answer the questions that follow. How many different arrangements are possible? If you look at the arrangement that we have formed, we have identified the places of 6 of the 8 people uniquely. We have identified where 2, 3, 4, 5, 6 and 7 actually stand. We have also identified the direction in which all of them are facing. The only confusion we have is whether it is 1 or 8 who is standing to the second from left and second from right. So in each of the cases there will be 2 cases. In one case, this guy from cell number 1 will be standing beside 5, and in one case the guy from cell number 8 will be standing beside the guy from cell number 5. So in all there are 2 cases possible. Other than that, there is no other case possible. Who among the following is definitely facing south? The guy who is facing south has to turn right, because we have identified that turning right is south. If you look at the numbers that are given, the people who are turning south are the guy from cell number 7, the guy from cell number 2, and one of the 2 guys from cell 1 or 8. This we are not sure. We are not sure whether it is cell number 1 or cell number 8. But we know that the guy from cell number 2 is definitely facing south. We also know that the guy from cell number 7 is definitely facing south. If you look at the options, inmate from cell number 1, we can't say for sure that he is facing south. There is a possibility that he is facing south, but it can't be determined uniquely. The inmate from cell number 3 is definitely not facing south. The inmate from cell number 4 is also definitely not facing south. the inmate from cell number 7 is definitely facing south. So the correct answer is 7. If 2 is also given in the option, even that would be correct, but because it is not given and only 7 is given, 7 is the correct answer. If inmate from cell number 1 faces north, so again to recollect, looking to the left is north. So if you look at the options that are given, it would imply that because this is to the left, this is where the inmate from cell number 1 is actually there. So let us write that particular case. So 1, 2, 3, 4, 5, 6, 7 and 8. This is 5, this is 7, this is 3, this is 4, this is 2 and this is 6. And the directions, if you are looking, this. The only confusion that we have is where is the guy from cell number 1 standing and where is the guy from cell number 8 standing. We know that both of them are there in either of these two cells. If it is given that the guy from cell number 1 is facing north, and we have also found out that to the left is north and to the right is south, it would imply that the guy from cell number 1 is standing beside cell number 6 and the guy from cell number 8 is standing beside cell number 5. From which cell, the inmate from which cell stands 2 ahead of the inmate from cell number 3. So this is cell number 3. So the person who is standing 2 steps ahead of the person from cell number 3 will be the guy from cell number 8. Between inmate from cell number 5, that is this guy, and inmate from cell number 2, that is this guy, both of them excluded. So you have to look at only these 4 guys, that is 1 or 8, 7, 3 and 4. How many inmates are facing north? Again to recollect, turning left is north and turning right is south according to the arrangement that we had. Now we know that the guy from cell number 1 or 8 is turning right, so he's not counted. The guy from 7 is also turning right, so he is also facing south. The guys from 3 and 4 are looking to the left, so they are facing north. And then you have 2. So the number of people between the inmate from cell number 5 and the inmate from cell number 2 who are facing north is 2, and they are the inmates from cell number 3 and 4.
Hi friends, welcome to Krako's video series. In this particular video, we are going to take a look at a LR set in which we have to arrange employees into different areas or specializations as well as different factories as such. So let us take a look at the set and let's see how to solve it. 5 factories, Tata Motors, Maruti Suzuki, Asian Paints, HAL and Apollo Tyres had 15 members A to O allocated for planning, production and shipping manufacturing unit. So basically there are 3 units: planning unit, production unit and shipping manufacturing units, and 5 factories. So 5 into 3, there are 15 people. So we have to allot each of these 15 people to one of these 15 combinations as such. The below chart gives the employees working in different various departments. Each company had 1 member in each department. So basically, like say A will be in Tata Motors production or something like that. So there are 15 people and 15 possible combinations of factory and department. Now we have to figure that out. Okay. Outer layer is planning, middle layer is production, inner layer is shipping. So basically we know exactly in which particular profession each of these A to O are. So we know that A is in shipping, A, C, J, E, L are in shipping and manufacturing. Middle layer is production, so D, H, G, I, M are production, and K, F, N, O, B are in planning department as such, and the additional details are also given about them. So essentially, if you see, this is kind of like Einstein's puzzle. We know who is in each department, but we have to essentially allot them according to factories also. So let us try to draw a table so that we can allot them in factories and in different departments as such. Okay, so we have 5 factories, which is Tata Motors, Maruti Suzuki, Asian Paints, HAL and Apollo Tyres. And I'll keep extra space over each of this so that I have additional room to write if I have any other comments as such. Okay, so this is say planning, this is production and shipping manufacturing, and this is Tata Motors, this is Maruti Suzuki, Asian Paints, HAL and Apollo. Okay, and this would be extra clue area essentially. And we have ACJEL is planning, is basically shipping. So this is ACJEL are in this department. DHGIM are in production, and KFNOB are in planning. Okay, these five are essentially, these five are in the different departments as such. Now let us take a look at the different clues that are there. AOJM are the only employees who are managerial level. No two of them work in the same factory. So AOJM should be in different factories. Asian Paints nor Apollo Tyres has selected employee M. So basically M is not over here, M is not over here. Maruti Suzuki. So essentially for the factories we should see the columns, for the departments we should see the rows, and the rows should be basically made of these 5 people that I've written in the extra areas as such. So ACJEL should be in some order over here, DHGIM should be in some order over here, KFNOB should be in some order over here. Maruti Suzuki has selected employee H. So Maruti Suzuki is employee H. So H is in production. So this is H. I have used up this clue. So H is gone. Tata Motors, Maruti Suzuki and Asian Paints, select one among the following pairs: A, H, O, N, J, D and MC. So A, H, O, M, J, D and MC. Let us consider which pairs are possible. Let us consider if it is, you have essentially M is appearing twice. So O, M and C can be one, O is over here, M is over here and C is over here. So both can actually be possible. And then in that case AH or JD will not be possible, but I know that O and M are in different factories. So if O and M are both are at managerial level and both of them cannot work in the same factory, I know that this cannot be one of the pairs, which means that AH, JD and MC are the 3 pairs, and each of these belong to one among Tata Motors, Maruti Suzuki and Asian Paints as such. Now I know where H is, so that means that A is also with Maruti Suzuki. A is in this row, so this is A. Cut off A so that I've placed A. So AH is done. Now I have JD and MC, and JD and MC should be in together in among so Maruti Suzuki is done. So one should be with Tata Motors and one should be with Asian Paints. But Asian Paints cannot have M, so M cannot be in Asian Paints. So that means MC has to be with Tata Motors as such. So that means that MC is with Tata Motors. So this is M, this is C. M and C are also done. And J and D should be with Asian Paints as such. So J and D is with Asian Paints. So this is J over here, this is D over here. J is done, D is done. Okay, so 3 are done as such. So this is also done. So this clue is used up. Apollo Tyres, Maruti Suzuki, HAL selected one among the following pairs. So we have BI, FG, OI and NH. Okay. So if you just see, we have G and I remaining, E and L remaining, and the entire planning row is remaining as such. So this is used up, this is used up. It cannot be M because I've already placed M as such. Also A, J, so this is D, sorry. So A, J and O and M are managerial level employees, and no 2 of them work in the same factory. So this is M. So I'm circling to indicate that they are managerial level, and A, O, J, M are managerial level and they don't work in the same factory. So O has to be either here or here as such. He cannot be in Tata Motor, Maruti Suzuki or Asian Paints as such. So 2 has also been used up. 1 I have not used up yet because I have not placed O yet. So let us take a look at the 5th this also. Apollo Tyres, Maruti Suzuki, HAL selected one among the following pairs: BI, FG, OI and NH. So we have BI and FI. So one of these should only be correct because you can't have BI and FI in the same because B and F are in the same row. So you can't have both BI and FI, OI to be the same. So one among these 2 is correct, which means that FG and NH are definitely correct. Now if NH is definitely correct, that means that N should be over here if NH is correct. So Maruti Suzuki is NH, and that is Maruti Suzuki is NH and A as such. So N is placed. Now between BI and OI, 1 is correct and FG has to be correct as such. So if FG is correct, where can we place FG? So FG basically is across these two levels. So we need two blanks across planning and production. So FG can be over here or over here. So it can be either HAL or Apollo Tyres, as such both are mentioned. So one of them should be FG. Now since I know that O has to be between these two rows, HAL and Apollo, if this is say FG, then the other has to be O. It cannot be B, because O has to be among HAL and Apollo. It cannot be in Tata Motors, Maruti Suzuki or Apollo, because of the first rule where M, A, J are over here. So O cannot be in these three factories. So O has to be among HAL and Apollo as such. So if FG is in HAL, then Apollo has to be over here, which means that BI cannot be the case. BI cannot be for the other company, because in that case O will have to be among these three companies as such, which is violating condition 1. So basically that means that BI is a wrong pair. So one will be FG and the other will be OI. So either FG can be HAL and Apollo can be OI, or this can be OI and this can be FG as such. So this means that we have two possible configurations, FG-OI or OI-FG. Now it is given that the factory that selected O also selected E. So it must be that it would be OI-E or E over here, and the other would be L as such. So it would be L or E or L according to this scenario. So one scenario is FGL or OIE, and the other is OIE and FGL as such. So basically we have two chains as such. FGL is one chain, OIE is one chain, and those chains can be essentially swapped between HAL and Apollo as such. The only two people who are not placed is K and B. So even this pair rule is used up, 5 is used up, 4 is used up, and AOG, even this is used up as such. O is the manager among this. So essentially all rules are used up. So this can be K or B, and correspondingly this will be B or K. Note that this K and B is not dependent on this placement as such. So this is independent placement, this is independent placement as such. So just indicating that we have two choices over here. This is K or B, correspondingly B or K, and two choices over here. HAL can be FGL or it can be OIE, and Apollo has to be the other as such. So you have two choices here, two choices here. Now let us, we have used up all the rules as such, and we have come up with this particular table. So now that we have come up with this table, let's try to answer the following questions. So consider the first question. The number of ways in which the employees can be selected is basically what is the number of ways in which we can arrange them. So the number of ways is basically B and K can be arranged in two ways. This can be KB or BK. And similarly, this can be FGL or OIE. So basically this has two configurations, this part, and this has two configurations. It is K or B. So it should be basically 2 into 2. So that has to be 4 ways as such. So 4 ways in which people can be arranged among the different this as such. Now the second question is, if K and C work in the same factory, then they will be working in which of the following factory? So C is in Tata Motors. So if K and C work in the same factory, then they are working in Tata Motors. So then the arrangement would be K will be here, B will be here. So in that case, they will be working in Tata Motors. Question number 3 is, G can work in which of the following factories? See, G can work in HAL or Apollo. So that basically means that he can work in Apollo Tyres. HAL is not one of the options, so the answer is Apollo Tyres, which is option A. Fourth question is, if B works in Tata Motors, then who works in the planning unit of Asian Paints? So we have B is in Tata Motors, so Asian Paints will then have K. This is if B is over here, then correspondingly K has to be over here, which means that planning unit of Asian Paints has K. Okay, so the answer is option C, K. So this is basically how you should solve questions of this sort. See, in this case, it became very easy once we had this table. So this table you have to just remember, this particular diagram as such would have thrown a lot of people. Just remember, whenever you have a diagram like this, try to represent it as a table. Once you represent it as a table, it becomes easier for people to understand. So if you see, this is basically saying that planning has these 5 people, production has these 5 people, shipping and manufacturing has these 5 people, and it's not really a complicated graph as such. So once you realize that, it becomes easier for you to answer questions. So this is basically how you should answer this set. Now that you know how to answer this set, please keep on practicing from the study room so that you answer more of sets of this kind. Thank you for tuning in.
In this question, we are told that there are 7 friends: Suresh, Mukesh, Kamlesh, Nayan, Namit, Naman and Amar, and they are all ardent football fans. They are looking at 3 teams: Manchester City, Arsenal and Manchester United, and each one of them has ranked these 3 football clubs in the ratio of their likelihood of winning. That is, a fan who is a person who is a very big fan of Manchester City would have ranked it 1, and if he thinks Manchester United would come the second best team, probably he would rank it 2, and whichever team he thinks has the least chance of winning the Premier League, he would rank it as 3. So each of these 7 people have ranked the 3 teams from 1 to 3. What we don't know is which ranks each of the 7 people have given to each of the 3 teams. But we have been given some clues, and based on these clues, we have to figure out the ranks given by each of the 7 people to each of the 3 teams. First, let us look at all the clues that are given, and then we will continue to reiterate till we figure out the entire table. The first clue says that the rank assigned by Naman to Manchester United is the same as the rank assigned by Kamlesh to Arsenal. What is the rank assigned by Naman to Manchester United? Let us assume this is small a. This is the same as the rank assigned by Kamlesh to Arsenal. So this will also be equal to small a. The number of friends who assigned rank 1 to Arsenal is the same as the number of friends who assigned rank 2 to Manchester City. So the number of friends who assigned rank 1 to Arsenal is the same as the number of friends who assigned 2 to Manchester City. The sum of the ranks assigned by all the friends to Manchester United is 5 less than the sum of assigned by all the friends to Manchester City. So let us assume that the sum of all the ranks assigned to Manchester City is equal to S. Therefore, the sum of all the ranks assigned to Manchester United is S minus 5. The sum of all the ranks assigned by all the friends to Arsenal is 7 less than that of the sum of all the ranks assigned by all the friends to Manchester City. So the ranks of all the friends assigned to Arsenal will be S minus 7. This is an important clue because all the 7 friends have ranked the 3 teams as 1 plus 2 plus 3 in some order, but all the 3 numbers in each of the rows is 1, 2 and 3. So if you are calculating the sum of the ranks in any row, it will equal 6. It can be 3, 1, 2, it can be 2, 3, 1, it can be 2, 1, 3. Anyway they rank, the numbers will be the same, they are 1, 2, 3. So the sum will equal 6. And there are 7 such rows because there are 7 such friends. So the total of all the ranks assigned to Manchester City plus Manchester United plus Arsenal will equal 6 into 7, which is equal to 42. Now 42 is equal to S plus S minus 5 plus S minus 7. So using this, we can calculate the value of S, or this is 3S minus 12 is equal to 42, or S is equal to 54 by 3, which is 18. Therefore, the total of all the ranks of Manchester City is 18, the total of all the ranks of Man United is 13, and the total of all the ranks of Arsenal is 11. So we have completely used up the third rule, we have completely used up the fourth clue. So let us put a cross over there because there is nothing more we can get when we are reiterating through all the clues. The next clue says that the rank assigned by Namit to Manchester United, this if you are saying is equal to B, is the same as the rank assigned by Nayan to Manchester City. So this is also equal to B. Suresh assigned a numerically lower rank to Manchester City over here than Naman. Suresh assigned a lower rank to Manchester City than Naman. So the rank assigned by Suresh to Manchester City is less than whatever was assigned by Naman. We are also told that none of the friends ranked Manchester United second. So all the ranks that were in the Manchester United column, they are either 1 or 3. We know that there are 7 such ranks and we know that they total up to 13. So we can figure out how many friends have ranked it as 1 and how many friends have ranked it as 3. Because we know that if say there are A friends have ranked it as 1, then 7 minus A friends have ranked it as 3, and the total of all the ranks is equal to 13. That is A plus 3 into 7 minus A is equal to 13, or A plus 21 minus 3A is equal to 13, or 2A will equal 21 minus 13, which is 8, or the value of A is equal to 4. So 4 friends have ranked it as 1, Manchester United, no friend ranked it as 2, that was given as the clue, and the remaining 3 friends have ranked Manchester United as 3. This is basically the clues that are given to us. Let us reiterate through all the clues and see if we will find any more clues. So let us go through all the clues, let us try to identify which are the important clues and which are not the important clues, and let us try to solve the table. The first clue, again if you are going through it, says that the rank assigned by Naman to Manchester United is the same as the rank assigned by Kamlesh to Arsenal. We have already noted that in the table, and there is nothing much that we are going to get by this one clue alone. So we will put a small cross over there. If you are looking at the second clue, the number of friends who assigned rank 1 to Arsenal was the same as the number of friends who assigned rank 2 to Manchester City. This seems to be an important clue and we haven't used it much. One of the reasons this feels to be important is because 7 friends ranked Arsenal and the total of all the ranks assigned by the friends is only 11. So a lot of friends have given very good ranks to Arsenal. So let us try to identify what the number of friends who have given the rank 1 to Arsenal is. So there is 1, there is 2 and there is 3. We already know that 4 friends have ranked Manchester United as 1. So the number of friends who ranked Arsenal as 1 has to be less than or equal to 3. The total of 7 friends and the total of all the ranks given by the 7 friends is 11. The average rank, if you look at it, is 11 by 7, which is approximately equal to 1.5. We also know that, as we have just discussed, because 4 friends have ranked Manchester United as 1, the number of friends who have ranked Arsenal as 1 has to be less than or equal to 3. If say only one friend has ranked Arsenal as 1, then the sum of the remaining ranks, remaining 6 friends, has to be equal to 10, and all the other guys have ranked Arsenal as either 2 or 3. And the average is 10 by 6, which is 1.66. So this is not possible. You can't have all the friends rank Arsenal as either 2 or 3 and the average be equal to 1.66. So the number of friends who ranked Arsenal as 1 cannot be equal to exactly 1. If it is equal to 2, the sum of the ranks given by the remaining 5 friends will be equal to 9, and the average is again equal to 1.8, and we know that all the other friends have ranked Arsenal as either 2 or 3. So again the average cannot be equal to 1.8. If you make the number of friends who have ranked Arsenal to be equal to 3, the sum of the ranks given by all the other friends, that is all the other 4 friends, will equal 8, or the average is exactly equal to 2. What this implies is that the number of friends who have ranked Arsenal as 1 is exactly equal to 3, the number of friends who have ranked Arsenal is equal to 2 is exactly equal to 4, and nobody ranked Arsenal 3. Because the average of the remaining 4 friends is 8, and even if one friend has ranked Arsenal to be 3, the average rank will be greater than 2. Because we know that the number of friends who have ranked Arsenal 1 is definitely equal to 3. So all the other guys have ranked it as either 2 or 3, and the average of all the ranks is exactly equal to 2. This would imply that all the other 4 friends have ranked Arsenal to be equal to 2. Now using this we can calculate how many people have ranked Manchester City as 1, 2 and 3. 1, 2 and 3. The total number of friends is 7. 4 ranked Man United as 1 and 3 ranked Arsenal as 1. So nobody ranked Man City as 1. Similarly, nobody ranked United as 2. 4 ranked Arsenal as 2. So the remaining 3 would have ranked Man City as 2. If you are looking at number 3, nobody ranked Arsenal as 3. 3 people ranked United as 3. So the remaining 4 have ranked Man City as 3. So this is the information we have. Now if you are looking at the ranks given by Naman to Man United is A, it is the same as the rank given by Arsenal by Kamlesh. We know that nobody ranked Arsenal 3, and we also know that nobody ranked Man United 2. This would imply that A has to equal 1, which is the only number common to both Arsenal and Man United. Similarly, if you are looking at the rank given by Suresh to Man City, we are told is less than, numerically less than the rank given by Naman to Man City. Nobody ranked Man City 1, so this would imply that the rank given by Suresh to Man City is 2 and the rank given by Naman to Man City is 3. This would imply that the rank given by Naman to Arsenal is 2. We would also know that because nobody ranked Man United 2, Kamlesh would have ranked Man United 3 because the only options remaining are either 2 or 3. This would imply that Kamlesh ranked Man City as 2. Using this, let us again go through all the clues to see if we can find any more clues. Otherwise, we will try to see if we can solve the set by ourselves. So we know that even the second clue has been completely used up. The sixth clue has also been completely used up. The fifth clue is that the rank assigned by Namit to Manchester United is the same as the rank assigned by Nayan to Manchester City. We have to figure out the value of B, so we'll try to come to it. This is probably the only clue left. None of the friends rank Manchester United 2, that we already know, and we'll try to use it while going forward. So this is basically the clues that are given. We have probably used all the clues. Let us just look at the table and try to fill in the table as much as we can. If you're trying to look at the value of B, nobody ranked Man City as 1. So the value of B has to be either 2 or 3. And we know that nobody ranked Man United 2. So the value of B cannot be equal to 2. This would imply that the value of B has to be exactly equal to 3. Similarly, we know that Suresh ranked Man City as 2. So Suresh would have ranked Arsenal as either 1 or 3. This has to be either 1 or 3. But if you look at it, we know that nobody ranked Arsenal 3. So the rank given by Suresh to Arsenal has to exactly equal to 1. This would imply that Suresh ranked Man United 3. Now we know that 3 people have ranked Man United 3 and the remaining 4 have ranked Man United to be equal to 1. And we have already found all the 3 people who ranked Man United as 3. So all the remaining people have ranked Man United as equal to exactly 1. Once we know the rank of Man United as 1, because Arsenal cannot have 3, it has to have either 1 or 2. We can put the rank given by Arsenal to be equal to 2 for Mukesh, for Nayan and for Amar. So the ranks of Man City for these guys will be 3 and 3. We know that how many 3s have we found out for Man City? We got 1, 2, 3 and 4. So we got all the 4 3s and we have 1 and 2 2s. So we have 1 2 remaining. So that will be the rank given by Namit to Man City. And there is one empty number for Arsenal. We have 4 2s. We have 1, 2, 3 and 4. And so this one has to be equal to 1. So now we have filled in the table. We know which friend has ranked which of the clubs according to 1, 2 and 3. Let us go ahead and answer the questions that follow. How many friends assigned rank 1 to Arsenal? If you are looking at Arsenal, we know that 3 people have ranked 1 to Arsenal and 4 people have ranked Arsenal as 2. The correct answer in this case is 3. What is the sum of the ranks assigned by Nayan over here, Namit over here and Naman over here to Manchester United? So there will be 1 plus 3 plus 1. So that is equal to 5. What is the sum of the ranks assigned by Suresh, Mukesh and Kamlesh, that first 3 guys, to Man City? It will be 2 plus 3 plus 2. So that is equal to 7. What is the sum of the ranks assigned by Mukesh, Kamlesh, Namit and Amar to Arsenal? Mukesh assigned 2, Kamlesh assigned 1, Namit assigned 1 and Amar assigned 2. So the total will be 2 plus 1 plus 2 plus 1, which is equal to 6. In this question, we are told that there is a public transport bus. It is present in Mumbai and it takes passengers from P to U, and between P and U, that is the bus stops P and U, there are a few other bus stops. Those are Q, R, S and T. We have one graph which shows how many people have entered the bus at all the particular stops. For example, if you look at P, 30 people have entered the bus and nobody has exited it, which is obvious because the bus has started from P. If you're looking at Q, 20 people have entered the bus and 15 people have left it. And similarly, you can look at R, where 40 people have entered the bus and 20 people have exited it, and so on. You can do it for S, T and U. Similarly, we are also told how much time it takes for the bus to go from P to Q, Q to R, R to S, S to T and T to U. This is just the information that is given to us. We can go ahead and answer the questions that follow. But first, let us put down the information that is given about the number of passengers who get into the bus and number of passengers who exit from the bus at different stops, so that we can go ahead and answer the questions. So we'll have a table. The first one will be the names of the stops. This row will contain P, this row will contain Q, this row will contain R, this row will contain S, these are T and U. So this is P, Q, R, S, T and U. This is in and this is out. We are just going to look at the information that is given in this graph and put it down in a table so that it is easy to handle the data. In P we have 30 people who have entered and nobody has exited because P is the starting point. At Q we have 20 people who entered and 15 people who have exited. So this is 20 and this is 15. At R we have 40 people who have entered and 20 people who have exited. This is 40 and this is 20. At S we have 30 people who entered and 35 people who exited. So this is 30 and this is 35. At T we have 30 people who entered and 40 people who exited. So this is 30 and this is 40. U is the last stop, so nobody entered it, but 40 people have exited it. So U will have 0 entry, this is also 0, and 40 people who have exited. As you can expect, the total number of people who have entered the bus will be equal to the total number of people who have exited the bus. If you calculate, this is 30 plus 20, that is 50, plus 40 is 90, 90 plus 60 is 150. So the total is 150. This is 15 plus 20 is 35, 35 plus 35 is 70, 70 plus 40 is 110, plus 40 is 150. This is expected that all the people who have entered the bus have got off the bus at some point or the other. We'll add one more column. This column will say the total number of people who are in the bus after the bus has started moving. So for example, in P, after the bus has moved from P there are 30 people in the bus. So this will be 30. At Q, 15 people have got off the bus. So the number of people who are there in the bus will be 15. But again, 20 people have got into the bus. So this will be 35. That is, after the bus starts from Q, there will be 35 people in the bus. Now then it comes to R and 20 people get off the bus. So you will have 15 people in the bus, but then 40 people enter the bus. So this will be 55. So after the bus starts from R, there will be 55 people in the bus. Then it comes to S, where 35 people get off the bus. So you will have 20 people in it, and then 30 people will get onto the bus at S. So there will be 50 people in it. And then again the bus starts moving from S. Then it reaches T, where out of the 50, 40 people will get off it. So there will be 10 people in the bus and 30 people also get into the bus at T. So you will have 40 people in the bus after the bus starts at T, and all these 40 people get off at U. So this is basically the information that we have. There are 4 questions. Let us try to answer them. In this question, we are asked to find out what can be the maximum number of people who travel from P to U. So P is the first stop and U is the last stop. So we'll have to try to maximize the number of people who are traveling from here. So if you look at the number of people who have entered at P, there are 30 people. Now once Q comes, 15 of these 30 people will get off. So you will have 15 people left who have gotten it at P, and there are 20 people who have gotten it at Q. So these are there and these are there at Q. Notice that the 15 people who got down at Q, all of them have to have got into the bus at P. Then again you have a total of 15 plus 20, that is 35 people in the bus. Now this bus comes to R, and how many people get off at R? There are 20 people who get off at R. What we are trying to do is maximize the number of people out of this 30 who reach U. So what we'll assume is that all the 20 people who got off at R would be the people who alighted the bus or who got into the bus at Q. So these 15 people would still be there in the bus. Now at R we have 40 more people who have entered. These are the people who got into the bus at R. There are 20 people who got off the bus at R, but we are assuming that all those 20 are from Q. So at this point, when the bus has just started from R, the bus will have a total of 55 people, of which 15 are from P and 40 are from R. Then the bus comes to S. And how many people have to get off the bus? 35 people have to get off the bus at S. Again, as we have done earlier, we will try to keep as many of this 15 as possible inside the bus. We want them to go till U because we want to maximize the number of people who have traveled all the way from P to U. Now you need to get 35 people off the bus. So what we'll assume is that of the 35 people who get off the bus, all of them have got into the bus at R. So all of them are part of this group of 40 people. So at S, when after the 35 people have gotten off the bus, you have 15 people from P, these guys. You have 5 people from R. So out of this 40, you have 5 people who are still left in the bus from R. And then you have 30 people who got into the bus at S. Again, if you notice, the total number of people in the bus at this time will be 30 plus 5 plus 15, that is 50, which is as expected. So again, the bus starts at S and then it goes to T. Now, how many people should get off the bus at T? You need 40 people to get off the bus at T. Again, you want to make this 15 or this 15 people to stay in the bus for as long as possible. But you need 40 people to get off the bus. So you will elate, you will make all the 30 people who got into the bus at S get off. You still need 10 people more. So you will take these 5 people from R also to get off the bus. So now you still need 5 more people. So of the 15 people who got into the bus at P, you will need to get 5 of them off the bus. So at T you have 10 people from P and you have 30 people who have just got into the bus at T. So this 30 will still be there, and now the bus comes to U, where you will get all the 40 people to get down from the bus, and here all the 10 people from P will get off. So the maximum number of people who can go from P all the way till U is only 10. So the correct answer over here is 10. Let us look at solving the next question. What can be the maximum number of passengers who have traveled for exactly 60 minutes? So we want to maximize the number of people who have traveled for exactly 60 minutes. So let us look at what are the different times that are, or what are the different stops that somebody can get into the bus and get off the bus such that they travel for exactly 60 minutes. If somebody has got into the bus at P, it will take 30 minutes to reach Q, it will take another 15 minutes to reach R, and it will take another 15 minutes to reach S. So P to S, the total time will be 60 minutes. If somebody has gotten into the bus at Q, Q to R will take 15 minutes, R to S will take another 15 minutes, so the total is 30 minutes. S to T will take another 15 minutes, so the total is 45 minutes. But T to U will take 30 minutes, so it will take 1 hour 15 minutes. There is no stop at exactly 60 minutes. So somebody who has gotten into the bus at Q, you will not have any of these guys who will get off the bus exactly after 60 minutes. So this will be 0. This is not possible. If you're looking at R to S is 15 minutes, S to T is another 15 minutes, so the total is 30 minutes, and T to U is again 30 minutes, so the total is 60. So R to S is another 60 minutes. These are the only two possibilities. So somebody who has gotten in at P should get down at S, and somebody who has gotten in at R should get down at, this is U, should get down at U. These are the only two possibilities for the total time taken by these guys to be exactly 60 minutes. There is no other possibility. So what we are trying to do is we will try to maximize both of these cases. So the number of people who have gotten at P who can get down at S, we will try to maximize this, and the number of people who have gotten in at R, we will try to maximize how many of them can actually get on at U, so that we can maximize the number of passengers who have traveled for exactly 60 minutes. So again, we'll do the same thing that we have done earlier. When the bus starts at P, you have 30 people, all of them have gotten in at P. Then it reaches Q, of which 15 of them have to get off the bus. So all these 15 have to come from P. So you'll have 15 people who have gotten in at P who are still there in the bus, and you have 20 more people who have just gotten into the bus at Q. So you have 20 over here. The total will be 35. This is the situation of the bus after it just starts from Q. Then it reaches R. Notice that you don't want anybody who has gotten in at P to get off the bus at R. You want them to get off at S. You want all of them as much as possible. You'll try to get them off at S. At R, how many people do you want to get off the bus? You want 20 of them to get off the bus. So you'll make all those 20 to be the people who have gotten into the bus at Q. So you have 15 people who have gotten in at P. All the 20 people who got into the bus at Q, they will get off at R. And you will have 40 more people who have gotten in at R in the bus. So once the bus starts from R, you will have a total of 55 people. 15 of them are from P and 40 are from R. Then the bus will go to S. How many people do you need to get off the bus? You need 35 people to get off the bus. But notice that over here you will get all the 15 people who have gotten into the bus to get off at S, because you want to maximize the number of people who have traveled from P to S, because that will be exactly 60 minutes. So all the people who have traveled from P, that is 15 people, will get off at S. So you still need 20 more people, because the total number of people who have gotten down at S is 35, of which you gotten 15 of them from P. So you need 20 more of them, and those 20 will come from R. So after the bus moves from S, you have 20 people remaining in the bus from R, and the people who have gotten into the bus at S, so that is 30S. Again, notice that you will try to maximize the number of people who have traveled from R to U. You will try to keep these 20 guys to be in the bus for as long as possible, and you will only try to get them off the bus at U. So when the bus starts from S, it has a total of 50 as expected. 20 are from R and 30 are from S. Now the bus reaches T, and you need 40 people to get off the bus. So of the 40, you will make the 30 people from S to get off the bus, because there is no person who has gotten into the bus at S who can travel for 60 minutes. Because S to T is 15 minutes and T to U is 30 minutes. So that maximum that somebody who has gotten into the bus at S can travel is 45 minutes. So out of this 40, you will take 30 from S, but you still need 10 more people. So you will take 10 of the 20 from R to also get off the bus at T. So once the bus starts from T, you will have 10 people from R in the bus, and you will have 30 people who have gotten into the bus at T. So the total number of people in the bus after the bus starts from T is 40, and this bus reaches U. And now all the 10 people who have gotten into the bus at R will also get off, and all the 30 people who have gotten into the bus at T will also get off. So the total people who get off the bus at U is 40. So the number of people who have traveled from R to U will be 10, and the number of people who have traveled from P to S is 15. So the maximum number of people who can travel for exactly 60 minutes is 25. Let us look at the next question. If the passengers who have boarded the bus earlier will exit the bus before the other passengers, then how many passengers have traveled for more than 15 minutes? We'll do the same thing again. We'll note down P, Q, R, S, T. Basically the number of people who have traveled for more than 15 minutes who have gotten into the bus at P. We'll count the number of people who have traveled for more than 15 minutes who have gotten into the bus at Q, and so on. So again, after the bus starts at P, you have 30 people. All of them have gotten into the bus at P. Now the bus reaches Q, and 15 of these people will alight. So this is 15 people are left who have started at P. And the 15 people who have got down, how much time did they travel? They have traveled for 30 minutes already. So all the people who have gotten into the bus at P would have traveled for more than 15 minutes. So this is 30. Now you have 20 people who have gotten into the bus at Q. So once the bus starts from Q, you have 35 people in the bus. Now this bus reaches R, and you need 20 people to get off the bus. Of this 20, the people who have gotten into the bus first will alight from the bus. So that is 15 of them who have gotten into the bus at P will get off, and you will also get off 5 people who have gotten into the bus at Q. So you have 15 people who have gotten into the bus at Q, and R you have 40 people who have gotten into the bus at R. The total is 55. Now these 15 people who have gotten into the bus at Q, they have already traveled 15 minutes. So at whatever stop they get off later on, they would have already traveled for more than 15 minutes. And the 5 people who have traveled from Q to R, they have traveled for exactly 15 minutes, and so they can't be counted. So the number of people who have gotten into the bus at Q and they have traveled for more than 15 minutes is 15. Now the bus starts from R and it reaches S. That is, it has again traveled for another 15 minutes. And how many people get off the bus? 35 people will get off the bus. Of these 35 people, again the 15 people who have gotten into the bus at Q will get off because they have gotten into the bus early. You need 20 more people, and those 20 people you will take from the group of people who have gotten into the bus at R. So now you have 20 people from R and you have 30 new people from S. Notice that these 20 people again also will travel for more than 15 minutes, because from R to S itself is 15 minutes. At whatever stop they get down from the bus later on, they would have traveled for more than 15 minutes. So this is again 20. Now the bus starts from S and it reaches T. How many people should get down from the bus? You need 40 people to get down from the bus. Of this 40, the 20 from R will get down, and you need 20 more. So out of the 30 from S, 20 will get down at T, and S to T is only 15 minutes, and you have 10 people who are left in the bus. These guys have started from S, and you will get 30 more people from T. So the 10 from S will travel for more than 15 minutes. So this is again 10. And now the bus reaches U and you need all 40 people to get off. So all these 10 and all this 30 will also get off. Notice that the 30 people from T who got into the bus at T and got off the bus at U, they have traveled for 30 minutes. So these guys also have traveled for more than 15 minutes. So this is 30. So 30 people who got into the bus at P, 15 people who got into the bus at Q, 20 people who got into the bus at R, 10 people who got into the bus at S, and 30 people who got into the bus at T have traveled for more than 15 minutes. So the total will be 30 plus 15 is 45, 45 plus 20 is 65, plus 10 is 75, plus 30 is 105. Let us look at the last question. In this question, you want to maximize the number of passengers who would have traveled for exactly 45 minutes. So we'll do the same thing that we have done a couple of questions earlier. If somebody has gotten into the bus at P and if he travels till Q, that is 30 minutes. But if he travels till R, that is 30 plus 15, so that is 45 minutes. So P to R, the distance will take 45 minutes. Similarly, if somebody has gotten into the bus at Q and he travels till R, that is 15, till S is 30, till T is plus 15, so that is 45. So Q to T is also 45 minutes. If somebody has gotten in at R, R to S is 15, R to T is 30, and R to U is 1 hour. So somebody who has gotten into the bus at R will not get off the bus after exactly 45 minutes. He'll either get down after 30 minutes at T or he'll get down after 60 minutes at U. So from R you have no passengers who will get off after exactly 45 minutes. Somebody who has gotten into the bus at S can get off at U because S to T is 15 and T to U is 30. So this is also 45 minutes. So you have three possibilities which you want to maximize. You want to maximize the number of people who got into the bus at P and who get off at R, or you want to maximize the number of people who got into the bus at Q and then get off at T. And the third option is the number of people who got into the bus at S and who will get off at U. These are the three groups of people you want to maximize, and whatever is the total will be the answer for this question. So we'll do the same thing that we have done earlier. The bus starts from P and you have 30 people. All of them have gotten into the bus at P. Then the bus reaches Q. Here you don't have an option. You want 15 people to get off the bus and all these 15 people have to be from P. So you have 15 people left who are from P and you are getting 20 people from Q. Then the bus reaches R. Now you want to maximize the P to R passengers. So you need 20 people to get off from the bus. Of these 20 people, you will take 15 people from P and 5 people from Q. All the 15 from P will get off, but you still need 5 more people. So you will have 15 people who are left from Q, and now 40 people have gotten into the bus at R. So the number of people who would have traveled from P to R, this is 15. Next, the bus starts from R and it goes to S. Here you don't want people who have gotten into the bus at Q to get off at S, because if you remember correctly, you want to maximize Q to T. And how many people have to get off the bus at S? You want 35 people to get off the bus. Remember what we said earlier, that there is a passenger who has gotten into the bus at R will definitely not travel for exactly 45 minutes. So we'll make use of this 40 passengers. So we'll make 35 of them to get off the bus at S. So you'll have 15 people from Q, 5 people from R, and 30 new people who have entered the bus at S to be in the bus after the bus starts from S. Now the bus reaches T and you want 40 people to get down from the bus. Of this 40, you want to make all these 15 guys to get off the bus at T. So here you are going to get another 15. You need 25 more people to get off the bus at T. Of these 25, you will take the 5 people who have gotten into the bus at R, because all the people who have gotten into the bus at R are not going to contribute for your total. So you have gotten 20 people off the bus at T. You still need 20 more people. So you have no choice but to take 20 people who have gotten into the bus at S. So now you have 10 people who have gotten into the bus at S, and you have 30 people who have gotten into the bus at T after the bus starts from T. Again, the total is 40. Now the bus reaches U. You need 40 people to get off the bus. This is basically all the people who are in the bus. So that is 10 people from S and 30 people from T. So 10 people from S will reach U. So S to U is also 10. So the total number of people who have traveled for exactly 45 minutes will be 15 plus 15 plus 10, that is equal to 40.
Google search Krakow free CAT mocks. Click on the first link. You can attempt 3 latest CAT mocks in the actual exam interface. After completing the test, you get detailed solutions, analysis, percentile along with your scorecard to gauge your all-India performance. Click on the solution to get video solutions from our expert faculty.
In this question, it is given that there is a GST council which was formed on 1st of March 2015 and it has 4 departments. The 4 departments are finance, technology, operational and strategy, and there are members in each one of them. The total number of members of the council is 18, which is spread across the 4 departments. It is also given that the number of members in each of these departments is an arithmetic progression with a common difference of 1. So it is not given what is the order in which these are split, but it is given that they are an arithmetic progression and the total of the arithmetic progression is 18. So you can easily calculate the individual members. So for example, if the 4 numbers are A plus 1, A plus 2 and A plus 3, the sum of these 4 numbers is given as 18, or 4A plus 6 is equal to 18, or A is equal to 3. So the number of members in each of these departments are 3, 4, 5 and 6. So at the end of every year, there might be some person who might leave, there might be some person who might join, or there might be no changes at all. It is also given that every person who retires is age 65 and every person who joins is age 32. Now this is the information that is given. There are 2 additional points that were given, which is that only strategy and planning, that is the 4th department, did not have any member join it across the 4 years. You can see that the age has dropped once, but other than that there has been no joining. Similarly, it is also given that at any particular in any particular year, all the changes happen only on July 1st, and at max 1 person has joined or 1 person has left. So at max there is a change of 1. So now if you look at the questions that were asked, you can see that each of the questions are with respect to how many people were there in each of the departments during any particular year. So if you are able to figure out which department had how many members at the start, and based on the change in the average age, if you can figure out whether a person has joined or retired, then we can answer all the 4 questions. So let us first draw a table so that we can keep track of all the informations that we have. This will look at the year. This is 2015, this is 2016, 2017 and 2018. These are the 4 years. 2015, 2016, 2017 and 2018. The first row will look at the total number of employees in finance department. The second row will look at the total number of employees in technology department. The third row will look at the total number of members in operations. And the fourth row will look at the total number of members in the strategy and planning department. If you are able to fill this table out, we will solve all the questions. This table will basically keep track of how many people were there in each of the particular years. This is 2015, this is 2016, this is as far as July 1st of the year is concerned. This is 2017 and this is 2018. The first department is finance, the second one is technology, the third one is operations, and the fourth one is strategy and planning. Now if you look at the information that is given in the additional clues, it is mentioned that strategy and planning is the only department in which no new member has joined during the course of the 4 years. If there are no changes, you would expect that the average age of the entire department increases by 1. That is, suppose in case of strategy and planning, if there are like say 6 members whose average age was 48 in 2015, if there are no changes in 2016, the average age of everyone will increase by 1 and it will become 49, like we have seen. Now from 2016 to 2017, the average age has decreased. It has gone down from 49 to 45, and we know that no person has joined this department. So this would imply that 1 person has retired from this department after 2016. Normally, if that person hadn't retired, suppose there are n members in strategy and planning, their average age would have been 50 and their total age would have been 50 into n. That is because their average age in 2016 was 49, 1 year would have passed and the average age of the department would increase by 1, and we are assuming that there are n members. So this is 50n, this is the total age of all the members in the department. This is equal to 45 into n minus 1, because we know that one person has retired and he is age 65. So the total age will be 45 into n minus 1 plus the remaining member who is 65. If you solve this equation, you will be able to find out the value of n. So this will be that 5n, that is 50n minus 45n, is equal to 65 minus 45, that is 20, or n is equal to 4. So initially in 2016 there are 4 members and one person has retired, so this became 3 members. Similarly, even in 2015 there were 4 members, because you could see that the average age increased by 1, which means that there is no change in the personnel. So in 2015 there were 4, in 2016 there were 4, in 2017 they became 3. Between 2017 and 2018 again the average age increased exactly by 1, which would suggest that there are no changes. So S&P again had 3 members in 2018. So we were able to fill out 1 row. We will continue to do the same for all the 4 rows, and then we can go ahead and solve the questions. The next one that you can see is the finance again has a very simple transition. That is, there is 1 year difference in the average age between 2015 and 2016, which would suggest there are no changes. From 2016 to 2017 again there is 1 change. So again there is no change in personnel. In 2017 to 2018 there is a drop. So again it would suggest 2 things. Either that one person has retired or one person has joined. If one person has retired, it would imply that in finance across the 4 years no new person has joined, because in 2015 to 16 there was no change in personnel. In 2016 to 17 again there is no change in personnel. If in 2017 to 18 again only one person retired and no person joined, it would imply that there is no change in personnel in finance. But we know that the only department where no new member joined is S&P. So we know that the drop in average age in finance from 2017 to 2018 is because one new member joined. So again let us assume that the number of people in finance in 2017 is n. So their average age is 52 in 2017. After 1 year pass it would become 53n. Now to 53n you add 32, which is the age of the new person who joined. This will equal the new average age, that is 50, into the new total number of personnel, which is n plus 1. If you solve this equation, you will be able to find out the value of n. You can solve this simply. So this becomes 3n, that is 53n minus 50n, is equal to 50 minus 32, that is 18, or n is equal to 6. So the number of people in 2017 is 6. One new person joined, so it becomes 7. Similarly, in finance there was no change from 2015 to 16 or 16 to 17. So the number will remain the same, which is 6, 6 and 6. Now let us go to the next question, next row, which is for say technology. In technology, the average age was 53 in 2015. This became 48.5. This has reduced. So this can be either because one person has joined or one person has retired. Again, let us assume that case 1 is that one person has retired. Case 2 is that one person has joined. Now let us see how that will work. The average age is 53. So their age at the end of 1 year should have been 54. So 54n is equal to the new average age, that is 48.5 into n minus 1 plus 65. This would imply that 54n minus 48.5n is 5.5n is equal to 65 minus 48.5, that is 16.5, or n is equal to 3. So if somebody has retired, the average age would decrease from 53 to 48.5. Let us see what the case would be if somebody has joined. Again, let us assume that the initial number is n. So 53 would have normally become 54. So 54n plus a new person has joined, so that is 32, is equal to 48.5 into the new number of members, that is n plus 1. This would imply that again 5.5n, that is 54n minus 48.5n, is equal to 48.5 minus 32 is equal to 16.5, or n is equal to 3. So in this case, both the cases n is equal to 3, and we are not able to figure out if somebody has joined or somebody has left. But in either of the cases, the number of people is 3 in technology. So this would be 3, which would imply that in operations the number of people is 5, because we know that across the 4 departments it is 3, 4, 5 and 6. Now let us first try to figure out whether somebody has joined or somebody has retired, in technology. So in the next year, the age has decreased from 48.5 to 46. So if you look at again two cases, the age was 48.5, this became 46. Again we look at if somebody has retired or somebody has joined. If somebody has retired, the average age should have been 45.5 into n into 3 actually. We always know that, no, we don't know the number of people actually in 2016. Because in the earlier case, if somebody has retired from 2015 to 2016, the number of people would decrease from 3 to 2. We just know that the number of people in 2015 in technology is 3. But if somebody has joined technology, the number would increase from n is equal to 3, which is initially, to n is equal to 4. So we'll have to try to figure out what is the value of n. Again, coming back to 2016, we know that in 2016 the average age is 48.5, and in 2017 the average age has decreased to 46. So again, let us consider two cases. Let us consider the first case in which somebody has joined the firm in 2017, early 2017. So 48.5 is the average age in 2016. Normally it should have become 49.5. So 49.5n is equal to the new average age, that is 46 into n minus 1 plus 65. If you solve this, you are going to get 3.5n is equal to 19. That is 65 minus 46, or n is equal to 19 by 3.5. Now this is not a natural number, so this case can be ignored because n has to always be a natural number. The next case is that somebody has joined them. So the average age is 48.5 in 2016. In a normal scenario, it would become 49.5. So this is 49.5n. But one new person has joined, so that is plus 32. This is equal to the new average age, that is 46, into the new number of people, that is n plus 1. If you solve this, you are going to get 3.5n, that is 49.5 minus 46n, is equal to 46 minus 32, that is 14, or n is equal to 4. So we know that in 2016 n is equal to 4 and a new person has joined, so this becomes n is equal to 5. This would also suggest that in the earlier year somebody did not retire, because if somebody had retired, n would have decreased from 3 to 2, but we know that n has increased from 3 to 4. So the number of people in 2016 is 4, the number of people in 2017 will become 5 because one person has joined. In 2015 it is 3. Now we can go ahead and fill the table. In technology, from 2017 to 2018, the average change is 1 year, that is from 46 to 47, which would imply that no new person has either joined or left. So this would remain 5. In operations, the age has decreased from 43 in 2015 to 42 in 2016. In operations, that is the only row that is remaining. In 2015, initially there were 5 members and the average age was 43. In 2016, this has decreased to 42. So we know that initially the average age is 43 and there were 5 members. At the end of 1 year, the average age would become 44 and there were 5 members. So the total is 44 into 5, this is equal to 220. The average age at the start of 2016 is 42. So either one person has retired or one person has joined. If one person has retired, the number of people would become 4. So the total will become 42 into 4, this is equal to 168. And the difference, that is the age of the person who has left the team, would be 220 minus 168, which is 52. But no person would leave it at 52. We know that if a person has left, his age has to be 65. Now let us consider the case in which the average age is 42, but one person has joined. So the total number of people is 6. So the total age is 42 into 6, which is 252. So the age of the person who has joined is 252 minus 220, which is 32. This tallies with what we expect, that if a new person has joined, his age has to be 32. So in 2016, the number of people is 6. And the average age in 2017, this has been removed, is 38.6. So for operations in 2016, the average age is 42 and there are 6 people. In 2017, the average age becomes 38.6. We'll do the same thing that we have done earlier. The average age is 42. At the end of 1 year, without any change in personnel, the average age would become 43, and their total will become 43 into 6. This is equal to 258. Now, if one person has left, if one person has retired, then the total will decrease by 65, and the personnel also will decrease from 6 to 5. So 258 minus 65 is 193. And because one person has left, the total number of people remaining is 5. So 193 by 5 is 38.6. This tallies. Now let us assume that one person has actually joined and check if the average age will again equal 38.6. The total of the 6 people who are left is 258. If suppose a new person has joined whose age is 32, the total age will become 258 plus 32. This is equal to 290, and the number of people would become 7. So the average age would be something like 41.4, something like 41.5. This is obviously not equal to 38.6. So the only thing that we can infer is that one person has retired from operations at the end of 2016. So there are 5 people remaining. From 2017, the average age was 38.6. It becomes 39.6. That is an increase of 1. So there is no change in personnel. Average age of 1 is expected after 1 year. So the number of people in operations is again 5. So we have been able to fill out the table. Now let us go and answer the questions. How many members were there in finance department on 1st July of 2018? In finance department in 1st July of 2018, there are 7 members, because after July 1st, the number of members is 7. So even in November, the number of person will be 7. In which of the following years a new member joined the operations team? Operations team is this. A new member has joined them in 2016. In 2015 there were 5, in 2016 there were 6. So one person has joined on 30th June of 2016 or 1st July of 2016. So the correct answer is 2016. One person has left on in 2017 and no one joined in 2018. How many members were there in strategy and planning department on 1st August of 2017? So in 2017 there are 3 members. There were 3 members in from 1st July of 2017. So even on 1st August of 2017, the number of members would remain 3. The last question is, what is the difference in the number of members in the GST Council on 1st July of 2016? This is the total number of members. This is 6 plus 4 plus 6 plus 4. This is 20. And in 1st July of 2018, the number is 7 plus 5, 12. 12 plus 5 is 17. 17 plus 3 is 20. So the difference is 0. There is no difference in the total number of members. So if you see this question, one of the first things that you should do is look at all the questions. If you read the information that is given, and once you look at the questions, you know what exactly is expected of you. So once you know that, you would immediately draw the table that we have drawn and try to find out how many people were there in each of the departments across the 4 years. Once you solve them step by step, you will be able to easily answer all the questions correctly. In this question, we are told that Amar bought a rectangular plot of land and he divided it into 3 pieces. In each of the 3 pieces, he has an option to plant either rice or wheat or maize. He can plant more than one crop in any of these fields. We have been given some information about the yield per square meter and the price of each of the crop per kg, and we are required to help Amar in making a decision. So let us look at a table. Let us draw a table where we'll have each of the information that is given. So we'll have 4 columns and we will have, say, 4 rows. So this is for rice, this is for wheat, this is for maize. The yield per square meter, you can look at it as yield per square meter, for each is given. For rice it is 10 kg, for wheat it is 12 kg, and for maize it is 9 kg. And the price per kg for all of them is given as 8, 6 and 9. So this is 8, this is 6 and this is 9. So the total revenue that they'll get per square meter, revenue per square meter for each of them is 10 into 8, that is 80, 12 into 6, that is 72, and 9 into 9, that is 81. But per square meter there is also some costs involved. So the cost per square meter for each of the crops is 12, 3 and 9. So this is 12, this is 3 and 9. So the essential profit per square meter for each of these 3 crops can be found out. This is equal to 80 minus 12, which is 68, 72 minus 3, which is 69, and 81 minus 9, which is 72. So this is basically the information that we know. Let us go ahead and answer the questions that follow. If instead of cultivating 3 crops all at once, Amar decides to practice crop cultivation and he plants rice in summer, wheat in winter, and maize during spring, what will be the ratio of the profits realized during summer, winter, and spring? So the ratio of the profits realized during summer, winter, and spring will be the profit for rice, wheat, and maize. So the answer will be 68. The ratio will be 68 is to 69 is to 72. Let us look at the next question. Which crop has the lowest profit per kg sold? Rice makes 68 rupees profit for 10 kg sold. So for rice, the total profit per square meter is 68 and the total yield per square meter is 10. So the profit per kg of rice is 68 by 10, which is 6.8. The profit per kg of wheat is 69 by 12, which is equal to 23 by 4, which is 5.75. And for maize is 72 divided by 9, which is equal to 8 per kg. This is the profit per kg. So it is lowest for wheat. So the correct answer will be wheat. If the size of Amar's plot is 600 meters, so he has a total of 600 square meters. And each crop is to be cultivated in at least 100 square meters. So he has rice, he has wheat, and he has maize. He has to dedicate 600 square meters to each one of them, such that each one of them has at least greater than or equal to 100 square meters and definitely less than or equal to 300 square meters. What is the maximum profit that can be realized by Amar? The profit per square meter is maximum for maize. It is 72. So we'll give maize 300 square meters, which is the maximum allowed, and the total profit it will make is 300 into 72. Then you will be left with 600 minus 300, which is another 300. The next highest is wheat. So we'll give whatever is possible to wheat, but you should also give at least 100 to rice, because all 3 of them should have at least 100. So we'll give 100 to rice and the remaining 200 we'll give to wheat, because the profit of wheat is greater than that of rice, profit per square meter. So this will be 200 into 69 plus 100 into 68. 100 into 68. This will be the total profit. You can take 100 common. This will be equal to 68 plus 69 into 2, which is 138, plus 72 into 3, which is 216. This is equal to 100 into what is 68 plus 138, that is equal to 206 plus 216, which is equal to 42200. So the total maximum profit that can be realized is 42,200 rupees. Now let us look at the last question. Amar decides to cultivate a crop and hoard it so that he can obtain the maximum profit. The prices of rice, wheat, and maize, they have become, the price has become 10, 8 and 12. But to store for 1 year, it costs them per kg. Rice cost, this is the price, and the cost is 2, 3 and 6. So basically the effective price that they get at the end of 1 year per kg, let us call it effective price, for each of these 3 crops will be 10 minus 2, which is 8, 8 minus 3, which is equal to 5, and 12 minus 5, which is equal to 6 per kg. This is the price that they get per kg. But how much profit he gets will depend on the yield per square meter, because if he is selling 1 kg of rice, he is making 8 rupees. If he is selling 1 kg of wheat, he is making 5 rupees. If he is selling 1 kg of maize, he is making 6 rupees. But how many kgs of each of these crops can he sell is again depend on the table that we have. If he is selling rice, he can sell 10 kgs per square meter. If he is selling wheat, he can sell 12 kgs per square meter. And if he is selling maize, he can sell 9 kgs per square meter. Or the total amount of money that he can make per square meter will be equal to 8 into 10, that is 80, 5 into 12, that is 60, or 6 into 9, this is 54. But again, for each of these crops, there is also a cost per square meter, which is given in the table. This is the cost per square meter for each of the crops. This is 12, 3 and 9. So what is the effective money that he makes per square meter for each of the crop? This will be 80 minus 12, that is 68, 60 minus 3, that is 57, and 54 minus 9, that is 45. So amongst the three of them, the amount of money that he makes, effective profit per square meter, is highest for rice, that is equal to 68. So he should be cultivating rice the next year. In this question, we are told that there is a sports event in which 6 teams A, B, C, D, E and F participate, and they play against each other once. But the tournament is divided into 2 stages, in stage 1 and stage 2. In stage 1, 3 matches happen for each team, and in stage 2, 2 matches happen for each team. We are given some clues about who won against whom in stage 1 and who won against whom in stage 2, and we are required to find out the results of each of the matches. So let us get started. Let us draw the tables for stage 1, and we'll do the same for even stage 2. We'll go through the clues and try to identify. So this is for stage 1. We will draw 3 columns. This is the name of the first column will be the name of the team, and the second column will be all the teams it has won against, and the third column will be all the teams it has lost against. So the first row will be for A, the second row will be for B, the third row will be for C, the fourth row will be for D, the fifth row will be for E, and the last row will be for F. This is stage 1, and we'll do the same even for stage 2. Again we'll draw 6 rows. This is for A, this is for B, this is for C, this is for D, this is for E, and we'll come down, and this is for F. This is A. This is A, B, C, D, E and F. Now this is the name of the team, this is who they won against, and this is who they lost against. So because there are 3 matches that are played by each of the teams in the first stage, the sum of all the teams that are in the one column and all the teams that are in the last column for each of the 6 teams will be exactly 3 in the first stage. And in the second stage, in stage 2, the sum of all the teams in the one column plus sum of all the teams in the last column will be 2 for all the teams, because the number of matches that are played in the second stage is 2. So let us go through all the clues that are given. We are told that one team has won all the 3 matches. So one team has W, W, W in all the 3 matches that it has played in stage 1. There are 2 teams which lost all the matches. So there are 2 teams, that is 2 and 3, who lost all the 3 matches. We need to identify who these teams are. We are told that D lost to A but won against C and F. So D won against C and F, and it lost against A. So this would imply that A won against D, and C lost to D, and F lost to D. So we have identified all the 3 matches that D has played in the first stage. Similarly, E lost to B. This would imply that B won against E, but E won against C and F. So E also won against C and F. So C and F have lost even to team E. B lost at least one match. So there is at least one match in the lost column for B. this would immediately tell you that all the teams other than A have lost at least one match. So the team which won all the 3 games is A. Similarly, other than C and F, all the teams have at least won one match. This would imply that the teams that have lost all the 3 matches in the first row, in the first round, are C and F. So we have been able to identify all the 3 teams that we were able to identify the 3 games played by both D and E. Now let us we are also given one clue that B has lost at least one match. Now the one match that B has lost, if we identify, it didn't play that against D or E, because we have identified all the 3 games that are played by D and E. Now we know that C and F have lost all the matches in the first round. So the only possibility for the loss for B is when it played against A. So this would imply that the loss for B is against A. This would also imply that A has won against B. Now we are also told the last clue. The last clue is that F did not play against the top team of stage 1. If you are looking at F, we have identified 2 games that it has played against. That is against D and E. We need to identify who it played against the third round. Now if we are told that F did not play against the top team is A. So the third game of F is not against D or E. It is also not against A. We also know that it can't be against C, because if it had played against C, one of the 2 would have won. So it can be either C which won or F which won, but we know that both of them lost all the 3 matches. So the only possibility is that F played against B and lost that game. That is, B played against F and won that game. And the only possible remaining matchup, because we have been able to identify all the 3 matchups of B, D, E and F, is the matchup between A and C. And because A won all its 3 games and C lost all its 3 games in the stage 1, it would imply that in the lost column for C we will put A, and in the one column for A we will put C. So now we have been able to identify all the wins and losses and all the teams that each of these individual teams have played against in stage 1. We'll do the same thing even for stage 2. In stage 2, the leader of stage 1 lost the next 2 matches. The leader of stage 1 is team A, and it lost the remaining 2 matches. Now in stage 1 it played against D, B and C. The only 2 teams it did not play against in stage 1 are E and F. Now we are told that it lost both of these matches, so we'll put E and F in the lost column for team A. Similarly, in the one column for team E we'll put A, and we'll do the same even for F. One of the 2 teams which was at the bottom of stage 1, the 2 teams which are at the bottom after stage 1 are C and F. They lost all their 3 matches. One of these 2 teams won both its matches in stage 2, while the other lost both its matches. We know that F has already beaten A. So it would imply that F won both its second matches, because F cannot suffer losses in both the matches, because we know that it has already beaten A. This would imply that C has lost both its matches in stage 2. Now if you're looking at C, it already played against A, E and D in stage 1. The only teams which are remaining for C are B and F. So it lost both these matches. So B won against C and C lost against B and F. This would mean that F won against A and C. Now one more team lost both its matches. If you identify the teams for whom we have been able to identify all the 2 matches in stage 2, they are A, C and F. The teams for which we are not able to identify are B, D and E. But we are told that one more team lost both its matches. That team cannot be B, that team cannot be A, because we know for sure that they won at least one match in stage 2. That is, B won against C and E won against A. So the only other team which lost both its matches is D. And D played against A, C and F in stage 1. So the 2 matches that D played and lost in stage 2 will be against B and E. This is for D. So D lost against B and D lost against E. So we can add the same even in the winners column for E and B. So now we have been able to identify all the matches that were played in stage 2 and won or lost for each of these individual teams. Now we can go ahead and solve the questions. The team that defeated the leader of the two teams that defeated the leader of stage 1 are the two teams that defeated the leader of stage 1 are E and F. So the correct answer is B. The only team that won both matches in stage 2 are, we are looking for the teams which won both the matches in stage 2. This will be B, which won against C and D, E, which won against A and D, and F, which won against A and C. So it is B, E and F, which is option D. Let us go to the next. The teams that won exactly 2 matches in the event are. So overall, including both stage 1 and stage 2, we are looking for teams which won exactly 2 matches. If you are looking at A, B, C, D, E and F, we will calculate the total number of matches they won in stage 1 and stage 2. A won 3 in stage 1 and 0 in stage 2. B won 2 in stage 1 and 2 in stage 2. C won 0 in stage 1 and 0 in stage 2. D won 2 in stage 1 and 0 in stage 2. E won 2 in stage 1 and 2 in stage 2. While F won 0 in stage 1 and 2 in stage 2. So the total for A is 3, the total for B is 4, total for C is 0, total for D is 2, total for E is 4 and total for F is 2. So the two teams which won exactly 2 overall are D and F, which is option E. Now let us go to the last. The teams with the most win in the event are, we have just calculated the most wins. B won 4 and E won 4. So the correct answer will be B and E. That is option E. In this question, we are told that there are 5 teams A, B, C, D and E. They participate in a game tournament. The game tournament has 4 rounds. And in each of the rounds, there are 22 games. If a team wins a game, it gets 5 points. So the number of points at stake in each of the rounds is 22 into 5, that is 110. Now after the first round, whichever team has got the lowest number of points in the first round is eliminated. So only 4 teams progress to the second round. In the second round, again the 22 games are played and whoever gets the lowest number of points is eliminated. So in the third round, only 3 teams play. And in the fourth round, only 2 teams play, and whoever gets the highest number of points in the fourth round is the winner. Now we had to figure out, there have been some clues that were given to us, and using this we had to figure out how many points each of the teams have scored. So to do that, let us first draw a table. So the number of rows will be 5 and the number of columns will be 6. So this is A, B, C, and this is D and E, if you are able to figure out. And this is the first round, this is the second round, this is the third round, and this is the fourth round. This is the number of points that each one of them has scored. So let us look at the clues that are given to us. The clues that are given to us is that only one team scored the least number of points in any round. So in any round, you know that the number of points that whichever team is getting eliminated has scored the lowest number of points, and there is no tie over there. Whichever team has got the lowest number of points is unique in each of the 4 rounds. Secondly, the only team that scored the same number of points in 2 or more rounds is team A. So this means that if across any 2 rounds, the only team which has scored the same number of points is team A. Every other team has scored different number of points in different rounds. In exactly 2 rounds, the scores of each of the teams was distinct. So out of 4 rounds, in 2 rounds, the scores of all the teams which are playing the rounds were distinct. And in 2 of the rounds, the scores of the teams which are playing were not distinct. And in fact, in those 2 rounds where the scores were not distinct, it is also given that the scores of exactly 2 teams were equal in those non-distinct rounds, and the scores of every other team was distinct. Finally, we are also given one more clue, that if a team wins a certain game during a certain round, then it continues to win that game till it gets eliminated. So for example, in the first round, if say A won 3 games out of 22, B won say 4 games out of 22, C won say 5 games, D 3, 4 and 5 is 12, D won say 4 and E won say another 5. So that this say totals up to 22. Now in the first round then A gets eliminated and these guys continue playing. But in the second round they continue to win the 4 games, 5 games, 4 games and 5 games that they have respectively won in the first round, and the only difference is the games that A has won in the first round. Now these 3 games will be distributed. Whoever wins those 3 games will get those extra points. But the games that these guys have won in the first round, they will continue to win them till they get eliminated. What this again implies is that the scores of each of the players is non-decreasing. So across different rounds, the scores will either keep on increasing or they will stay constant. In fact, if you go through the clues closely, as there is only one team which gets the same number of points in 2 rounds, it implies that only A has 2 rounds where it gets equal points and the scores of every other team keep on increasing after every round. Because they have never, once they win a game, they are not going to lose it. So the number of points that they will get in the subsequent round will be greater than or equal to the points that they have got in this round, unless they are eliminated. In case they are eliminated, then they are out of the game. But if they are not eliminated, in the next round they will keep on winning at least as many games as they have won now. And because it is also given that there is only one team which got the same number of points in 2 rounds, it implies that for all the other teams which are not eliminated, the scores keep on strictly increasing as and when the rounds progress. This is basically the information that is given to us. We are also given one more information that the cumulative scores by the 5 teams is 40, 75, 15, 155 and 155. What we will do first is we will divide each of these scores by 5 so that we know the total number of games that are won by the 5 teams. So A has won 8 games, B has won 15 games, C has won 3 games and D have won 31 games each. This is the number of games that each one of them has won. Now we have to distribute them across the 4 rounds. So the total number of games that are played is 4 into 22, which is equal to 88. If you really count the total over here, 8 plus 15 is 23, 23 plus 3 is 26, 26 plus 31 plus 31 is 62. So 26 plus 62 is 88. As you can see, the total number of games won by all the 5 of them is 88. So that is matching. So this is like a cursory check that we have done. Now let us get started. In the first round, who is the person who has gotten eliminated? As you can see, the least number of games won are by C. So it is quite clear that C got eliminated in the first round. This would imply that the second highest number of games won are by A. So A has won at least 4 games in the first round, because he has to win more than C, otherwise he would have been eliminated in the first round. So if A has won at least 4 in the first round, because the total number of games won by A is 8, the only way this is possible is if he has won 4 even in the second round, because we know that the number of games that A has won in the second round has to be at least greater than or equal to the number of games he has won in the first round. So now we know that A got eliminated in the second round, C got eliminated in the first round. Now what is the number of games that B could have won in the first round? He could have at least won 4, because he has to win more than 3. Now because the only person who got the same number of points in any 2 rounds is A, as given in one of the clues, this would imply that B's number of games that he has won, if he is calling it score, in the second round has to be at least 5. And he is not eliminated because it has to increase. Therefore, the number of the score in the third round has to be at least 6, because again it has to be strictly greater than 5. If you count 4 plus 5 plus 6, this is equal to 15. This is the total number of games that B has won. So this will be 4, 5 and 6. C did not play in any of the consecutive rounds. A also did not play in any of the consecutive rounds. In the third round, B got eliminated and B also did not play in any of the consecutive rounds. Now you know that the only 2 persons that are left which have to be distributed are D and D. And to be really honest, you don't really know any way to differentiate between D and D. Both of them have won the same number of points and there is no additional clue that gives us which distinguishes us from D or E. So what we'll do is we will remove D and E over here. We'll just consider both of them to be 2 different persons and we'll try to figure out what the distribution can be. We can't say for sure that okay, this column is D or this column is E, but we can kind of say what the distribution will be. That is what each of the 2 persons have scored, but we will not be able to assign the scores to any of the particular person, whether it can be either D or it can either be E. So for example, if you look at the first round, the total number of games won by A, B and C is 4 plus 4 plus 3, that is equal to 4 plus 4 is 8 plus 3 is 11. So how many games have to be distributed between D and D, that is the last two columns? It will be 22 minus 11, which is equal to 11. Now when it is 22 minus 11, it is 11. What are the different ways in which you can distribute the two scores? Can it be 4 plus 7? It can't be 4 plus 7 because we know that in none of the rounds did 3 people get the same score. Because if somebody has scored out of D and D, one of them, if they have scored 4, it would imply that A, B and that person have scored 4. All of them have got the same number of points, which is not allowed. So 4 and 7 is not possible. So the only other way out is if it is 5 and 6. Again, we don't know who has scored 5 and who has scored 6, but we know that one of D and D has scored 5 and the other person has scored 6. Now what will their scores be in the next round? It has to be at least respectively 6 and 7, because even for both of them the scores have to increase strictly. Then what will the total be? 4 plus 5 is 9 and 6 plus 7 is 22. So you know that both of them have to score 6 and 7, and you also know that they can't score more than 6 and 7. Now that even this is done, if you're looking at the third round, you know that B has scored 6. What are the remaining number of games left? The remaining number of games will be 22 minus 6, which is equal to 16. Now you know that the person who has scored 6 in the second round has to score at least 7, and the person who has scored 7 has to score at least 8. Now 7 plus 8 is 15, so you have one additional game that should be distributed. So the distribution can either be 7 and 9 or it can be 8 and 8. How will you decide whether it is 7 and 9 or whether it is 8 and 8? If you look at one of the clues that is given, we are told that in 2 rounds out of the 4, the scores were definitely distinct. Now you know that in the second round, the scores were 4, 5, 6 and 7, which are distinct. You know that in round 1, the scores were not distinct because A and B got 4 and 4 each. So basically out of the third and fourth round, one round the scores have to be distinct, and in one round the scores should not be distinct. Now in round 4, because there are only 2 teams, and you also know that in every round there is exactly one team which has scored the lowest number of points. So you know that both of the teams which are remaining, that is D and D, cannot score the same number of points in round 4. So this also has to be distinct. This would imply that in round 3 the scores should not be distinct, which would imply that the scores of D and D have to be the same, and so the scores will be 8 and 8. Now how much did they score in the fourth round, in the remaining round? You know that both of them have won a total of 31 games each. So the first team till the third round, the number of games it has won is 5 plus 6, that is 11, plus 8 is 11 plus 8 is 19. So 31 minus 19 is 12. Similarly, the second team has won 6, 7 and 8. So the total will be 21. The total it has won is 31. So this team has won 10 games in the last round. Now again, you don't know whether the fourth team in this column, the fourth column is team D or team E. You also don't know whether the fifth column is team D or team E. But you know that both the columns are for both the teams D and D. You just don't know which one is which. Now that we are done with this, let us go ahead and answer the questions that follow. How many points did team D score in round 3? In round 3, D and E, both of them have won 8 games each. So there is no ambiguity here. The number of points that each of them have won is 8 into 5, which is 40 points. If team D scored 25 points in the first round, then who was the winner of the competition? If team D has won 25 points in the first round, it would imply that the fourth column is team D. And so the winner also will be team D, because team D has won 12 points in the fourth round, which is greater than 12 games in the fourth round, which is greater than 10 games in the fourth round by team E. So if team D has scored 25 points in the first round, the winner of the game will be team D. How many games were won by more than one team over the 4 rounds? The total number of games that are there is 22. Out of these 22 games, the number of games won by C in the first round is 3. So these were won by other people in the next rounds. You don't know who has won, but you know that somebody other than C has won. Similarly, in the first round, the number of games won by B is 4. These 4 games were won by B in the first, second and third rounds. But in the fourth round, one of D or E has won this 4 games because only those 2 were remaining. Similarly, A has won 4 games in the first round and he has won these 4 games even in the second round. But in the third and fourth round, somebody else has won. So the total number of games that were won by more than one person in the total 22 games is 3 plus 4 plus 4, which is equal to 11. Another way to look at it is that in the first round, D and E have won 5 plus 6, that is 11 games. These 11 games were won by the same person across all the 4 rounds. Every other game was won by a different person. So the total will be 22 minus 11, which is also equal to 11 games. So the answer in this case is 11 games. How many points did B score in round 3? B won 6 games. So the number of points that B scored in round 3 will be 6 into 5, which is equal to 30. In this question, it is given that there are 2 friends, Akshita and Radhika, who are playing a game of dice. So in order to play the game of dice, for every round they have to pay ₹5. And based on the number on the dice, either of them can win, both of them can lose, or one of them can win and one of them can lose, or there can be a break even. So whenever somebody is winning, when they win, they make plus 10 rupees. When they lose, they have to pay an additional minus 10 rupees. And to play any of these rounds, they have to pay fees of ₹5. There is also something called break even. So when you break even, you neither get anything or you lose anything. So break even means they get 0 and they have to pay 0. So in this case, because they have to pay a fees of ₹5 to pay the round, the effective money that they make when they win is plus 10 minus 5, that is plus 5. And when they lose, they have to pay an additional of 10 rupees and the 5 rupees of fees, so it will be minus 15. And when there is a break even, even though they don't have to pay anything extra, because they have to pay the fees to play the round, effectively they are losing minus 5. So based on the table, that is based on the number on the dice, the outcome has been given. So for example, if it is 1, Radhika will win and Akshita will lose. If it is 2, both Radhika and Akshita, both of them will win, and you can find the remaining also. So before we go further, let us first write down how much each one of them will make effectively based on the outcomes. So this is quite simple. This is just putting down whatever has been given already in the table. So this is basically the dice. This is how much Radhika would make, and this is how much Akshita would make. Now the first row is when the die is 1, this is when the die is 2, this is when the die is 3, this is when the die is 4, and this is when the die is 5 and 6. So this is the die number, this is Radhika's amount that she makes effectively, this is Akshita's amount effectively. This is 1, 2, 3, 4, 5 and 6. If it is 1, Radhika will win and Akshita will lose. So for win, they will make plus 5, and for lose, they will lose minus 15. If the die is 2, both of them will win, so both of them will make 5 rupees each. If it is 3, Radhika would lose, so it is minus 15, and Akshita would break even, so it is minus 5. This minus 5 is effectively the playing fees to enter the tournament. When it is 4, both of them will lose, and so it is minus 15 and minus 15. When it is 5, Radhika will break even, so it is minus 5, and Akshita will win, so it is plus 5. And when it is 6, both of them will break even, so it is minus 5 and minus 5. This is basically the effective money that they make by playing the tournament if the die turns out to be as given. Now let us go ahead and try to answer the questions. If both Radhika and Akshita started with the same amount and played 3 rounds, what is the maximum difference between the amounts with them if the number which turned up in each of the rounds is different? So initially both of them had the same money, let us assume that it is M, and they played 3 rounds, and at the end of 3 rounds we have to figure out how much is the difference. So suppose Radhika and Akshita started with M, we should try to maximize the difference, but we also know that the number on the dice in each of the 3 rounds is different. So if you look at the outcome table, we'll first figure out how much is R minus A. That is, if the die is 1, the difference between the total amount that Radhika makes and the total amount that Akshita makes is 5 minus of minus 15, so this will be 20. This is R minus A. In case it is 2, both of them make the same amount of money, so this is 0. In case it is 3, R minus A is minus 10, that is R will lose 10 rupees extra. If it is 4, again it is 0 because the outcome is the same. If it is 5, Radhika will again lose minus 10, and if it is 6, both of them will lose 5 rupees, so it is 0. So in order to maximize the difference, if you want Radhika to make more than Akshita, we have to first pick the die which makes the maximum difference, which is 1. Then you can see that 2, 4 and 6 are 0, which are the next highest. So it can be either of the 2 or 4 or 6. In either of these 3 cases, in the first round Radhika will make 20 more, and in all other options she makes no additional money. So the difference is maximized and this is 20. If you want to make Akshita make much more than Radhika, initially you will have to choose 3 or 5, and the second time it will be the other ones, that is either the die has to be 3 or 5. In both these cases Akshita will make 10 rupees more, and in no other cases will she make more money. So the next third best option for them is either 2 or 4 or 6, in which case it is basically a tie. In which case Akshita will make 10 in the first round, 10 additional money, and 10 additional money in the second round, and 0 in the third round. So the total difference, the total possible maximum difference in either of the cases is 20. So the correct answer is the maximum difference that is possible between the money that Akshita has and Radhika has is 20 at the end of 3 rounds, if the number on the dice is always different in these 3 rounds. Akshita and Radhika started the game with 10 rupees each. So Radhika and Akshita, both of them had 10 rupees each at the start. This is 0. Both of them played all the rounds. Okay. And what is the minimum number of rounds when Radhika would have 40 more than Akshita? Now you want Radhika to have 40 more than Akshita. So you want Radhika to make more money in the rounds. If you see, we have to figure out the minimum number of rounds in which this is possible. If you look at it, there is only one case in which Radhika is making more money than Akshita. Whenever the die is 1, only then will Radhika make more money than Akshita. If the die is 2 or 4 or 6, they make the equal amount of money because the difference is 0. And if the die is 3 or 5, Akshita will make more money than Radhika. Now you don't want that because you want to minimize the number of rounds that are played. So suppose because you want Radhika to make 40 rupees more, why don't we have 2 rounds? In both the rounds the die turns 1 each. That is, in both the first round the die turns up as 1, and even in the second round the die turns up as 1. In that case Radhika will have 40 rupees more than Akshita. But the problem is that both of them have only 10 rupees each. So if in the first round the die turns up as 1, Radhika will get 5 rupees more, but Akshita will lose 15. And if she loses 15, she will have negative money and she will be immediately asked to stop. So there won't be an option for her to make to play the second round and lose more money. So what we have to do first is ensure that both of them get enough money so that we can have 2 ones, and whenever there is a 1, Radhika will gain 20 rupees more than Akshita. So you want the 1 to happen twice, and whenever the die is 1, Akshita is losing 15 rupees. So we have to try to give Akshita some money first, and then the die should turn up 1. So to give both Akshita and Radhika money, we should want the die to be 2. So the first round has to be if you are looking at this is the die, the first round the die has to be 2. Then the money with Radhika will be 15 and the money with Akshita will be 15. In the second round again you want the die to be 2 so that the money with both of them is 20 each. In the third round again you want the die to be 2 so that it becomes 25 and 25. Remember that whenever the die is 1, Akshita will lose 15 rupees. So you would want to ideally first make up the money with Akshita to be 30, and then you would want 2 dice which are 1 each. And the fourth round also you want them to have 2 so that Radhika will have 30 and Akshita will have 30. Now Akshita has enough money, so now we can the die can become 1. So in the 5th round, the die will be 1, in which case Radhika will gain 5 and Akshita will lose 15. So Radhika will have 35 and Akshita will have 15. And at the end of 6th round, again the die should be 1. So that Radhika has 40 and Akshita will lose even this 15 and become 0. In this case, the difference between Radhika and Akshita is 40 and the minimum number of rounds that it takes is 6. Notice that whatever money has been gained by Radhika is only when the die is 1, because that is the only case in which Radhika will make more money than Akshita. So you wanted 2 ones, you wanted the die to come up 1 twice, but before that happens, you wanted Akshita to actually have 30 rupees so that she can sustain losses of minus 15 for 2 rounds. So the answer in this case is 6 rounds. Radhika and Akshita started the game with 10 rupees each. So this is Radhika and this is Akshita. Both of them had 10 rupees each and played for 4 rounds. Total rounds are, there is 1, 2, 3 and 4. These are the rounds. If the sum of the amounts with them at the end of 4 rounds was maximum, you want the money with them to be maximum, the sum. What is the sum of the numbers on the die if the number on each turn was different? So again the numbers on each turn was different. So we'll again do the same thing. We'll, instead of calculating R minus A, we'll calculate R plus A. That is, what is the total amount of money that they make when the die is 1, what is the total amount that they make when the die is 2, and so on. So R plus A when the die is 1 is 5 minus 15, that is minus 10. R plus A. R plus A when the die is 2, that is the total money that both of them will make is 5 plus 5, that is 10. When the die is 3 is minus 20. When the die is 4 is minus 30. When the die is 5 is 0 because Radhika loses 5 and Akshita gains 5. And when the die is 6, it is minus 10. So if you're looking for 4 rounds and you want to maximize the sum of money that they have, the die should ideally be 2 because that is the positive number which is plus 10. Then it should be 5 because here they're at least not losing any money. Then it should be 6 because they are losing only minus 10 in total, that is minus 5 and minus 5. And finally it should be 1 because in this case they are losing minus 10. So if you see, if the die is 1, the total amount that they lost is minus 10. If the die is 2, both of them will gain plus 10. If the die is 3, they lose minus 10. If the die is 4, they lose minus 30. If the die is 5, they lose 0. And if the die is 6, they lose minus 10. So the best possible case is if it is 2, 5, 6, 1. In the first case, they both make 10 rupees in total. In the second case, they lose nothing. In the third case, that is if it is 6, it is minus 10. And in the fourth case also it is minus 10. So both of these are the 4 ways in which it can happen. These are the 4 numbers that can turn up on the dice. And the sum of the numbers is 2 plus 5 plus 6 plus 1. This is 2 plus 5 is 7, plus 6 is 13, plus 1 is 14. So the sum of the numbers has to be 14. In this question it is given that Radhika and Akshita start with rupees 10 each. So Radhika had 10 and Akshita had 10. After playing for 4 rounds, the amount with Radhika is 3 times the amount of with Akshita. So Radhika had 3 times the amount with Akshita. What is the sum of the numbers on the dice at the end of 4 rounds? So as Radhika had 3 times the amount with Akshita, and if you look at the pay table, all the numbers in the pay table are multiples of 5. So the amount with Radhika has to be a multiple of 15. It has to be some 15 into k. Now the maximum amount that Radhika can gain in 1 round is plus 5, and because there are 4 rounds, the total amount of money that Radhika can gain at max has to be 30. That is, Radhika cannot have more than 30 at the end of 4 rounds. So the only possibility is that there is case 1 is that Radhika had 15 rupees at the end of 4 rounds, and case 2 Radhika had 30 rupees at the end of 4 rounds. In the first case, Akshita would have 5, and in the second case Akshita would have 10, which is the amount of money with Radhika divided by 3. Now let us try to see if there is any possibility for Radhika to have 15 at the end of 4 rounds. Radhika initially started with 10 and she ended with 15. So overall, after playing 4 rounds, she gained plus 5. Now if you look at the pay table, the table is 5 minus 15 or minus 5. That is, she is either gaining 5 or she is losing 5 or she is losing 15. Now by distributing these over 4 rounds, you will never get an odd multiple of 5. That is, this is plus 5, which is 5 into 1. If you look at it, this is 5 into 1, this is 5 into minus 1, and this is 5 into minus 3. The multiple is always odd. So if you are adding 4 of these numbers, the final quotient will be an even number. So it has to be 5 into some 2x. So it will be either 10 or minus 10 or minus 20 or something like that, which is an even multiple of 5. It can never be an odd multiple of 5, because you are adding 4 numbers, all of which are odd. When you are adding 4 odd numbers, you are going to get an even number. But you want the difference to be plus 5. That is, you want her money to become 15 from 10. So that is not possible. Now let us look at the next case. The case is that Radhika has 30 rupees and Akshita has 10 rupees. In this case, Radhika has made 20 rupees from 4 rounds and Akshita made 0 from 4 rounds. Now this is possible. This is possible only if Radhika was winning 5 in all the 4 rounds. That is, in the 4 rounds, Radhika made plus 5, plus 5, plus 5 and plus 5. And Akshita made an overall amount of 0. Now when does Radhika always win? Radhika will win if the die is 1 or 2. Only in the case when the die is 1 or 2 will Radhika make plus 5. In all other cases, Radhika is losing some money. Therefore, in all the 4 rounds, the die has to be 1 or 2. But you also want the dice to be spread out in such a manner that Akshita is not making any money cumulatively. Now, if the die is 1, Akshita loses minus 15, and if the die is 2, Akshita will make plus 5. But over 4 rounds, cumulatively, you want Akshita to make no money. So that would happen if 3 of the 4 dice is 2, in which case Akshita will make 15 rupees, and the 4th die is 1, in which case Akshita will lose all her 15 rupees that she gained. But Radhika, on the other hand, will continue to make plus 5 for the 4 rounds. That is, 3 of the 4 rounds have to be 2 and the 4th round has to be 1. So the total sum of the dice will be 3 into 2 plus 1. This is equal to 7. In this question, it is given that there are 3 people, Ajay, Bharat and Charan. They initially had a total of 310 distinct coins with them, and they were distributed in the ratio 2:3:5. So we can easily figure out how many coins each one of them had. The total number of coins is 310. They were with A, B, C, and the ratio is 2:3:5. If you sum them up, it is 2 plus 3 is 5, 5 plus 5 is 10. So the number of coins with Ajay is his ratio 2 by 10, which is the total ratio, into 310, which is equal to 62. Similarly, the total coins with Bharat is his ratio, that is 3 by total ratio into 310, which is equal to 93. Similarly, with Charan, it will be his ratio, that is 5 by 10 into 310. This will equal 155. This is the initial number of coins with each one of them. Now they redistributed their coins amongst themselves such that after redistribution, the ratio is half is to 1/3 is to 1/5. So after redistribution, the ratio is half is to 1/3 is to 1/5. We can use the same method to calculate how much each one of them had, but because these are fractions, it is slightly more complicated to actually calculate. So what we'll do is we'll multiply the ratios, we'll try to get a natural number ratios and then use the same method to calculate what each one of them had. Again, if you see, there is 2, 3 and 5. The LCM of 2, 3 and 5 is 30. So we'll multiply each one of them with 30. So 30 into half is 15 is to 30 into 1/3 is 10 is to 30 into 1/5 is 6. So the ratio after redistribution is 15 is to 10 is to 6. The sum of these ratios is 15 plus 10 is, that is 25. 25 plus 6 is 31. So after redistribution, Ajay had, we'll call it A1, is equal to his ratio, that is 15 by 31 into the total number of coins will remain 310. So this is equal to 150. And after redistribution, Bharat will have 10 by 31 into 310, which is equal to 100. And Charan will have 6 by 31 into 310. This is equal to 60. As you can see, the sum will total up to 310 even initially and finally. The sum will remain the same, which is 310. We are also mentioned that after redistribution, Ajay did not have any coins that he had initially. So none of the 62 coins that were with Ajay are left with him. They were distributed to Bharat and Charan. Similarly, initially Bharat had 93 coins. None of these particular 93 coins were left with him. They were distributed off to Ajay and Charan. And the same applies even to Charan. None of his initial 155 coins were with him. They were distributed to the others. Now this is the information that is given to us, and we'll have to go and solve the questions. If you see the questions, we are asked about the minimum number of coins that Ajay can give Bharat, and in the second one also it is the maximum number of coins that Bharat can give Charan, and so on. So what we'll do is we'll come back to this. We'll try to get a sense of how the distribution actually takes place. That is, how many coins Ajay can give Bharat and how many coins Ajay can give Charan. So what we'll do is we'll assume that initially this is Ajay, Bharat and Charan. Initially they had 62:93 155. Finally they became 150, 100 and 60. So we'll assume that of the 62 coins that were initially with Ajay, he gave A coins to Bharat. This would imply that the remaining 62 minus A coins were given directly to Charan. So we'll try to figure out, assuming one variable, that is A, as the number of coins Ajay has given Bharat, and try to figure out how each one of the other distributions went. So what we'll do is we'll construct a table and try to calculate. It will just make the calculations easier and less confusing. So this is the initial coins that were with Ajay, Bharat and Charan, and these represent how many of these coins went to each one of them. That is Ajay, Bharat and Charan. And this will be the total coins. And these are the final total coins. So initially the rows will represent the initial number of coins with them, and each one of them will represent how each of these coins were distributed. For example, we know that none of the coins initially with Ajay were left with Ajay. So that will be 0. Similarly, none of the initial coins with Bharat were left with Bharat. So this will be 0. Similarly, none of the initial coins with Charan were left with Charan. What we also know is that the total number of initial coins with Ajay is 62. These 62 were distributed between Bharat and Charan. Similarly, the total number of initial coins with Bharat is 93. And the total number of initial coins with Charan is 155. And the columns represent the final total. The final number of coins with Ajay is 150. The final number of coins with Bharat is 100, and the final number of coins with Charan is 60. Now what we are assuming is that Ajay has given A of his initial 62 coins to Bharat. So from Ajay, Bharat received A coins. This would imply that the remaining 62 minus A were left with Charan. This is basically what this line represents. Now if Bharat got A coins from Ajay and he has a total of 100 coins at the end, this would imply that he got the remaining 100 minus A from Charan. And if Charan gave 100 minus A coins to Bharat and he had initially 155 coins, the number of coins that Charan gave Ajay will be 155 minus 100 minus A, so this will be A plus 55. Similarly, Charan at the end had 60 coins, of which he got 62 minus A from Ajay. This would imply that the remaining coins he got from Bharat. So that will be 60 minus 62 minus A, so that will be A minus 2. What we are saying over here is that Bharat finally had 60 coins, of which he got 62 minus A from Ajay. So the remaining 60 minus of 62 minus A he got from Bharat. This will equal A minus 2. So Bharat gave A minus 2 coins to Charan. But Bharat initially had 93 coins. So he gave A minus 2 of them to Charan. So all the remaining coins he would have given Ajay. So that would be 93 minus A minus 2. So this will be 95 minus A. So 95 minus A were the coins that Bharat gave Ajay. Now as you can see, we have filled out the table. Each of these rows just represent how many of the coins were given from one person to the other during this redistribution. Just to reiterate, Ajay gave 0 of his coins to himself. Ajay gave A coins to Bharat and the remaining 62 minus A he gave to Charan. Similarly, Bharat gave 95 minus A to Ajay. He gave no coins to himself and he gave A minus 2 coins to Charan. As you can see, Charan gave A plus 55 coins to Ajay, 100 minus A coins to Bharat, and he gave no coins to himself. So this is the table that we have, assuming that the variable A represents the number of coins Ajay gave to Bharat. Now we can solve the questions. The first question, as we have seen, is what is the minimum number of coins that Ajay gave to Bharat? We assumed that the number of coins is A and we have to find out the maximum and minimum possible values of A. If you see all the redistributions, we know that 62 minus A is the number of coins that Ajay gave Charan. So this has to be greater than or equal to 0, or A has to be less than or equal to 62. Similarly, 95 minus A is greater than or equal to 0 because this represents the number of coins that Bharat gave Ajay. This would imply that A is less than or equal to 95. Similarly, Bharat gave A minus 2 coins to Charan. So A minus 2 has to be greater than or equal to 0. So A has to be greater than or equal to 2. Similarly, 100 minus A has to be greater than or equal to 0. So A has to be less than or equal to 100. If you look at the lower bounds, the lower bound is 2. So A has to be greater than or equal to 2. And the upper bound amongst all of them, as you can see, is 62, which is the smallest. So A has to be less than or equal to 62. So 62 is greater than or equal to A is greater than or equal to 2. Therefore, the minimum number of coins that Ajay can give Bharat is 2. The maximum number of coins which Bharat can give Charan is, what are the number of coins that Bharat can give Charan? Bharat giving Charan is A minus 2. So we need to find out the maximum value of A minus 2. We know that A is less than or equal to 62. So the maximum value of A minus 2 occurs when A is equal to 62 and A minus 2, the maximum value of it will be 60. The difference between the number of coins that Bharat had before and after the distribution is, so Bharat before the distribution had 93 coins and Bharat after the distribution had 100 coins. So the difference between these two is 7. Which of the following statements is definitely false? Charan gave 37 coins to Bharat. If you are looking at the coins that Charan gave Bharat, in our representation that will be 100 minus A. Now A is greater than or equal to 2. So 100 minus A will be definitely less than or equal to 98. And because A is less than or equal to 62, 100 minus A will always be greater than or equal to 38. So C minus B will always lie between 38 and 98. So the statement that Charan gave 37 coins to Bharat is definitely false. Because the number of coins that Charan gave Bharat will be 100 minus A, and this will always lie between 38 and 98. It can't be 37. If you're looking at the second one, Bharat gave 35 coins to Ajay. Bharat gave Ajay is 95 minus A. So we'll again, because A lies between 2 and 62, 95 minus A will lie between 93 and 33. So if Bharat gave 35 coins to Ajay, this can be possible because this is lying between the interval 33 and 93, and this will occur when A is equal to 60. That is possible. So this cannot be always false. So this can be true. Bharat gave 61 coins to Charan. If you are looking at Bharat gave to Charan, that is Bharat gave to Charan, that is A minus 2. As again A lies between 62 and 2, A minus 2 will lie between 0 and 60. So Bharat cannot give 61 coins to Charan because he can give only a maximum of 60 coins. So even this is definitely false. So if you are looking at it, statement 1 and statement 3 are definitely false. In this question, we are told that there are 4 friends, Aman, Bhanu, Chintu and Deepak, and they borrowed some money from each of their parents. So let us assume that the money borrowed by each one of them is A, B, C and D. Now we are told that the money borrowed by Aman, Bhanu, Chintu and Deepak respectively is in descending order. That is, A is greater than B, is greater than C, is greater than D. It is known that each one of them goes to a different school. The schools are given as Kendriya Vidyalaya, Kendriya. Then the second one is DPS. Next is Xavier's. And finally is Navodaya. Each friend knows certain information about the amount of money that is borrowed by the others. That is, the boy from Kendriya says that the sum of the money borrowed by the others is 180. The boy from DPS says that the sum of the money borrowed by others is 200. The third guy, that is the boy from Xavier, says that the sum of the money borrowed by the other three people is 220. And finally, the boy from Navodaya says that the sum of the money borrowed by the other three guys is 280. We know that the amount of money borrowed by each one of them is a unique positive number. And we also know that one of them has made a mistake of calculating and he either added or subtracted 20 rupees. So we are supposed to find out which school each one of them goes to and how much money did each one of them borrow. So let us assume that the money borrowed by each one of them based on the Kendriya Vidyalaya, DPS, Xavier and Navodaya are K, D, X and N. Now once we know the ordering, we can easily identify that the highest is A, the second highest is B, the third highest is C and the fourth highest, that is the smallest, is D. But because we don't know as of now which of these is highest, let us assume that they are K, D, X and N. Now what does the boy from Kendriya say? That the sum of the remaining 3 is equal to 180. That is, D plus X plus N is equal to 180. Now what does the boy from DPS say? That the sum of the remaining 3 is equal to 200. That is, K plus X plus N is equal to 200. Similarly, the boy from Xavier says that the sum of the remaining 3 is 220. So K plus D plus N is equal to 220. And finally, the boy from Navodaya says that the sum of the money borrowed by the others is 280. That is, K plus D plus X is equal to 280. Now if we sum them up, we are going to get that this is equal to 3 into K plus D plus X plus N, because each one of them is repeated 3 times, is equal to the sum of these 4. This is 180 plus 200 is 380. 380 plus 220 is 600. 600 plus 280 is 880. Therefore, 3 times the sum of all the money that is bought by these students is 880. But you would immediately observe that 880 is not a multiple of 3. But we know that each one of them has borrowed money which is a multiple of 3. So how can that actually happen? We are told that one of them has made a mistake while adding the sum. That is, amongst these 4 numbers 180, 220, 200, 220 and 280, one of the numbers is either greater by 20 or less by 20. If it is less by 20, then the sum, instead of 880, if 20 was added fraudulently, we had to decrease 20. So this would become 860. But 860 is also not a multiple of 3. So we know that the only other possibility is that we have undercounted, and instead of 880, the actual sum is 900. We know that 900 is a multiple of 3. So one of these 4 numbers, instead of being the number that is given, it should actually be 20 more. In this case, K plus D plus X plus N, that is the actual numbers, will equal 300. Now which of the 4 numbers should we add 20 by? If we add 20 to 180, it will become 200. The 4 numbers will become 200, 200, 220 and 280. This is not possible because we know that all of them are unique numbers. If there are 2 numbers which are equal, for example, if the first 2 expressions are equal, we can cancel X plus N and it would imply that D is equal to K. But that is not possible. So 4 sums also have to be unique. If any of the 2 sums are the same, it would imply that not all the 4 numbers of K, D, X and N are unique. So we can't add 20 to 180. Can we add 20 to 200? We can't add 20 to 200 because the same issue will occur where we'll have 180, 220, 220 and 280. Again we'll have 2 220s repeating, in which case these 2 should be the same, in which case X will equal D. That is also not possible. Can we add 20 to 220? In that case, the 4 numbers will become 180, 200, 240 and 280. This is possible, there is no contradiction involved. But if we add 20 to 280, that is the last possibility. In that case, the 4 numbers will become 180, 200, 220 and 300. But the sum of all the 4 numbers is equal to 300. In this case, we are getting that k plus d plus x, the 3 numbers itself will equal 300, which would imply that n is equal to 0. That is not possible. So we can't even add 20 to 280. The only number for which we can add 22 is 220. So now we know the 4 expressions. The 4 expressions are d plus x plus n is equal to 180, k plus x plus n is equal to 200, k plus d plus n, instead of 220 we should add 20 to it, so this will become 240, and the last is k plus d plus x, this is equal to 280. We can subtract each of these 4 equations from the cumulative sum to get the values of k, d, x and n. For example, if we subtract the first one from the cumulative sum, we'll call it 0 expression. So 0 minus 1 will imply that k is equal to 120. 0 minus 2 will imply that d is equal to 100. And 0 minus 3 will imply that x is equal to 60. And the last one, that is the 4th expression, would imply that n is equal to 20. Now these 4 are the same as the amounts borrowed by A, B, C and D. Now the highest is A, so A is equal to 120. And A has gone to Kendriya Vidyalaya. So Kendriya Vidyalaya, Aman, 120. The next is D, which is the second highest, that is equal to B. So that is Bhanu. And he has borrowed 100. X is the third highest, it is equal to 60. This is Chintu. He borrowed 60. And the one who has gone to Navodaya, that is Deepak, got the least. And this is equal to 20. So once we have identified what are the values of k, d, x and n, that is the amount borrowed by the Kendriya Vidyalaya student, the DPS students, Xavier students and Navodaya students, because we also know that A, B, C and D are in descending order, we can easily identify which of the students has gone to which school and how much he has borrowed. Now let us go and answer the questions that follow. What is the amount borrowed by Aman? That is equal to 120. In which school does Bhanu study? Bhanu studies in DPS. What is the amount borrowed by Deepak? Deepak borrowed 20. Finally, the last question. What is the difference between the amount borrowed by Aman and Chintu? Aman borrowed 120, Chintu borrowed 60. So the difference between these two is 60.
We at Krakow provide all the previous year CAT papers along with many other MBA examinations such as IIFT, XAT, SNAP, MAT, CMAT, TIS and PGDBA in the actual exam format. You can attempt them as a test and get a detailed analysis of your performance or download them as PDFs.
In this question, we are told that there are 6 people, A, B, C, D, E and F. They were taking their board exams and they got 6 different ranks from 1 to 6. It is also mentioned that each of them has a different blood group. The blood groups have an antigen and they have an RH factor. So basically the blood groups vary from A positive, A negative, B positive, B negative and O positive and O negative. So these are the 6 different blood groups which we have to assign to each of the 6 people. It is also mentioned that each of them speaks one of the 3 languages as their second language, that is between Latin, Greek and French. It is mentioned that there are exactly 3 people who speak one of the language, 2 people who speak another language, and the last remaining language is spoken by exactly one of the 6 people. So 3, 2 and 1, the total will be 6. So this is the information that is given to us. We have to figure out who got which rank, what language does he or she speak, and what is the blood group. So this is basically an arrangements question. So how are you going to approach it? The first thing I would suggest is first draw a table which will identify or which will look at what is the important thing that we have to, what are the attributes of each of the persons. The most important thing to identify is whether the first column will be with respect to the rank or whether it will be with respect to the name. Because if it is with respect to the name, then all the other rows have to be filled accordingly. If it is with respect to the rank, we have to write down the ranks first. In this case, I think going with ranks is better, because most of the clues that are given are with respect to ranks. We are told, for example, in one of the clues that Ilango got 4th rank. We are also told that the people with different blood groups secured consecutive ranks. So there were many clues with respect to ranks which were given. So we put the first column as the ranks. So for example, this will be 1, 2, 3, 4, 5 and 6. Once you have finalized which of them will be the first column, figuring out the other columns is not difficult, it is very easy. Once you put that, go through the clues multiple times. Whenever you are able to identify any cell, keep inputting the number into the cell and keep reiterating through all the clues until you are able to extract whatever information is given completely. So let us get started. In this question we are given that exactly one person who speaks French is better than exactly one person who speaks Latin. So we are told that there is one guy who speaks French, exactly one guy who got a better rank than exactly one guy who speaks Latin. Ilango scored a worse rank than 3 others. This would imply that the rank that Ilango has scored is 4. So the 4th rank table we have entered Ilango, and none of those 3 spoke French. So the first 3 are not French, the first 3 are either Greek or Latin. The people with RH type as positive secured consecutive ranks. And the people who have antigen O secured consecutive ranks. So what this would imply is that there are 3 ranks in which the blood group is all positive, positive and positive, and the people who had O positive and O negative have also secured consecutive ranks. This would give us that there are only 2 cases possible. Either O positive is at the start and O negative has secured a better rank than him, or the other way around, in which there are 3 positives and O positive is at the end and O negative got the immediately worse of rank than him. Again, we don't know what these ranks are, we just know that all these are consecutive and they have to be one of the 2 cases. So essentially we know the blood group of 4 people on consecutive ranks. Not exactly, but we have an idea that all 4 of them are with consecutive ranks. We know, for example, we don't know whether this is A or B or B or A, but you get the idea. Let us look at the next question, next clue. We are told that while people who secured consecutive ranks did not speak the same language. So this seems to be an important clue. We are told that, for example, the 3 people who speak the same language, they did not get consecutive ranks. Similarly, the people who speak the same language, that is those 2 people, again did not secure consecutive ranks. This also seems to be an important clue. We will come back to it after we iterate through the clues once. Arun, whose blood group is A negative, secured a rank which is immediately below the person who has secured B positive blood group. So immediately you will know that the first case is not possible, because we are told that there is a person whose blood group is A negative and the person who has scored a rank which is just above him is B positive. So this would imply that there is another positive guy ahead of him, and the guy who secured the best positive rank has to be O positive, and the person above O positive is O negative. This would imply that the person who is above B positive will have to be A positive. That is the only blood group with positive sign which is left. Arun, whose blood group is A negative, secured a rank which is immediately below a person who has B positive blood group, and secured a rank which is immediately above a person who speaks Greek. So below the Arun is a guy who speaks Greek. This seems to be a very important clue, because we have been able to identify the ranks of all of them. These are 6 people. So this would imply that the person who got the 6th rank was speaking Greek. Arun is the 5th in line, so this is Arun. His blood group is A negative. The person above Arun is B positive. The person above B positive is A positive. And above A positive is O positive. And above A positive is O positive is O negative. and the only remaining blood group is B negative. So for all the 6 ranks, we have been able to identify the 6 blood groups. Now let us look at next one. Babu secured a worse rank than Charles and Dinesh, but did not secure the worst rank. So 6 is not by Babu, and Babu scored a worse rank than Charles and Dinesh. So this would imply that Babu secured the 3rd rank and Charles and Dinesh secured either the 1st rank or the 2nd rank. We'll come back to it, but we know that they have secured better ranks than Babu, and there are only 2 ranks remaining, that is 1 and 2. This would also tell us that the 6th rank was secured by F, by Faisal. So we have filled in some of the details. Languages column, for example, is completely empty. So we'll go through the clues again. We'll try to focus mostly on the languages part because we have filled in most of the rest. And whenever we are able to fill in, whenever we are able to conclude anything, we'll come back and put it in the languages column. For example, one of the clues that we thought was quite important, which we have marked by star, is that consecutive ranks did not secure the same language. That is, people who have secured consecutive ranks did not speak the same language. Anyway, let us go through the clues again. Exactly one person who speaks French is better than exactly one person who speaks Latin. So there is one person who speaks French and he secured one rank, secured a better rank than exactly one person who speaks Latin. Now if you remember one of the clues that was given, it is that the first 3 people did not speak French. It was given in the second clue. So if you are trying to identify the person who has spoken French, it can't be 1, 2 or 3. It can't be 6 because that person is speaking Greek. So it has to be either 4 or 5. It can't even be 5 because in that case there would be no person who is speaking Latin, who has secured a worse rank than this person. So it would imply that the person who secured 4th rank, Ilango, was speaking French, and the person who came 5th was speaking Latin. Now there are only the top 3 which are remaining, top 3 ranks, and we know that the top 3 ranks did not speak French. So this would imply that out of the 3, 2 and 1, the number of the language which is spoken by only one person is definitely French. That one person is Ilango. We don't know whether the number of people who speak Greek is 3 or the number of people who speak Latin is 3. Those 2 cases are still remaining. So this would imply a few things. This would imply that the 1, 2 and 3 can be either Greek, Latin and Greek, or it can be Latin, Greek and Latin. Any of the 2 cases is possible. Let us go through the clues again to see if we can finalize which of the cases is actually true. Remember one more thing, we don't know who secured the 1st rank and the 2nd rank. We know that both of them are Charles and Dinesh, but we don't know who is who exactly. Ilango secured a worse rank than 3 others and none of them spoke French. This is fine, this we have taken care of, so nothing more can be extracted from it. The people who with RH type as positive secured consecutive ranks, that we have identified as 3, 4 and 5, and the people with antigen O also secured consecutive ranks. So that is, the people with positive RH type are 2, 3 and 4, and O negative and O positive are 1 and 2. And people who have secured consecutive ranks don't speak the same language. This we have already identified. In none of the cases are we finding any contradiction. So we can't rule out any of the cases. Arun, whose blood group is A negative, Arun secured 5th rank according to us, is immediately below a person who has B positive, that is the 4th ranker Ilango, and secured a rank which is immediately above a person who speaks Greek. So this is Greek, that is Faisal, his blood group is B negative. Again, we are not getting any new information from this clue. Babu secured a worse rank than Charles and Dinesh but did not secure the worst rank. This helped us in identifying that Babu secured the 3rd rank but not 1 and 2. So if you look at the clues, we have used all the information that is there in the clues. We have not been able to identify exactly which order is the language spoken by the top 3 people and who secured 1st and who secured 2nd rank. So let us go ahead and try to answer the questions that follow. For how many people can the language spoken be determined accurately? We know that E, A and F have spoken French language and Greek, so that is 3 for sure. We don't know if C is G or C is L. Similarly for D also we don't know whether it is L or G. Similarly, for Babu also, we don't know whether it is Greek or Latin. So for the first 3 people, we don't know their language exactly. So the correct number of people for whom the language can be determined accurately is 3. Which among the following people has A positive blood group? A positive blood group is B, that is Babu. Who among the following speaks French? French is spoken by Ilango, he got the 4th rank. How many different types of arrangements are possible for this given problem? There are 2 uncertainties. The first uncertainty is who got the first rank and who got the second rank. So that can be resolved in 2 ways. And once that is resolved, even the languages, there are 2 possibilities, that the first guy spoke Greek, second guy spoke Latin, and third guy spoke Greek is the first case. And the second case is that the first guy spoke Latin, the second guy spoke Greek, and the third guy spoke Latin. So there are 2 cases possible with respect to languages and 2 cases possible with respect to the names of the first and second ranker. So the total number of arrangements possible are 4. In this question, we are told that there is a contractor and he paid different amounts to 6 freelancers. The names of the 6 freelancers are given. They are Aman, Ajay, Diya, Farhan, Priya and Ram. Now the way in which or the order in which he has given money is not given, and how much amount is given to each one of these freelancers is also not given. But there is some information which is given. It has been mentioned that the amount that is given to each one of them is not necessarily a whole number. It is also mentioned that there are some clues. We are told that no 2 persons were paid at the same time, and each of the amounts given to these 6 freelancers is different. In addition to that, we are given some information which will help us in figuring out how much money was given to each of the freelancers and what is the order in which the money was given. So before we go through the clues, let us first draw the table in which we will identify the serial number in which people were given. So suppose this is the table. We'll put this will be basically the serial number, the name of the person. So the first row will represent the name of the person and the amount he or she was given. So this will be 1, this will be 2, this will be 3, this will be 4, and this will be 5 and 6. So this is 1, 2, 3, 4, 5 and 6. If we can fill this table, we can go ahead and easily answer the questions that follow. Now let us look at the clues that are given. We are told that Priya received $1,200 and this was the least amount paid by the contractor. So we know that Priya, for example, has received $1,200 and this is the least. What we don't know is what is the serial number of Preeti, that is in which order did she receive the money. Was she the first to receive money or the last or in the middle? We don't know that. We'll figure it out. We are also told that barring the first and the second payments, the amount paid by the contractor was the arithmetic mean of the previous 2 amounts paid by him. So this is a very important clue because this gives us a lot of information. It says that if say the first amount is A and the second amount is B, the third amount that is paid is A plus B by 2. That is the arithmetic mean of the first 2 is the third amount. Similarly, the arithmetic mean of the second and third is the fourth amount. And the arithmetic mean of the third and the fourth, these 2 is the fifth amount. And the arithmetic mean of the fourth and fifth is the sixth amount. So this narrows out a lot of detail. This gives us a lot of detail. So let us assume, because we will have a lot of fractions involved, because this becomes A plus B by 2 and the next one will have a denominator of 4 and the next one will have a denominator of 8 and so on. Let us assume that the first amount that has been received is 16A, small a. This is just to make our calculations easy because there will be a lot of divisions by 2 as we are calculating the arithmetic mean. And the second person is say 16B. This is 1, this is 2. The third person will be 8A plus 8B. This is the arithmetic mean of the first and the second. This is 3. And the fourth one will be sum of 2 and 3 divided by 2. So the fourth one will be 4A plus 12B. This is the fourth person. And the fifth one will be again the arithmetic mean of 3 and 4, which is 3 plus 4 divided by 2. So 8A plus 4A is 12A divided by 2 is 6A plus 8b plus 12b is 20b, divided by 2 is 10b. This is the fifth person. And the sixth one is the arithmetic mean of 4 and 5. So 4a plus 6a is 5a, plus 10b plus 12b is 11b. This is the sixth person. If we know the value of small a and small b, we know exactly how much money was paid to each one of them. We also have one more additional clue. We can kind of figure out where Priya was paid. What is the serial number of Priya? Because whenever you're told that this is an arithmetic mean, if we are calculating the arithmetic mean of two numbers, these are the first two numbers. Say this is the first number which is greater than the second number. We can consider the other case also where the second number is greater than the first number later. But if say the first number is greater than the second number, the third number has to be the arithmetic mean of 1 and 2. So it will lie somewhere in the middle. So the third number will be less than the first number but greater than the second number. And the fourth number will be the arithmetic mean of second and third. So again it has to lie between 2 and 3. So this will be the fourth number. And the fifth number will be the arithmetic mean of 3 and 4. So it will lie between 3 and 4. This will be the fifth number. And the sixth number will be the arithmetic mean of 4 and 5. So again it will lie between 4 and 5. What this basically tells us is that the extremes, that is the highest and the lowest, will always be the first and the second numbers. We don't know whether the highest is the first number or the lowest is the first number, but the highest and lowest, both of them will be the first and second numbers because of the way in which the money distribution has actually happened. Because an arithmetic mean will always lie between those two numbers. So what we know is there are two cases. Case one is the first is highest, first number that is given, and second is lowest, or the first is lowest and second is highest. Again, this would imply that Priya is either second or first because she received the least amount of money. Now let us go ahead and look at the next clue. Just remember that these are the two cases that we'll have to look at. He paid at least two of the freelancers amount greater than 2200. What again this means is there are two freelancers who received more than 2200. We know that the highest and the lowest have to be 1 and 2. So the highest person, that is the person who received either first or second, the person who is other than Priya, is one of the guy who received an amount greater than 2200, and even the third person will be the second highest. So that person also received greater than 2200. This is another clue that we'll remember, which we might use later on. Ram received payment before Ajay and Farhan. Also Farhan received $150 more than Ram. So Ram was above Ajay and Farhan. Again, we don't know whether Ajay received before Farhan or Farhan received before Ajay, but we know that Ram received before both of them. Priya and Diya did not receive the highest payment, received their payments consecutively. So now we are told that Priya and Diya received their payments consecutively and Diya did not receive the highest. So now we can rule out the case in which Priya received first, because if Priya received the lowest amount first, the person who receives amount immediately after her should be the person who came second, who has received the highest amount, because 1 and 2 are the highest and lowest. So if this is not the case, what we can say for sure is that Priya received second and Diya received third, because Diya did not receive the highest. This would also imply that, because we already know that Priya received 1200, so the amount which is the highest is greater than 2200, and the amount person who received it third also is greater than 2200. So the first and the third are greater than 2200. Everything else is less than 2200. Now if you look at the table that we have, the table over here says that 16b is equal to 1200. 16b is equal to 1200, or b is equal to 1200 by 16, which is 75. Now we know many things. What we know is that the person, for example, Ram did not receive money greater than Farhan. So Ram was not the person who received highest. So Ram is not the person who came first, who was given money first. So Ram has to be fourth, because Ram can't be 5 or 6, because there are two people who received amount after Ram. Now we know that Farhan has to be either 5 or 6, and Ajay also has to be 5 or 6. So this has to be either Ajay or Farhan. Similarly, this has to be either Ajay or Farhan. Now we know that there are two people who received money which is greater than 2200. That is the first and the third person who has received money is greater than 2200. So 8A plus 8B, which is the amount received by the third person, which is the second highest, is also greater than 2200. We know that 16B is 1200, so 8B, because B is 75, will be 600, or 8A is greater than 1600, or A is greater than 200. If two people have received money which is greater than 2200, we have to have A to be greater than 2200, because we have assumed that the amount received by the first person, which is the highest, is 16A, amount received by the second person is 16B, but because the second person has the lowest amount received, B we have calculated is equal to 75, so the third person has received 8A plus 8B, which will be the second highest. So the first and the third have to be greater than 2200, or A has to be greater than 200. Now this is one thing that we have noticed. We can even calculate the value of A, because we know that the difference between Ram and Farhan is 150. So we'll calculate the difference between the fourth and the fifth guy. We'll also calculate the difference between fourth and the sixth guy. Then we can calculate the value of A, and we can then find out how much each person has received. If you're calculating the difference between the fourth and the fifth, fourth person has received 4A plus 12B, fifth person has received 6A plus 10B. The difference between these two is 2 into A minus B. If this is equal to 150, A minus B is equal to 75, or A is equal to B plus 75, which is 150. But this is not possible, because we know that A is greater than 200. So Farhan cannot be the fifth person to receive it, because if Farhan is the fifth person to receive it and the difference between Ram and Farhan is only $150, it would imply that A is equal to 150, which would again imply that the highest, that there are no two persons who have received more than 2200. So the only implication is that Farhan is the sixth person. Again we will calculate the difference between how much the fourth person has received and how much the sixth person has received. In this case, the fourth person has again received 4A plus 12B, and the sixth person has received 5A plus 11B. The difference between these two is A minus B. Now if A minus B is equal to 150, it would imply that A is equal to B plus 150. We already know that B is equal to 75, so A is equal to 225. This is greater than the restriction that we have, that A has to be greater than 200. So this is possible. So now we have the value of A and we have the value of B. Now we can calculate how much each of the persons has received. We also know who is the fifth person. The fifth person is Ajay. So the only remaining person is the first one, who is Aman. Now we know exactly how much each of them has received, because we know the value of A and the value of B. The value that Aman has received is 16 into A. So that is 225 into 16. This is, you have your calculator, so you can calculate it, or this is 900 into 4, which is 3600. And Dia would have received the arithmetic mean of these two, so that will be 2400. Ram would have received again the arithmetic mean, so that is 1800. Ajay would have received again 2100, and Farhan would have received again the arithmetic mean, which is 1950. You can even calculate using the equations that we have of in terms of A and B, but that is slightly more complicated. You have to do more calculations. Once you know how much the first person has received and how much the second person has received, calculating the arithmetic mean is much more easier. Anyway, now we have the respective amount of how much each person has received. We also know the serial number in which the people have received their money. Now let us go ahead and answer the questions that follow. So the first question says that who was the second last person to receive the payment? The second last person to receive the payment is Ajay. So that is option C. What is the highest amount paid by the contractor in dollars? The highest amount paid by the contractor is that received by Aman, which is 3600. What is the total amount paid by the contractor in dollars, which is basically the sum of all of this? 3600 plus 1200 plus 2400 plus 1800 plus 2100 plus 1950. 2100 plus 1950 is 4050. 1200 plus 3600 is 2400 is 3600. So this is 7200 plus 1800. 7200 plus 1800 is 9000. So the total amount that is paid is 13,050 by the contractor. Let us look at the last question. Of all the 6 payments, what is the median payment received in dollars? So we have to find out, when you are asked to find out the median of a group of numbers, you have to arrange the numbers in ascending order and find the middle term. So if, for example, the median of, say, an even set of numbers, if you arrange them in ascending order, you find out the middle terms. The middle terms will be 3 and 4, and you have to calculate the average of these two. If the group of numbers that are given are odd in number, that is if there are only 5, 1, 2, 3, 4 and 5, then you have to just simply calculate the middle term. Because here there are 6 terms, we will have to calculate the average of the third highest and the fourth highest. The highest is 3600, the second highest is 2400, the third highest is 2100, and the fourth highest is 1950. This is the third highest, this is the fourth highest. So once you have identified this, you have to take the average of these two. The average of these two is 4050 by 2, which is 2025. So the correct answer is 2025. In this question, we are told that there are 5 friends: Arun, Rajan, Dheeraj, Tilak and Charan. All of them belong to one of the cities which are given. The 5 cities that are given are Chennai, Mumbai, Bengaluru, Hyderabad and Pune. And all of them have travelled to 2 other cities other than the place of their origin amongst the 5 cities. And each one of them has travelled on one of the 5 days. The 5 days are from Monday to Friday. And they have met the person who belongs to the other city during whenever they were travelling. And we have been given some clues. So using these clues, what we have to identify is which of the city does each one of them belong to, which of the 2 cities did each of them visit, and on which day did they visit. We have been given some clues, like one of the clues that is given is that no combination of friends have met each other more than once, and some other clues that follow. But once you understand this question, you know that this is an arrangements question and you have to fill in a table. So let us first draw the table, then let us go through all the clues once. If there is any direct clue that is given, we will fill up the table. Then we will keep on reiterating as and when we find something new, we will keep on updating the table till we are completely done. Once we are completely done, we will go ahead and answer the questions that follow. So in this case, we will have a table. The first column will contain the name of the player. The second column will contain the city he is from. The third one will be the 2 cities that person has visited, and the fourth one will be the day of travel. So this is the column for the row for the headings. This is the first person, this is the second person, this is the third person, and this is for the fourth and the fifth person. The first column is the name of the person, the second column is that person's hometown, the third column will be the cities that he or she has visited, and the fourth column is the day on which they have visited. So if you have to put up the names of the headings, this is the name of the person, this is the home city where that person is based in, this is the 2 cities that person has travelled, and this is the day of travel. So again, before we go through the clues, just to get a good understanding of what the columns will look like. For example, names we can fill up. The first one is Arun, the second name is Rajan, the third one is Dheeraj, the fourth is Tilak, and the fifth is Charan. So these are the 5 persons. The home cities, each of these cities have to be exactly one of, let us take only the first letter of the cities. This is Chennai or Mumbai or Pune or Bengaluru or Hyderabad. So each of these alphabets has to come in one of the particular rows of the home city. If you're looking at the 2 cities that are travelled, so we'll have comma separated names. So each of them will be a tuple because each person has visited 2 cities. Now, if you're looking at how many times the alphabets come, that is how many persons could have visited Chennai, you know that the total number of cities, if you calculate in this column, will be, because there are 5 persons and each of them has visited 2 cities each, the total number of cities in this column will be a total of 10. But how many times can each of the city be visited? We will try to prove that the total number of people who has visited any city cannot be anything other than 2. So it cannot be one person who has visited a city, it cannot be three persons who have visited a city. Because let us assume that suppose three people have visited a city. Just for example, let us assume that they have visited a city called Pune. Now there is one person, suppose the three people who have visited, out of these three are say the first three, which is A, R and D. That is Arun, Rajan and Dheeraj. Suppose the three of them have visited Pune, and suppose Tilak is from Pune, basically the fourth person. Now if you are looking at it, if three people have visited Pune and Tilak is from Pune, Tilak also has to visit two other cities. Now, so one of the city he could visit will be the city of Charan, but the next city that Tilak is visiting has to be one of Arun or Rajan or Dheeraj. So Tilak would be meeting that person two times. So once he would be meeting them when Arun or Rajan or Dheeraj visits Pune, that is the first time he would meet, and the second time would be when Tilak actually goes to Pune to meet. So this can't happen. So this proves that there is no person who can visit a particular city. You cannot have more than two people visit a particular city. At max there can be only two people who are visiting a city, and because you have a total of 10 cities that are traveled by 5 people, it would imply that each of the cities, that is there will be 2 C's in this column, there will be 2 M's in this column, there will be 2 P's, 2 B's and 2 H in the column of cities that are traveled by the people. If any city is traveled by 3 other people, then as we have just discussed, there will be a meeting of, there will be at least 2 meetings of the persons, like we have just proven with respect to, by assuming that Arun, Rajan and Dheeraj have visited Pune and say Tilak is from Pune, then Tilak would be meeting that person 2 times, which is not possible. So each of the 5 cities are visited 2 times by 2 other people, and each of the 5 people belong to one of the cities out of the 5 cities given. And in the third column, day, it will be one of the 5 days from Monday, Tuesday, Wednesday, Thursday and Friday. So out of these 5 days, we have to distribute them amongst these columns, amongst the different friends. So this is basically how the table would look like. Now let us go ahead and look at the clues and let us try to fill in the table. The first clue says that Arun met Dheeraj on Thursday. So it would imply that either Arun travelled on Thursday or Dheeraj travelled on Thursday. And it would also imply that either Arun travelled on Thursday and went to Dheeraj's home city, or Dheeraj travelled on Thursday and went to Arun's home city. These are the only 2 cases possible. We'll just keep track of it until we get anything which is more concrete. We wouldn't fill in the table. But we know that this has some information, so we'll keep a dot against it. If you have completely exhausted that point, we'll put a cross against it so that it will make it easier for us to understand which are the points to concentrate. Rajan visited Pune and Mumbai on Monday. So Rajan visited Pune and Mumbai, and the day he travelled is on Monday. So as you can see, this point is completely exhausted. There is nothing, no other information that can come from this. So we'll put a cross against it. The person from Mumbai met Charan a day. So after Charan met the person from Chennai. So on one day, Charan met the person from Chennai, and one day after that, Charan met the person from Mumbai. This seems quite complicated. It looks like there's a lot of information, but we are not able to figure out because we don't know who is from Mumbai, we don't know who is from Chennai, we don't know whether Charan travelled to Mumbai or the person from Mumbai travelled to Charan's home city. So it seems complicated. So we'll again put a dot over here. We'll again come back to it later. But one of the things that you should observe and try to take in is that at least this tells us immediately that Charan's home city is not Chennai or Mumbai, because he has met both the people whose home cities are Chennai and Mumbai. So Charan's home city, for example, this, you can make a mental track that this is not Mumbai and this is not Chennai. Now let us go to the next question. Tilak and Ranjan met in Hyderabad on Tuesday. So Tilak and Ranjan met in Hyderabad on Tuesday. So if you know that Tilak and Ranjan met in Hyderabad, it would imply that either Tilak travelled to Hyderabad or Ranjan travelled to Hyderabad. You know that Ranjan did not travel to Hyderabad. The 2 cities that Ranjan has travelled are already known. So this would imply that Tilak travelled to Hyderabad. This is one thing that you know. And you also know that Ranjan's home city will have to be Hyderabad, because that is the only way in which Tilak and Ranjan would have met. And you also know that because both of them, Tilak and Ranjan, met on Tuesday, it would imply that Tilak travelled on Tuesday to Hyderabad to meet Ranjan. So as you can see, This information is again completely taken care of. Tilak met Ranjan in Hyderabad on Tuesday. We have completely exhausted whatever information is being given over here. So we'll put a cross over there. The next question is that the person from Hyderabad met Charan on Friday. So we know that the person from Hyderabad is Ranjan and he met Charan on Friday. So this would imply that Charan travelled on Friday and one of the two cities that Charan went to is Hyderabad. This can be inferred from this. Again, we have completely exhausted this point, so we'll again put a cross over here. If you look at next point, Arun did not go to Dheeraj city. So Arun did not go to Dheeraj city. This is important because one of the first clues that we took, there were two cases. The first case is that Arun travelled on Thursday and went to Dheeraj's home city, or the second case is that Dheeraj travelled on Thursday and went to Arun's home city. This proves that Arun did not go to Dheeraj city. So the only way Arun and Dheeraj could have met on Thursday is if Dheeraj travelled on Thursday and one of the cities that he has gone to is Arun's home city. So even though we can put a cross over here, we'll still put a dot at the first because there is still some information that Dheeraj has gone to Arun's city on Thursday and we don't know what city it is. So we'll again put a dot over here to keep that in mind. Dheeraj did not meet anyone on Tuesday. This would also imply that Arun travelled on Wednesday. So Dheeraj did not meet anyone on Tuesday and Charan did not meet anyone on Monday. So if Dheeraj did not meet anyone on Tuesday, it is implied that anybody who travelled on Tuesday did not go to Dheeraj's home city. And who travelled on Tuesday? Tilak travelled on Tuesday. So we know that Tilak did not go to Dheeraj's home city. And Charan did not meet on Monday. Who travelled on Monday? Ranjan travelled on Monday. So we know that the person who travelled on Monday, that is Ranjan, did not go to Charan's home city. So this will tell us that Charan is not belonging to either Pune or Mumbai because otherwise he would have met Ranjan who travelled on Monday. So Charan is also not Pune. Now this is basically the information that we have. We don't have anything more. So how do we proceed? We will first look at all the points that we have noted down. All the points will tell us something or the other which we might have missed out. And then we will keep on reiterating through all the points. We will see which are the points that are important. For example, 2 points we have noted down with dots. They probably are important. And we will keep on doing the reiterating until and unless we have exhausted all the points. If you are looking at the notes that we have made, we know that Charan is not from Chennai or Mumbai. We also know that Charan is not from Pune or Hyderabad. Because Charan has travelled to Hyderabad, we know that Charan is not from Chennai, we know that Charan is not from Mumbai, and we have just noted down that Charan is also not from Pune. Because Charan did not meet anybody on Monday and Ranjan travelled on Monday. So the only city that Charan can actually belong to will be Bengaluru. Now we have figured out that Charan is from Bengaluru. Let us try to figure out if we can finalize any of the hometowns of other people. If you are, for example, trying to look at which is the home city of Tilak, Tilak's home city cannot be Hyderabad because Ranjan is from Hyderabad. Tilak's home city cannot be Bengaluru because Charan is from Bengaluru. And we also know that Tilak has travelled to Hyderabad. So he has met Ranjan in Hyderabad once. So the two cities that Ranjan has travelled to, which is Pune and Mumbai, also cannot be the hometown for Tilak. So they cannot be Pune or Mumbai. Because if say Tilak is from Pune, then Tilak would have met Ranjan in Pune once when he went to Pune, when Ranjan came to Pune. And Tilak would have met Ranjan also in Hyderabad when Tilak went to Hyderabad. So he would have met Ranjan twice. But it has been said that no combination of friends have met more than once a week. So all of them have met exactly once a week. This would imply that because we know that one of the cities that Tilak has travelled to is Hyderabad, his hometown cannot be the cities that Ranjan has travelled, which is Pune and Mumbai. So if you remove 4 of these points, the only city that Tilak could have belonged to is Chennai. Now basically there are only 2 cities left which are the hometowns, which is one is Mumbai and one is Pune. We'll have to figure out which who belongs to what. So let us again go through and reiterate all the points and then try to see if we can finalize who belongs where. The 2 points that we have not made complete use of is that Arun and Dheeraj met on Thursday. Basically the fact that Dheeraj went to Arun's city. So if you're assuming that this is the hometown is 1 and the hometown of Dheeraj is 2, we know for sure that Dheeraj has gone to Arun's home city. So this is 1. But we don't know anything else from this. If you're looking at the second point, the person from Mumbai met Charan a day after Charan met the person from Chennai. So we know that if you're looking at the day on which Charan met the person from Chennai, who is the person from Chennai? We have just figured out that the person from Chennai is Tilak. So we have to figure out the day in which Charan met the person from Chennai, who is Tilak. So what are the 2 days when Charan and Tilak could have met? They could have met either when Charan went to Chennai or Tilak came to Bangalore. So basically they could have met either on Tuesday or Friday. These are the only 2 days that Charan could have met the person from Chennai. One is when Tilak came to Bengaluru or when Charan went to Chennai. But you know that 1 day later Charan met the person from Mumbai. So the day of meeting of Charan and the person from Chennai cannot be Friday. It has to be on Tuesday. So this would imply many things. First, it would imply that Charan and Tilak met on Tuesday and not Friday. And Charan and the person from Mumbai met on Wednesday. So this would tell us one thing. One thing that is going to tell us is that Charan and Tilak met on Tuesday. So the second city that Tilak has visited has to be Bangalore. It will also tell us that the person from Mumbai, because Charan did not travel on Wednesday, the only way in which Charan could have met the person from Mumbai on Wednesday is if the person from Mumbai has to be Arun, who traveled on Wednesday. So this has to be Mumbai. So the remaining this has to be city of Dheeraj has to be Pune. And so one of the cities that Dheeraj has visited has to be Mumbai. So now we have figured out the home cities of everyone. We have figured out the days on which they have traveled. We just have to figure out which are the 2 cities that each one of them has visited. Now let us try to count which are all the cities that are left in the second column that should be filled in the third column. We have 2 Mumbais, so we'll cancel this out. We have 2 Hyderabad, so we'll cancel this also out. We have 1 Pune and we have 1 Bengaluru. So we have 1 Pune and we have 1 Bengaluru and we have 2 Chennais to fill in. Now if you are looking at Charan, we know that the second city cannot be, so the second city has to be either Chennai or Pune or Bengaluru. One of the 3 cities have to be the city that Charan has visited. It can't be Bengaluru because his hometown is Bengaluru. So it has to be either Chennai or Pune because these are the only cities that are remaining. Now out of Chennai and Pune, you know that Tilak from Chennai has come to Bangalore and met Charan. So Charan again cannot go to Chennai and meet Tilak because that would be meeting them twice. So the city that Charan has visited, the second city cannot be Chennai, it has to be Pune. Now if you are removing Pune also, you have 2 Chennais to fill and 1 Bengaluru to fill. And you have to figure out 2 Chennai and 1 Bengaluru. And these have to go to Arun and these have to go to Dheeraj. So because there are only 2 people left, both of them have to go to Chennai because one person cannot go to Chennai twice. So one of this has to be C and one of this has to be C and the remaining has to be B. So now you have filled up the entire table. Now let us go ahead and answer the questions that follow. On which day of the week did the persons from Pune and Mumbai meet? Who are the 2 persons from Pune and Mumbai? They are Arun and Dheeraj. If you remember one of the clues that was given, we were told that Arun and Dheeraj have met on Thursday. Or you can also infer that Arun and Dheeraj would have met only when Dheeraj has gone to Arun. So that would be the day that Dheeraj has travelled, which is a Thursday. Let us look at the next question. Which of the following cities did Charan not go to? Charan went to Hyderabad, he went to Pune and he is from Bengaluru. So the 2 cities that Charan did not go to are Mumbai and Chennai. So the answer has to be option D. Which city is Tilak from? Tilak is from Chennai. We have figured it out. The person from Bengaluru met the person from Chennai on which day? The person from Bengaluru is Charan and the person from Chennai is Tilak. So on which day did Charan and Tilak meet? We have figured it out earlier using one of the clues that they have met on Tuesday. because they have met one day before Charan met the person from Mumbai. Anyway, on Tuesday, Tilak has travelled to Hyderabad and Bengaluru, and on that day, because Charan is from Bengaluru, both of them have met. So the correct answer has to be Tuesday. In this question, we are told that a team of 3 students have to be formed by using 8 students. The names of the 8 students are A, B, C, D, E, F, G and H. And we have to use these 8 students to form a team which contains at least 3 members. Now there are some conditions given. There are some restrictions based on the students and their selections. So let us go through them. The first condition says that if D is selected, then G has to be selected. The second condition says that if G is selected, then H has to be selected. What this implies is that in the first condition, if D is selected, we have to select G, and because G is selected, then we have to select H. Now let us look at the third condition. The third condition says that if A is selected, then D cannot be selected. So if A is part of the team, then D is definitely not part of the team. The fourth condition says that if E is selected, then H cannot be selected. So if E is part of the team, then H is not part of the team. The fifth condition says that if F is part of the team, then the team size can be at max 3 members. But because we are given that the team has to be at least 3 members, it is implied that if F is part of the team, the total number of members in the team has to be 3. The sixth condition says that if C is part of the team, then the total number of members in the team cannot be more than 4. Therefore, if C is part of the team will have either 3 members or 4 members. Finally, we are told that at least one of B or C has to be part of the team. That is, either B should be part of the team or C should be part of the team. So these are the conditions given. Let us go ahead and answer the questions that follow. What is the number of teams possible if F is definitely selected? If F is definitely selected, we know that the number of members in the team cannot be more than 3. We also know that either B or C has to be part of the team. Remember that it can be either B or C or both. We are just told that at least one of these two has to be part of the team. So let us first consider the case where both of them are part of the team. So the case is that the team will be FBC. So this is one case. Now let us consider all the cases where exactly one of B or C is part of the team. One member of the team is F. The second member of the team can be selected from B or C in 2 ways. And now we have to figure out who the third member can be. Now before we figure out who the third member can be, let us first list down all the 8 players. So there is A, B, C, D, E, F, G and H, of which F is already part of the team. B and C are also selected, either one of them is selected, but if one of them is selected in this particular case, the other person will not be selected, so we are ignoring that. So the choice for the last member has to be made from A, D, E, G or H. So there are 5 members remaining. But before we can select all 5 members, because there are some conditions remaining, let us look at all the conditions. Can that person be D? It cannot be D, because if that person is D, then we have to select even G and we have to select even H. So we would need places for 3 people, but we have only one person, one place remaining. So that person cannot be D. For the same reason, that person cannot even be G, because if you select G, you have to select H, and we don't have 2 places, we have only 1 place. So now basically the last choice is between A, E and H. There is no condition with respect to A. It is just mentioned that if we are selecting A, then it shouldn't be D, which is fine because we are anyways not selecting D. So the third person can be A. Can it be E? It can be E because the restriction is that if you select E, then you shouldn't select H, which automatically will happen because there is only 1 place left. So if the last place is given to E, then it is not given to H and H is not selected. Similarly, the last person can be H also, and there is no real restriction about selecting H. So the total number of ways in which the last person can be selected is 3 ways. So in this case, the total number of possibilities is 2 into 3, which is 6 ways. So there is 1 way in which both B and C are selected, and there are 6 ways in which exactly one of B or C is selected. So the total number of ways in which F is definitely selected is 7 ways. Now let us look at the next question. What is the number of teams possible if C is definitely selected? If C is definitely selected, the number of members in the team is either 3 or 4. So let us consider both the cases. The first case is when there are exactly 3 members and one of the members is C. And the second case is when there are exactly 4 members and one of the members is C. Now in the first case, we have to select 2 more members. So let us again first list down all the players. Let us first try to evaluate the people with conditions. And once we have understood their restrictions, we will look at the people without conditions. So the people remaining are A, B, C, D, E, F, G and H. Of this, C is already part of the team. Based on the condition that we have discussed earlier, D cannot be part of the team, because if D is part of the team, G and H also have to be part of the team. So we would need 3 places, but we have only 2 places. So it cannot even be D. So now you have only A, B, E, F, G and H remaining. Let us first look at F, because we know that actually in this case we don't need to look at F. Let us look at the other people. Let us first look at what are the conditions remaining. If you are looking at G, if you are selecting G, then you have to select H. So one condition is that, one case is that it is C, G and H. We'll keep this in mind. But if you ignore this one case, then you can't select G. Because if you are selecting G, the other person has to be H. So that is the only case in which G is being selected. So now if you are looking at the remaining possibilities, there is A. There is no condition on A. So you can select A because you know that you are already not selecting D. So that is not an issue. If you are selecting B also, there is no restriction. So B is also, for our standpoint, is somebody who is completely free from any conditions. If you are looking at E, there is a condition that H cannot be selected. So let us look at this separately. F is also free for this moment because there is no condition on F. The only restriction on F is that he should be part of a team which is not more than 3. In this case, we have only 3 members. So there is no restriction even on F. On H also per se, there is no restriction. The only restriction is with respect to E and H. So what we will do is we will consider the case where the second person we have selected is E. Then the last person can be either A or B or F. There is no restriction on them. So if you are selecting E, there are 3 cases. Now once you have ignored this case, once you have eliminated the selection of E, then you can put H in the alongside all the remaining 3 people, that is A, B, F and H. Amongst these 4, there is no restriction because you have assumed that in this particular case, you are not selecting G, you are not selecting E. So amongst A, B, F and H, there is no restriction and you have to select 2 people out of this 4. So how many ways can you select 2 people out of this 4? It is 4C 2 ways, which is 6 ways. So the total number of ways in which you can select 3 members, a team of 3, which includes C, is 1, which is C, G and H, 3, which definitely has E, and 6, which definitely doesn't have E. So the total is 10 in the first case when there are exactly 3 members in the team. Now let us look at the number of ways in which we can select a team of 4 members, which includes C. We will repeat the same exercise with the same procedure again. Let us first write down all the names of the people. You have A, B, C, D, E, F, G and H. In this case, F cannot be part of the team because it has 4 members. There is one case, one trivial case where you have D, G and H as part of C. That is the case in which D is part of the team. G and H will also be part of the team. So you have C, D, G and H. So this is one case. Other than this one case, D cannot be part of the team. So we'll note down this one case and we'll proceed further. Now if you're looking at the other people, C is already taken care of. There is no restriction on A. There is no restriction on B because A just implies that there shouldn't be D. If you're looking at E, again as earlier, there is a restriction that H cannot be part of the team. In this case, G and H have a connection, that is if you select G, you have to select H. So let us consider the cases where you definitely select G. So if you're selecting G, then H has to be part of the team and the last member should be either A or B. So if G is being selected, the number of cases possible is 2. So other than these 2 cases, you cannot select G. So we will keep that in mind. So the last 3 number, the 3 have to be selected between A, B, E and H. And A, B, E and H From these 4 you have to select 3. Now how many ways can that happen? If you are selecting E, then you cannot select H, so the remaining 2 has to be A and B. Or if you are not selecting E, then the remaining 3 have to be A, B and H. So basically there are 2 possibilities of selecting the last 3, that is A, B and E, or A, B and H. So other than C, you have 5 cases in which you can select a team of 4. What are those 5 cases? Just to reiterate, one of them will be C, D, G and H. This has D, G and H. The other one includes C, G, because G is there, H has to be there, and this is A or B. So this is 2 cases. And finally you have C and you have A and B, and the last element will be either H or E. So this is another 2 cases. So you have 10 possibilities of a team of 3 and you have 5 possibilities of a team of 4. So the total teams possible, which includes C, is 15. Let us look at the next question. How many 4-member teams are possible? So in the earlier question we have counted that there are 5 4-member teams possible, which include C. So now let us count the number of teams which definitely don't include C and have 4 members. Then we will add that to 5 and get the answer. This is an easy way to solve it. So you have 1, 2, 3 and 4. You have the people as A, B, C, D, E, F, G and H. You don't want C to be part of the team. Because C is not part of the team, B has to be part of the team. Because one of B or C is definitely part of the team, at least one of them. So now you have to select 3 members out of A, E, F, G, H and D. Because this has 4 members, it cannot even be F. So now you have basically 5 members. Who are the 5 members? You have A, E, D, G and H. With D, G, H there is one case, which is the trivial case, that if you are including D, the other 2 members have to be G and H. So other than that you can't include D. So if you are adding that one case, you have A, E, G and H, and of this you need to fill in 3 places. How are you going to do that? We'll again look at the second guy who has this kind of a restriction. That is, if you are assuming that G is part of the team, then H has to be part of the team. That is, this is G and H. And then you can't have E, because if E is part of the team, it can't have H. So the last person has to be A. So other than this one case, G also will not be part of the team. So you ignore him. Now you have 3 members and you have 3 spots. But can you have a team which has A, E and H? This is not possible, because if E is part of the team, H cannot be part of the team. So this is not possible. So the 4-member team which doesn't include C, there are only 2 cases. That is B, D, G, H and B, G, H, A. And you have 5 teams which include C. So the total number of teams is 7. Let us look at the last question. What is the number of teams possible if A is definitely selected? So let us count the number of 3-member teams with A, the number of 4-member teams with A, and the number of 5-member teams with A, and so on. So because you know that A is definitely part of the team, let us first look at the case where there are only 3 members and one of them is A. Now A can be the first member, but we know the condition that B or C have to be part of the team. That is, at least one of B or C have to be part of the team. So let us consider the first case where both B and C are part of the team. That is one case where the team is A, B and C. Other than this, let us assume that there is only exactly one of B or C who is part of the team. So the first member will be A, the second will be either B or C. So you will multiply the number with 2, and now you have to only select the last member. Now what are the possibilities for the last member? If you look at all the 8 members, you have A, B, C, D, E, F, G and H. It is not A or B or C because we have already selected them. As we have discussed earlier, it cannot be D because then G and H also have to be part of the team and we don't have that much space. Similarly, it cannot even be G because if G is part of the team, then H also has to be part of the team. Then you have to select one of either E or F or H. When you are selecting only one of these guys, there is no restriction. The only restriction with E is that if E is part of the team, then H will not be part of the team. which is fine with us in this case because you have only one opening. So if E is part of the team, H will definitely not be part of the team. So we need not consider that condition. So the last member can be selected as one of E or F or H. So this is 3 ways. So the total number of ways in which you can select a team of 3 members, which includes A, is 1 plus 6, that is 7. Now let us consider the number of cases in which you can select a team of 4, which includes A. We'll do the same thing that we have done earlier. We'll first take care of B and C. So let us consider the number of cases in which you have both B and C as part of the team. If you have both B and C as part of the team, you can only select the last person. And who can that last person be? If you're looking at it, A, B and C are already taken care of. It cannot be D for the same reason that D requires 3 spaces. It cannot be G because G would require again 2 spaces, G and H. It cannot be F because F will not be part of a 4-member team. It has to be either E or H. So in a 4-member team which includes A, having both B and C, there are 2 cases. Now let us only consider the case where exactly one of B or C is part of the team. So again write 4 blanks. The first one is A. The second one is either B or C. Now let us try to figure out in how many ways we can fill the last 2 cases. So we again have A, B, C, D, E, F, G and H. In this case, A is taken care of, B is taken care of, C is taken care of. D cannot be part of the team for many reasons. If you really think about it, if A is part of the team, then D cannot be part of the team. So even then you can ignore D. Then you have E, F, G and H. You can't have F because this has it has 4 members and F is not a part of a 4-member team. So now you have only E, G and H. And amongst these 3 you need to pick 2 people. Now one person that you can pick is GH. This is one case. If you are picking G, then it has to be H. And if you are not picking G, it has to be E and H. But that is not possible because if E is part of the team, then H cannot be part of the team. So this is not allowed. So the last 2 in this particular case have to be G and H. So this has 2 cases. So a 4-member team which includes A, there are 4 ways. Now let us look at how many ways in which we can select a 5-member team which includes A. So if you're looking at A, 1, 2, 3, 4 and 5, you have A, B, C, D, E, F and G and H. You have A, because A is present, you cannot have D, you cannot have F. So from B, C, E, G and H, you have to select 4 members. How many ways in which you can do this? Remember what we discussed for even C. C is part of a team which has a maximum of 4 members, but because you are looking at 5 members, C cannot be part of the team. So now you have 4 blanks and you have 4 members. You have B, G, H and E. But again, E and H, both of them cannot be in the same team. So out of the 4 members, B, G, E and H, you can't have a team with them because E and H will be in the same team. So a 5-member team having A is not possible. So the total number of teams which have A is 7 plus 4, which is 11. In this question, we are given a graph. This graph represents the quantity of vegetables that were produced across 4 years, that is 1, 2, 3 and 4 years. The 4 years from 2015 to 2016 is the first year, 2016 to 2017 is the second year, 2017 to 2018 is the third year and 2018 to 2019 is the fourth year. We are given 5 different vegetables: cabbage, which is given in blue color, beetroot, which is in brown, orange is orange, onion is green and potato is dark blue. We are also given that the distance in the x-axis is measured as 100 units, that is from one year to another year, and the distance in the y-axis is given as follows. You can look at the graph and you will figure it out. We are also given that all the numbers in the y-axis are multiples of 5. This is basically the information that is given to us. So before we answer questions, what exactly should be done? One way to go ahead is actually note down the points of each of the years for each of the vegetables and then try to calculate the area and then answer the questions that follow. That is one thing, but sometimes, especially in an exam like CAT, that is probably an overkill because all that information is probably not needed. So in general, when we look at these kind of questions, the first thing you should do is first go through all the questions quickly. Try to identify what exactly is needed, whether jotting down the information from the graph into a table is needed or not. That decision you will have to take only after first glancing through all the 4 questions. So if you're looking at the first question, how many kgs of potatoes were produced in the time period from 2015 to 2017? So for potatoes, we are required to find out the total quantity that was produced from 2015 to 2017. That is for 2 years. The second question says that what is the percentage of production of beetroot from the time period, what is the increase in 2018-19 as compared to 2017-18. So even for beetroot, we need to find out the area for 2 years, because area represents the quantity that is produced. If you're looking at the third question, what is the difference in the amount of onion produced in 2018-19 as compared to cabbage which is produced in 2016-17. So for onion, we need to calculate the area for 1 year, and for cabbage, we need to calculate the area again for another year and find out the difference between those two. If you're looking at the last one, what is the total production of tomatoes during 2015 to 2019? For tomatoes, we need to calculate the area for all the 4 years. So if you look at it, if you glance through the questions and spend like a minute or two, you would understand that we don't need to find out the area for all the different vegetables across all the years. For each of the vegetables, probably 1 or 2 years is just needed. So finding out more than necessary is just a waste of time. So once you understand this, we'll also look at how we'll actually calculate the area for any of the year. If you look at it, if you look at any of the vegetable in any of the year, it is all represented by a trapezium, because the numbers in the y-axis, that is all the lines in the y-axis, are parallel to each other. So any vegetable in across any year will be a trapezium. Even if you're looking at something like this, it won't decrease, probably it will only increase. So if you're looking at, say, cabbage for example, and if you're looking at cabbage between 2017 and 2018, 2 sides are definitely parallel and the 2 sides are non-parallel. So that is basically a trapezium, which is the case for all the 4 years for all the 5 vegetables. So if you're calculating how much quantity of each vegetable is produced in any year, you have to just find the area of a trapezium. It is not any quadrilateral. And finding out the area of a trapezium is not very difficult. How will you find out the area of a trapezium? Area of a trapezium is basically the average of the lengths of parallel sides multiplied by the distance between them. So for example, if you are given any trapezium, for example, if you are looking at the area under the cabbage between the year 2017 to 2018, we will first find out the lengths of both the parallel sides and then find out their average and then multiply with them with the distance between those two. Another thing that you should notice in this question is that the distance is always constant. The distance is 100 units. It is given to us that the line segment from 2016 to 2017 measures 100 units. So the distance in the x-axis is always the same. So in any one particular year, that is from 2016 to 2017 or 2017 to 2018, the distance between those two y-axis is constant, and that is equal to 100 units. So if you want to calculate how much of any vegetable is produced in any particular year, you have to just find out the lengths of the y-axis, take the average and then multiply it by 100. Then you are going to get the actual vegetable that was produced in that year. So once you know this, let us go ahead and try to answer the questions that follow. The first question, how many potatoes were produced in the time period from 2015 to 2017? So 2015, 16 and 2016, 17. We just need to find out the lengths of the sides. Potato is dark blue, so it is the bottommost one. So for all the years, the bottom coordinate is 0. So 2015 it is 0, 2016 it is 0, and 2017 is also it is 0. In 2015, it is initially 45. In 2016, it is 60. In 2017, it is 80. So if you are calculating the amount of potatoes that was produced between 2015 to 16, find out this length and find out this length and take the average of those two. So the initial height of the trapezium in 2015 is 45 units. In 2016 it is 60 units, Therefore, the average length of the parallel sides is 60 plus 45 divided by 2. So that is 52.5. And again multiplied by 100, which is the distance between both the lines. So into 100. This is the amount of potatoes that was produced in 2015-16. If you are doing it for the same for 2016-17, initially the height is 60 units. This is 60 units. And in 2017 it is 80 units. That is, this length is 80 units. So what is the average of the lengths of the parallel sides? It is 60 plus 80 by 2. So that is 70. And what is the distance between the two parallel sides? This distance, as we have discussed, is always the same. It is equal to 100 units. So what is the amount of potatoes that were produced in 2016-17? It will be 70 into 100. So that is 7,000. And in the first year it is 52.5 into 100. So that is 5250. So what is the total amount of potatoes that were produced? It is 7,000 plus 5250. So that is 12250 kgs. Let us look at the next question. In this question we are supposed to find out by what percentage has the production of beetroot increased from the time period 2018-19 as compared to the time period 2017-18. So we have to understand how much beetroot was produced in 2017-18, find out how much beetroot was produced in 2018-19 and find out the percentage of increase. So we'll do the same thing. For 2017 we'll calculate the length. For 2018 we'll calculate the length of the parallel side. Take the average between these two to get the amount of beetroot that was produced in 2017-18, and we'll do the same thing for even 2019. Beetroot is brown in color. So what are the coordinates in 2017? In 2017 the lower point is over here, so that is 155, and the upper point is somewhere over here, so that is 230. In 2018 the lower point is somewhere over here, so that is 190, and the upper point is somewhere over here, which is 280. In 2019 the lower point is somewhere over here, so that is 225, and the upper point is somewhere over here, so that is 330. So if you look at the lengths of the parallel sides, in 2017 it is 230 minus 155, so that is 75. In 2018 it is 90. In 2019 it is 105. So what is the average of the parallel sides? In 2017-18 it is 75 plus 90 by 2, so this is 82.5. In 2018-19 it is 105 plus 90 by 2, so that is 97.5. So if you're looking at the amount of beetroot that is produced in 2017-18, you multiply it by 100, and if you're looking at it in 2018-19, again you multiply it by 100. So this is basically 8250 and this is 9750. So the percentage increase, if you're looking at it, will be 9750 minus 8250 divided by 8250 into 100. This is equal to 1500 divided by 8250 into 100. 1500 is 250 into 6. If you divide 8250 by 250, 1000 is 4. So 8000 is 32. So this is 33 into 100. So this is 6 by 33 into 100, or this is 2 by 11 into 100, or this is 200 by 11. So you can calculate 200 by 11, you can use your calculator to calculate it, otherwise this is going to be 1 and 90 is 8.1818%. So the amount of increase or the percentage of increase is 18.18%. Let us look at the next question. What is the difference in the amount of onion produced in 2018-19? So onion 2018-19 and cabbage produced in 2016-17. Again, for onion we will find out the lengths of the parallel sides in 2018-19. We will do the same for even cabbage and find out the difference between those two. If you are looking at onion, it is green. In 2018-19, in 2018 the lower point is 100 and the upper point is over here, so this is 155, and in 2019 for onion it will be over here. So this is 115 and the upper point is 210. This is for onion. If you are looking at the lens, this is 55 and this is 95. If you are looking at the average, it is 150 by 2, so this is 75. So the amount of onion that is produced in 2018-19 is, the lengths of the parallel sides are 55 and 95. So the average of the lengths of the parallel sides is 75. So you multiply 75 by 100, so this is 7500. This is the amount of onion that is produced in 2018-19. If you are looking at cabbage in 2016-17, what is the color of cabbage? It is blue. So for cabbage, we have to calculate it for 2016-17. So the lower point is somewhere over here. So this is 190. And this is the upper point. This is 225. In 2017, it is over here. This is 230. And the upper point is somewhere over here, 255. So the length of the parallel sides in the first year is 35. This is 225 minus 190, and in the second year it is 25, which is 255 minus 230. So the average of the lengths of the parallel sides is 35 plus 25 by 2, so that is 30. So the amount of cabbage that was produced in 2016-17 is 30 into 100, so that is 3000. So the required difference is 7500 minus 3000, which is 4500. Now let us look at the last question. What is the production of tomatoes in 2015 to 2019? So for tomatoes, for all the 4 years, we will have to calculate the lengths of the parallel sides, take their average and multiply it by 100 and then sum them up. So if you are looking at tomatoes, that is orange in color. In the first year, the bottom one is 85 and in this upper one is 120. This is for 2015. In 2016, the bottom one for orange is 105 and the top one is over here, that is 130. In 2017, the bottom one is over here, this is 130 and the top one in 2017 is over here, this is 155. In 2018, the bottom one is at 100. In 2018, we'll have to look at the orange one, right? So in 2018, the orange one is somewhere over here. This is at 155. And the top one is over here. This is 190. And lastly, for 2019, the bottom one is in the middle, this is at 210 and the top one is just slightly above, so this is 225. So there is a lot of scope for making mistakes. You should ensure that you're not making a mistake. So if you calculate the lengths in each of the years, in 2015 it is 120 minus 85, so this is 35. In 2016 it is 130 minus 105, so this is 25. In 2017 it is 155 minus 130, again 25. In 2018 it is 190 minus 135, so this is 35. In 2019 it is 25 minus 225 minus 210, so this is 15. So now you have the lengths of the parallel sides. We have to calculate the average of the parallel sides, so you are going to get only 4 values. The first one is 30 and 25, so the average is 30. This is for 2015-16. The average for 2016-17 will be the same, it is 25. For 2017-18 it is 25 plus 35, so that is 30, which is the average. And for 2018-19 it is 35 and 15, so that is 25. This is the average of the lengths in each of the 4 years. Multiply each of them with 100 to get the production of tomatoes. So the total will be 30 plus 25, that is 55, plus 30 plus 25, so another 55. So 55 plus 55 is 110, into 100 is 11,000. So the total number of tomatoes that were produced is 11,000. In this question, there is a table given in which the scores of some countries are given across 3 parameters. The parameters are income index, health index and education index. We are also told that there is something called a development index for each of these countries. Now the development index is based on the scores that each of the countries has received in income, health and education. So there is a formula that is used to calculate the development index. The formula is also given. So the development index is X into I plus Y into H plus Z into E. So we don't know the coefficients of I, H and E, but we do know that all the coefficients are either 2 or 3. They are either 2 or they are either 3. So once you find out what the values of each of the coefficients are, we can easily calculate the development index for each of the countries. Also, some of the values are missing in the table. So we will also have to fill in the values. To help us do that, we have been given some clues. So once we use these clues to first calculate the values of the coefficients, that is X, Y and Z, then if we can fill out the table, then we can go ahead and answer the questions that follow. So let us try to first find out the values of the coefficients. That is, what will X, Y and Z be? Before we do that, let us first quickly go through the clues that are given so that we can try to first find out the coefficients. We are told that the development index of none of the two countries is the same. That is, once you apply the formula, you can calculate the development index for all these countries. All of them are unique numbers. The DI for country Q is 38. So for country Q, the development index is 38. The values of I, H and E, that is the income index, health index and education index, for all of the countries are integers and they vary between 1 and 10. The value for development index is neither less than 31 or greater than 40. So the development index for all of these countries is greater than or equal to 31 and it is less than or equal to 40. The score of education index is the same for P and Q. We can assume that the education index is A. For both P and Q, it is the same number. There is exactly one country which has got a score of 10 in one parameter. So amongst all the missing values, there is one value which is 10. And finally, we are told that the development index of W is not the highest. Now, if you look at the scores of W, it scored 8 in income and it scored 9 in education. Both of these are the highest in their respective columns. That is, no country got more than 8 and no country got more than 9 in education and income and education respectively. This will first, this should raise some eyebrows for you. So let us first try to find out the coefficients based on the scores of W in income and education. If you are looking only at W, in income it received 8 and in education it received 9. And in health, suppose it has received, say, X. We know that the coefficient of income index is X, coefficient of health is Y, and coefficient of education is Z. Now, if either X or Z is 3, the development index of W will be greater than 40. How do we know this? Because if X is, say, 3 and Z is, say, 2, then 8 into 3 will be 24. And 9 into 2 will be 18. This is 24 plus 18, this is 42, which is greater than 40. We have not even added the additional composite score that they get from health. Similarly, if X is equal to 2 and Z is equal to 3, the development index of W will be 2 into 8 plus 9 into 3 plus something that they will get from health. But this itself is 2 into 8 is 16. Plus 27 is 43. So in both the cases, the development index of W will be greater than 40. But we know that development index of all the countries lie between 31 and 40. In addition to that, we also know that development index of W is not the highest. So one thing that we can say for sure is that the coefficient of income is 2 and the coefficient of education is also 2. This is something that we can conclude looking at the scores of W. Now let us try to figure out, there is one more important clue that was given to us, that the education index and education index of P and Q are the same. So if we assume that the education index of Q is A, it is A for even P. Now if you are looking only at Q, Q scored 3 in income, it has scored 6 in health and it has scored A in education. We know that the coefficient of income is 2. We know that the coefficient of education is also 2. We don't know the coefficient for health. It can be either 2 or 3. Let us call it H. Therefore, the development index of Q will be 3 into 2 plus 6 into H plus 2 into A. This we are told is equal to 38. Or if you calculate this, 6H plus 2A is equal to 32. Now as all of them are as all the coefficients are even numbers, we can divide it by 2. So this will be 3H plus A is equal to 16, or A is equal to 16 minus 3H. Now H, that is the coefficient of health, can be either 2 or 3. So if the coefficient of health is say 2, then A will equal 10. If the coefficient of health is 3, then A will equal 16 minus 9, which is 7. But A cannot equal 10. Why can A not equal 10? A cannot be equal to 10 because that is the score of both P and Q in education. Both of them have scored A. But we are told that 10 occurs only once in the entire table. So that cannot be 10, that score. Therefore, H is not equal to 2 and H is equal to 3. So now we have found out all the coefficients for both income, education as well as health. And later we have also found out the value of A is 7, which is the score of both P and Q in education. So let us try to fill out whatever values that we already know. The development index of P can be now easily calculated. The development index of P will be 5 into 2 plus 4 into 3 plus 7 into 2. This is equal to 10 plus 12 plus 14. This is equal to 36. Similarly, the development index of V can be calculated because we know all the values. So V will equal 3 into 2 plus 9 into 3 plus 1 into 2. This is equal to 6 plus 27 plus 2. That is 35. For the remaining numbers that we don't know, let us try to give some values. So for example, for R, if you assume that he has scored A, and for S, if you assume that he has scored B, T has scored C, U has scored D, and W has scored E. We'll try to calculate their development index and then try to see, because all the development index have to be unique, we'll try to figure out if we know some more values for A, B, C, D and E. The value for R will be 2A plus 3 into 3, that is 9, plus 5 into 2. 3 into 3 is 9, 5 into 2 is 10, so this has to be 2A plus 19. This is the value development index for R. For S, it will be 7 into 2 plus 3 into 3 plus 2B. This will equal 14 plus 9, 23 plus 2B. For T, it will be 3 into 2 plus 3C plus 6 into 2. This is 6 plus 12, 18 plus 3C. U will be 1 into 2 plus 3D plus 3 into 2. This is 2 plus 6, 8 plus 3D. And finally we have W, which is 8 into 2 plus 3E plus 9 into 2. 8 into 2 is 16, 9 into 2 is 18, so that is 34 plus 3E. Now we know that W is not the highest. That is one of the clues that has been given to us, which is what actually started us solving for the coefficients. So we can easily infer that the value of W has to be less than 40, because the development index of none of these countries is greater than 40. And because this is 34 plus 3E, the only possible values are 37, this is when E is equal to 1, or 40, this is when E is equal to 2. But W cannot be 40, because if it was 40, that would be the highest. So the development index of W has to be 37. Therefore, the value of E has to be 1. And this is 37. So there are only 4 numbers that we haven't been able to calculate. Now again, if you look closely, we also know one more clue, that there is exactly 110 amongst the missing values. So one of these numbers has to be 10. If you look at the values that are possible, R, if A is equal to 10, the value of R will be 39. This is possible. If B is equal to 10, the value of S will be 43. That is not possible, because the development index for S also has to be less than 40. So B is not equal to 40. If C is equal to 10, the development index for T will become 18 plus 30, which is 48. This is also not possible. If the value of U is 10, then the development index will be 8 plus 30, which is equal to 38. Although this lies between 31 and 40, 38 has already been taken by Q. So this is also not possible. So the only possible value where a number 10 can exist is when A is equal to 10. So this is 10 and the overall development index of R is 20 plus 19, so that is 39. Now let us only look at the development index which we have already calculated. The development index of S is 23 plus 2B. The development index of T is 18 plus 3C. The development index of U is 8 plus 3D. Now if you are looking at T, 18 plus 3C is a multiple of 3. Whatever is the value of C, 18 plus 3C will always be a multiple of 3. Now the only multiples of 3 which lie between 31 and 40 are 33, 36 and 39. But 39 and 36 are already taken. 36 is the development index of P and 39 is the development index of R. Therefore, the only possible value for the development index of T is 33. And when T is 33, C will equal 5. So now there are only two values which are remaining, that is of S and U. Now the value of U is 8 plus 3D. 8 plus 3D, if you look at it, it is 1 less than a multiple of 3. So the possible values for 8 plus 3D will be between 31 and 32 is 38, 35 and 32. These are the only three numbers between 31 and 40 which are 1 less than a multiple of 3. But 38 is already taken and 35 is also already taken. This is 35 and this is 38. So the overall development index of U is 32. And this would imply that 8 plus 3D is 32 or D is 8. 3D will be 24 and D will equal 8. Now we have only S left. S is of the form 23 plus 2B. Now 23 plus 2B is an odd number because 23 is odd and 2B will be even. So the possible values for S are 31, the development index of S are 31, 33, 35, 37 and 39. These are all the odd numbers between 31 and 40. 39 is already taken, 37 is already taken, 35 is already taken and 33 is also already taken. So the only odd number which is available between 31 and 40 is 31. So the development index of S is 31. This would imply that 23 plus 2B is equal to 31 or B is equal to 4. So if you are just looking at the possible values which exist, if you are removing all the values that aren't allowed, we can easily solve the missing tables. So now let us go ahead and solve the questions that follow. What is the development index of S? The development index of S is 31. Which country scored 10 in a parameter? The country which scored 10 in a parameter is R, which scored 10 in income index. What is the total sum of scores of all the countries in the health index? If you total all the scores in the health index, we will get the answer. This is 4 plus 6 is 10, 10 plus 6 is 16, 16 plus 5 is 21, 21 plus 8 is 29, 29 plus 10 is 39. So the correct answer is 39. What is the median value of DI for all the countries? Let us write down all the DI values. There will be 1, 2, 3, 4, 5, 6, 7, 8 in ascending order. So the scores are 31, 32, 33, 35, 36, 37, 38 and 39. So to calculate the median value, we will have to find out the middle term and take the average because this is odd. So we can cancel the extremes. one extreme at a time. So these are the two middle values. So the median value will be 35 plus 36 by 2, which is equal to 35.5. So if you are given a set of numbers, if the number of numbers is odd, the median term will be the middle term. So you will have to arrange all of them in ascending order, and if the number of these numbers are odd, just pick the middle term. If the number of numbers is even, like say 10, then pick the middle two terms and calculate the average to get the median. So in this case, the middle two terms are 35 and 36. So we are taking their average, which is 35.5. So the median is 35.5. In this question, we are told that Harish went to a circus, and in the circus, there were jokers from 4 different countries, A, B, C and D, and they have performed. And each of them was wearing a bow, a coat, a trouser and shoes. So Harish made up a list of which country's joker was wearing what colors bow, coat, trouser and shoes. And he has filled in the names as B1, B2, B3 and B4. So these are the 4 colors of the bows that he has noticed or he has remembered. Similarly, C1, C2, C3 and C4 are the colors of the coats that he remembered. T1, T2, T3 and T4 are the colors of the trousers. S1, S2, S3 and S4 are the colors of the shoes that he has remembered. So he has made a table like this. But after making the table, when he cross-checked with the actual information, he realized that only one color for each of the garments is correct. That is, amongst all the bows, B1, B2, B3 and B4, only one of them was correct. Similarly, amongst the coats also only one color was correct. Trousers also one was correct and shoes was also one correct. We have been given some more information, and using this information we have to figure out which country's joker was wearing what colors bows, coats, trousers and shoes. So this is a simple arrangements question. So let us first make a table, and in the table we'll make rows and columns. So this will be the colors. This will be for A, this will be for B, and this will be for C and D. This is the row for bow, this is the row for coat, and this is the row for trouser and shoe. So if you look at it, let us write down the table's names first. This is A, B, C and D. This is bow, coat, trouser and shoe. So for each of these rows, we have to figure out where all the colors will fit. So basically we have to figure out where B1 comes. It comes in one of the 4 countries, because all the bows, that is all the elements of the first row are B1, B2, B3 and B4, but not necessarily in that order. We know that only one of them actually goes into the right place. So let us first go through all the clues. When we are going through all the clues, we'll kind of note down what are the important clues, what are the non-important clues, and then keep on reiterating. So the first one is that the color of B3 is in a column which is to the right of the column of C1. B3 is the bow, this is B3, and this is to the right of the column of color C1. So C1 is somewhere over here. To the right of it, we'll have B3. Again, we don't know where is C1. If we had known where C1 was, we can easily find out where B3 was, but we don't know it. Next question is, C4 is in the column which is 2 places to the right of column T1. So T1 is trouser. There is one column to the next of it, and there is 2 columns to the next of it. Here we have C4. C4 is over here. So basically there is a gap of 2 between T1 and C4, which in turn is 1 to the right of column S3. So this in turn is 1 column to the right of S3. So S3 is somewhere over here. Now you know that we have figured out that there are 1, 2, 3 and 4 columns. So the first element over here, this has to be S3. The one to the right of it has to be T1. And C4 has to be the 4th element for country D. So this we have completely figured out, the point 2. T3 is in the column which is 2 places to the right of column B1. So you have, this is completely done, you have B1 over here, and 2 places to the right of B1, this is one column and this is another column. This is where you get T3. This is the bow row, this is the coat row, and this is the trouser row. So T3 is somewhere over here, which in turn is to the left of column C3. So you have T3 is in the column over here, which is 2 places to the right of column B1. So this is B1, which in turn is to the left of column C3. So in the middle of this is C3. Now we have some confusion over here because C3 over here you are only able to account for 3 columns. So they can be either the first, second and third column, or they can be the second, third and fourth column. So they can be either these 3 elements or they can be these 3 elements. That we are not so sure because we can only account for 3 columns. But we'll keep this in mind. We'll come back to it when we get more information. Let us look at the next clue. B2 is in the column which is to the right of column of color S2. So you have B2. This is in the column which is to the right of the column S2. So then you have S2. So this is S2 and to the right of it you have B2. So you have this information, and you have the B1, C3 and T3 information. Other than this you have no other information and you have to figure out the points for each one of them. But there is one more information which we are ignoring, which is that in each of the rows we have only one element which is in the correct place and all the other elements are in the wrong places. So if you look at it, code C4 is in the correct place. Over here also C4 was in the country D. Over here C4 is in the correct place. So we have identified which is the element which is in the correct place. And all the remaining 3 elements have to be in the wrong places. This is the first important thing that we have figured out. This will tell us many things. This will tell us that, for example, if you are looking at B1, C3 and T3, we thought they have to be either in the first, second and third column or they have to be in the second, third and fourth columns. Now you can cancel or rule out the second, third and fourth column because in that case C3 will be over here and there will be 2 codes which are in the right places. This is not possible. So C3 cannot be here. So this would imply that C3 is over here and T3 would be here and B1 is over here. Now you have identified the correct place for even the bows because B1 is in the first column. You have identified the correct place for even trousers because T3 is in the first column. So you can't have any bow or coat or trouser come back into the correct position. This would imply that, for example, in coats, C1 cannot be in the first column because then you will have 2 coats in the same correct order. So that is not allowed. So this has to be C2 and this will be C1. If you are looking at trousers, you have 3 of them, B2, B3 and B4, which are not yet identified, but it is difficult for us to figure out the correct order when there are 3 bows remaining. But if you look at trousers, for example, the trousers that you need to fill in are T4 and T2. The last element, this cannot be T4 because in that case again you will have T3 and T4 in the correct places. So this has to be T2. So this would imply that this is T4. Once you have even this, let us look at what are all the clues that we can use still. We have used this clue. So there are only 2 clues remaining with respect to B2 and S2 and B3 and C1. We know C1 over here. So this has to be B3. So this clue also has been used up. Now amongst the bows, what are the bows that are remaining? We have B2 remaining and we have B4 remaining. B2 cannot go into its correct place. So B2 has to go into its wrong place. So the second item, this over here, has to be B4. Because if B2 goes into the second column, then you will have 2 bows in the correct place, which is not allowed. So we have now identified the places for all the bows, all the coats and all the trousers. There is only one clue remaining with respect to B2 and S2. So if B2 goes into the third column, S2 will go into the second column. So now you have 2 shoes remaining. They are S1 and S4. Have we identified the correct place of the shoe? We haven't identified because S3 is in the first column. This is in the wrong place. S2 is in the second column. So yeah, now we have identified even the shoe which is in the correct column, that is S2. So S1 and S4, both of them have to go into the wrong places. This would imply that S4 will go into the third column and not the fourth column, and S1 will go into the remaining column. So now we have identified all the bows, all the trousers, all the coats and all the shoes. Now that we have got the entire table correct, let us go ahead and answer the questions that follow. What is the color code of the bow which belongs to the joker from A? The joker from A, the bow is B1. This is actually the correct color code. Similarly, the correct color code for coat is C4, for trouser is T3 and for shoes is S2. Joker from which country wore S4 as the color coded shoes? The country is country C. What is the country of the joker whose shoes correctly were noted by Harish? The shoes that were correctly noted is S2 and the joker belongs to country B. Joker of which country wore T4 as the color coded trousers? T4 was worn by joker of country A.
Google search Krakow CAT formulas PDF. Click on the first link. You will get a list of topics for CAT. Click on one of the topics. Download the PDF to get a list of formulas for the topic.
The set is P, Q, R and S are four brothers who went to an ice cream parlor. Each of them ate a different number of ice creams among 1, 2, 3 and 4. Since their mother did not allow more than one ice cream per day, they decided to report distorted information to her. So each one of them decided to be a truth teller or a liar or an alternator. Truth tellers always tell the truth, the liars always make up false statements. Alternators, however, alternate between making true and false statements. So one statement would be true, one statement would be false, or the first will be false, the second will be true. Among the four, there is at least one truth teller, one liar and one alternator. Each of the four brothers make the following statements. P, the difference between the number of ice creams eaten by me and that by R is 2. S is not a liar. Q says exactly 2 of us tell the truth. R ate 1 ice cream while P ate 3 ice creams. R says only one of us is an alternator. S ate 4 ice creams. S says I am an alternator, only one of us is a liar. Now if that is the case, if I have to actually consider P, Q, R, S, so they say this is P, Q, R and S, I have to consider the truth value of each of them. Which one should I choose? Whose statement should I choose? Actually I'll use double this because this double length, because each has 2 statements. So basically P1, P2, then Q1, Q2, R1 and R2, and then you have S1 and S2. So these are P, Q, R, S's statements. Now if I have to pick out first value to set, essentially the first value I set should be such that it reduces the number of cases as much as possible. So the one which should I pick? So basically the way you solve is that you say that okay, maybe P is the truth teller, Q is the truth teller, R is the truth teller, S is the truth teller. We know that there is one truth teller, one alternator, one liar as such. So we can start off by assuming one case till we find a contradiction and stop. But instead of picking P, Q, R and S, I actually want to pick S. Why is that the case? Because S says he's an alternator. Now if he says he's an alternator, it becomes easier rather than if one of the others says that somebody else is something else, it becomes harder. Because if I know that okay, if S said I am a truth teller or if S said I am a liar, then you know that there are far fewer cases, because essentially either he is telling the truth or lying. So if S is an alternator, I have 2 cases. S is an alternator or S is not an alternator. Because if this statement is a lie, if the first statement is false, that means S cannot be a truth teller, because a truth teller will not call himself an alternator. So I essentially get only 2 cases with him. S is either an alternator or he is a liar. He cannot be a truth teller. So let us consider the 2 cases. S is an alternator or S is a liar. Okay. Now if S is an alternator, what is the first scenario? If S is an alternator, the first statement is true. The second statement will have to be false because he is an alternator. Then he says that only one of us is a liar, which means that there are 2 liars in this case. Similarly, let us consider, I'll just slightly move it down because you might not be able to see because of the writing. So the second, this is if S is a liar. If S is a liar, then both of his statements are false. So this would be false, this would be false. So in either scenario, I see that the second statement is false, which means that in all possible cases, there will be 2 liars. So either S is an alternator or S is a liar. Still out of the 4, there are 2 liars, which means there is one alternator, exactly one alternator, and one truth teller. So one alternator and one truth teller in all this as such. So if this is the case, let us try to figure out how we can actually get a true false kind of a statement given the fact there are 2 liars, one alternator and one truth teller. So S says only one of us is a liar, which is false. He says he is an alternator. Now suppose he is the alternator, we have to find out 2 liars from the remaining this. Let's take a look at P statements. P statement is that S is not a liar. In this first case, this becomes true. Now if this is true, what happens? If this is true, then since there is only one alternator and you have to have two liars, as there is only one alternator, P's both statements have to be true, and that would mean that P is a truth teller. Why can't he be an alternator? Why can't it be F and true as such, false and true? Because only one alternator is there, which means that P is the truth teller, which means that both of these guys are liars. So what is the statements that they have made? Our statement is only one of is an alternator, but that is actually a true statement, because according to the conditions only one of the statements is correct. So this means that this is true, which means that this case cannot be the case. Where S is an alternator cannot be the case, because we reach a contradiction almost immediately, because in that case our statement has to be true, and if our statement is true, that means that P cannot have one true statement there. So we reach a contradiction, which means that S is not an alternator, which means that S is a liar. Now if S is a liar, what happens? P's second statement becomes false. That means P's second statement is false, means that P has to be either an alternator or a liar now. So there are two liars, one liar is S, one alternator, one liar could be P, or he could be the alternator, he cannot be the truth teller. Q statement, let's take a look at Q's first statement. Q's first statement is exactly two of us tell the truth. Now this cannot be true, because we know that two liars are there, so there cannot be two truth tellers. So we know that this is also false. Now essentially, if you look at the statements, P's one statement is false at least, Q's one statement is false at least, and we know we have one truth teller whose two statements have to be true. The only way we can actually have a truth teller is if R is the truth teller, because P has at least lied once, Q has at least lied once. So the truth teller has to be R. So S has to be the liar, the truth teller, R has to be the truth teller. Now let us try to figure out who is the other liar and who is the other alternator as such. So Q could be the alternator and the statements could be F and T, and P could be the liar, or P could be the alternator and the statements are T and F, and Q is the liar as such. So let's try to figure out who is lying, who is not. First thing that we realized is that only one of us, our statements are true. Now if our statements are true, R says only one of us is an alternator already considered. S ate 4 ice creams, which means that in this particular case, S ate 4 ice creams. So we were able to arrange that particular portion of how many ice creams S ate. Okay. Now these statements are done. Now let us try to figure out who among P and Q is the alternator and who is the liar as such. Okay. So let's take a look at the statements whose value we have not deduced already, which is P's first statement and Q's second statement. P's first statement is the difference between the number of ice creams eaten by me and R is 2. Q's second statement is R ate 1 ice cream while P ate 3 ice creams. So essentially one of these guys is telling the truth and one is lying, which means that one is an alternator and one is a liar. So that basically means that one of these has to be true and the other has to be false. Now consider the first case, okay? Consider the case that P is telling the truth and Q's second statement is false. If P's first statement is true, that the difference between the number of ice creams eaten by me and R is 2 and Q's statement is false, what does that mean? That means that R didn't eat 1 ice cream and P didn't eat 3 ice creams. If the difference is 2, that means and 4 is over here, and the difference is 2, that means that P and R ate 1 and 3 in some order, and Q's statement is false, which means that R ate 3 and P ate 1. On the other hand, if I say that Q's second statement is true, for example, if I say Q's second statement is true, then P's first statement has to be true. Then we reach two alternators kind of a situation, which is not possible. So if Q's second statement is true, P's first statement has to be true. So that means Q's second statement is false, because then we will only then can we actually satisfy the condition, and P's first statement is true. They are not internally contradictory. One thing that many people might actually have gotten confused is that they might have thought that they are true at the same time and false at the same time, but not the case. Q's second statement implies P's first statement, but the reverse is not true. P's first statement does not imply Q's second statement. Why? Because there are two possibilities. It could be that R ate 1 ice cream and P ate 3 ice creams, or R ate 3 ice creams and P ate 1 ice cream. So that basically means that P's statement is true and Q's statement is false. So the final order is like this, where P is the alternator and Q is the second liar. Now what does this mean? This means that R didn't eat 1 ice cream and P didn't eat 3 ice cream, but the difference is of 2, and we already know S ate 4, which means that the gap of 2 can only be between 1 and 3 and 2 and 4. 4 is already gone, so it has to be 1 and 3, and R didn't eat 1 ice cream, so it has to be P who ate 1 ice cream. R ate the 3 ice cream, which means that Q ate 2 ice creams. Now if we are able to figure this out, it becomes very easy to solve all the questions. So let's take a look at the questions as such. Who ate the most number of ice creams? S ate the most number of ice creams. He ate the 4 ice creams. If we look at the second question is who among the 8 statements made, how many were lies? Since there were 2 liars, that is 4 statements, 1 alternator, that is plus 1, that is 5 statements, 1 truth teller and 1 alternator statement is 2. So out of the 8 statements, 5 were lies. Okay, so the right answer over here is 5. The next question is which of the following is definitely true? So which of the following is definitely true over here? Sorry, I think there is a lot of writing over that. So I'll just try to erase that part of writing over this. Yeah. So the third question is that which of the following statements is definitely true? And I think this is where some of the students faltered. S made the most number of false statements. See, there are 2 liars, so both of them made the most number of false statements, which is the max value, which is 2. So this is true since S is one of the 2 liars. S and Q both made most number of false statements. So this is true as such. P made the most number of true statements. No. R made the most number of true statements. Q ate more ice creams than R. Not true. Q ate 2 ice creams, R ate 3 ice creams. The number of ice creams eaten by P and S together is more than that eaten by the other 2. No, Q and R together is 5, P and S is 5. So both are equal. So it's not, this is also not true. So the which of the following is definitely true? Only option A is definitely true. I think many of you faltered because I think some thought that okay, there are 2 values which are at max, so you can't say that these are he made the most number of false statements. But the most number of false statements you can make is 2, and he made those number of false statements. And then we have the last question. What is the total number of ice creams eaten by Q and S together? That would be 2 plus 4, that is 6.
In this question, we are told that there is a university and there are a total of 500 students who are studying in this university. It has 2 streams. It has medical and science, and we are told that a student can be part of one of these 2, but he can't be part of both of them. But amongst the different streams, a survey was conducted where the inclination of a student to drink either tea or coffee is known. So if you look at the clues, you will understand that there are some students who like only tea, there are some students who like only coffee, and there are some students who like both, and some students who don't like either of the 2. So whenever you see this kind of an overlap between the interest of students, you know that this is a Venn diagrams question. But here, because there is no overlap between medical and sciences, there are 2 Venn diagrams. One Venn diagram will look at all the students in medical stream, and one Venn diagram which will look at all the students in science stream. So let us first draw both the Venn diagrams. So this will represent all the students who are in medical, and this will represent all the students who are in science. And in the middle of each one of them, you will have 2 circles. Each of the circle will represent one of the interest, that is either tea or coffee. Similarly, you will have 2 more circles. This is also for tea or coffee. So this is medical and this is science. The total number of students in both of them is 500. Now this is tea. So this circle represents the students who like tea and who are in medical stream. This circle will represent the students who like tea and are in science. Similarly, this is coffee in both the 2 different streams. Now the first thing that we are told is that among those who pursue medical, 25% like only coffee. So 25% is 1/4. So let us assume that the total number of students in medical is 4A. Then the number of students who like only coffee is A. And equal number of students in both the streams don't like both coffee and tea. So the number of students who lie within the rectangle, within each of the rectangle, but outside the circles are the same for both medical and science. So if you're part of one circle, this means that you like tea. If you're part of this circle, it means that you like coffee. and the overlap means that you like both tea and coffee. The area which is outside both the circles but inside the rectangle represents the students who are in that particular stream, in this case medical, and who don't like either tea or coffee. Similarly, this will represent the number of students who don't like both tea and coffee and who are in science stream. A total of 250 students like tea and 220 students like coffee. So the total number of tea drinkers across both the streams is 250 and coffee is 220. Science has 50 more tea lovers than medical. That is, the number of tea drinkers in medical and science, if you sum both of them, you are going to get 250. But we are told that science has 50 tea drinkers more than medical. So this would imply that the number of tea drinkers in science is 150 and the number of tea drinkers in medical is 100. Because the sum is 250 and the difference is 50, this you can easily equate and calculate that one of them has to be 150 and the other has to be 100. The number of students who like both tea and coffee in medical is 30 less than in the science stream. So let us assume that the number of people who like both tea and coffee in medical is B. Then the overlap of tea and coffee in science is B plus 30. In science stream, the number of students who like coffee is equal to the number of students who like tea. In science stream, the number of people who like tea is 150. This we have calculated. Therefore, the number of students who like coffee is also equal to 150. Now, because the total number of medical students, we have assumed this to be equal to 4A, we can easily calculate what is the number of students who like only tea. This will be 100 minus B. That is the total number of tea drinkers minus the overlap between tea and coffee. And because in medical we have 4A students overall, the number of students who don't like both tea and coffee in medical will be 4A, which is the total, minus 100 minus B plus B plus A. This will represent the number which is outside both the circles but inside the medical stream. This, if you equate, this will be 100 plus A. So this will be 3A minus 100. So the number of students who are in medical but don't like both tea and coffee is 3A minus 100. But we know that that is the same in both medical and science. That is, the number of students who don't like both tea and coffee is the same. So even this has to be 3A minus 100. Now, what is the number of only tea drinkers? That will be equal to 150 minus B plus 30 in the science stream. So this will be 120 minus B. It will be the same even in only coffee drinkers. Again, it is 150 minus B plus 30. So this is also 120 minus B. Now we have two equations. One equation that we have is that the total number of coffee drinkers is 220. The second thing we have is that the total number of students in medical and science is 500. So we'll get two equations in A and B. Once we solve them, we are going to get the values of A and B, which we can use to answer the questions that follow. What is the number of coffee drinkers overall? The coffee drinkers in science is 50. So the coffee drinkers in medical will be 70, which is 220 minus 150. That would imply that A plus B is equal to 70, because that is the number of coffee drinkers in medical. We also know that the total number of students across both the streams, medical and science, is 500. So that would imply that the total number of students in medical is 4A, and the total number of students in science will be 120 minus B plus 30. So that is equal to 150 plus 120 minus B plus 3A minus 100. This will equal 500. Now we can simplify this as 4A plus A is 7A. 7A plus 170 minus B is equal to 500. Or you can again simplify this as 7A minus B is equal to 330. This is the first equation and this is the second equation. Now using both these equations, we can sum them up to get 8A is equal to 400 or A is equal to 50. Similarly, then we can find out that B is equal to 20. So now for each one of them, we can calculate the individual values. That is, we know that, for example, the number of only tea drinkers in medical is 100 minus B, that is 80. The common number, that is the number of students in medical who like both tea and coffee in medical is B, so this is equal to 20. The number of students who like only tea in medical is A, so that is equal to 50. The number of students who don't like either of them is 3A minus 100. This is equal to 150 minus 100. So again 50. This is also equal to 3A minus 100. So this is equal to 50. 120 minus B will equal 100. B plus 30 will equal 50. And 120 minus B will again equal 100. So now let us go ahead and answer the questions that follow. What is the number of students in science stream? The number of students in science stream is 500 minus 4A. This is the number of students in medical. So this will equal 500 minus 200. So that is equal to 300. What is the number of students who neither like tea nor coffee? That is 50 in medical stream and 50 in science stream. So the total will be 100. What is the number of students who like both tea and coffee? That is 20 plus 50, so that is equal to 70. How many students in science stream like only tea? In the science stream, the number of people who like only tea and not coffee will be equal to the number which is part of this area, that is equal to 100. So the correct answer is 100. In this question, we are told that there are two friends, Arun and Bipin, and they're playing a game. The game involves a certain number of coins which are there on the table, and each one of them has to pick some coins in his or her turn. Now, the player who picks the last coin loses the game, and we have to assume that both the players play this game very logically. So in this kind of games, we can always find a rule such that if the number of coins on the table are say X, then based on, because both of them are playing logically, we can figure out before the game starts who is definitely going to win the game. For example, if the number of coins on the table initially are 1 coin, then the person who is starting the game will lose. So this is like the loser table. We'll represent F as the person who has to pick the coin first, and S as the person who has to pick the coin second. So if there is only 1 coin on the table, then definitely the person who has to pick the coin first will lose, because he has to pick the 1 coin that is left. Similarly, if there are 2 coins on the table, then the person who is picking first will pick 1 coin, and then there will be only 1 coin left, which will have to be picked by the second person. So if there are 2 coins on the table, then definitely the person who is picking second will lose. So the number over here represents the number of coins on the table, and the alphabet will tell us who is losing the game. Now suppose there are 3 coins on the table. Then the person who has to pick first is going to pick 2 coins, and he will leave 1 coin which has to be definitely picked by the person who is picking second. So again, the person who is picking second loses. Similarly, if there are 4 coins, again the person who is picking first in this case will pick 3 coins and leave 1 coin on the table. So he will always try to leave 1 coin on the table which has to be picked by the person who is picking second. So even if there is 4, the person who is picking second will lose. Now how many coins can a person pick? He can pick at least 1 coin and at most 15 coins. If you continue doing this, if there are 15 coins on the table, the person who is picking first will pick 14 coins and leave 1 coin. So again the person who is picking second will lose the game. Now if there are 16 coins, what will happen? If there are 16 coins, again the same thing will happen, where the person who is picking first will pick 15 coins and leave 1 coin. So again the person who is picking second will lose the game. Things will change when there are 17 coins on the table. Why will they change? Because the person who is picking first can pick only 15 coins at max. So if he picks 15 coins, there will be 2 coins left on the table, and the person who is picking second is also a logical guy. So this guy is going to pick only 1 coin and leave 1 coin back on the table, which has to be picked by the first person. If you look at it, after the first 16 coins are done, the table basically gets inversed. That is, if there are 17 coins on the table, and if the first person picks up say 5 coins, then it is equivalent to having 12 coins left on the table, and the person who is picking second is basically the person who is picking first. And in that case, the person who is picking second will also lose. Just to make it clearer, suppose the person who is picking first is A and the person who is picking second is B. If there are 17 coins left on the table and the first person picks 5 coins, this is equivalent to a game in which there are only 12 coins left, and instead of A picking the coins, B has to pick first. Then if there are 12 coins on the table and B has to pick first, then who is going to win the game? B will obviously win the game because he is going to pick only 11 coins and leave 1 back on the table. Similarly, if there are 17 coins and whatever the number that A picks, A can pick 2 coins, A can pick 3 coins, A can pick 15 coins, B will always have a chance where he'll pick some coins and will leave only 1 coin on the table. So irrespective of what the first person does, the second person always has a choice of picking the number of coins in such a way that he'll leave exactly 1 coin on the table. So when it is 17, the person who picks the coins first will lose. We can again do the same for 18 coins. If there are 18 coins on the table, the person who is picking first will pick 1 coin and he'll leave 17 coins on the table. Now when the person who is picking second comes to the table, he will see 17 coins on the table. This is exactly the same situation as earlier. It is just that the persons have changed. Now the person who is picking second, in this case say B, has 17 coins on the table and he has to pick. Irrespective of how many coins he picks, the person A, who is the other person, can always pick number of coins in such a way that he will leave only 1 coin on the table. So when there are 18 coins on the table, the person who is picking second will lose. Remember again that this is the loser table. Similarly, if it is 19, the person who picks first will pick 2 coins and he'll leave 17 coins on the table, and the cycle will again repeat. So when there are 17 coins left on the table and somebody is coming to pick, irrespective of how many coins he picks, the other person can ensure that the first person will come back and see 1 coin left on the table. So even when there are 19 coins, the person who is picking second will lose the game. This will again continue. When there are 31 coins left on the table, what will happen? The person who picks first will pick 14 coins and he'll leave 17 coins on the table. So the person who is coming second will have no choice. Irrespective of how many coins he picks, he will be left with 1 coin at the end. So even for 31, the person who loses is the person who picks the coin second. The case is same for even 32. In this case, the first person will pick 15 coins and leave 17 coins on the table. So again, the person who picks second will lose. But things will again change when there are 33 coins. Because when there are 33 coins and the first person comes to the table, he can pick a maximum of 15 coins, which will leave 18 coins on the table. And when there are 18 coins on the table, the person who comes second will pick 1 coin. And then he'll leave 17 coins back on the table. Irrespective of how many coins the first person will pick, the second person can ensure that he picks the number of coins in such a way that 17 coins are left on the table. And when 17 coins are left on the table and the person comes to pick it, he is going to definitely lose. So for 33 coins, again, the person who picks first will lose. So as you can see, there is a pattern emerging. The pattern that emerges is that for every 16 numbers, the cycle changes. And the person who is picking first will definitely lose only in one case. He will lose if the number of coins are of the form 16k plus 1. In every other case, the person who picks first can ensure that he is definitely going to win. So for example, he'll definitely lose when the number of coins is 1. He'll definitely lose when the number of coins are 17. And he'll definitely lose when the number of coins are 33. In every other case, he's going to ensure that he'll win. Because he's just going to leave 1 coin on the table. He'll either leave 1 coin, or he'll leave 17 coins, or he'll leave 33 coins, and so on. So whenever n is equal to 16 plus 1, the person who picks first will lose. In every other case, the person who is second will lose. All questions of this sort can be formulated into a cycle which is similar to this. The numbers will change, but essentially the gist of it or the way to solve it will remain the same. Now let us go ahead and try to answer the questions that follow. Arun and Bipin decide that Arun will pick the coin first. So Arun is first and Bipin is second. Further, Bipin offers Arun 4 choices for the total number of coins. Which of the following number of coins should Arun not agree to? So if you remember what you have just discussed, if the number of coins is of the form 16k plus 1, Arun will definitely lose. In every other case, Arun is definitely winning. So amongst the 4 options that are given to us, we just have to figure out which of them is of the form 16k plus 1. So from all the 4 options, we'll subtract 1 and we'll divide that number by 16. If it is a perfect number, if 16 divides that number perfectly, then Arun should not agree to that number. In the first case, we have 1347. 1347 minus 1 is 1346. This clearly is not divisible by 16 because 46 is not divisible by 4. So Arun can agree to this number because this is not of the form 16k plus 1. So if that is the number of coins, Arun can ensure that he is going to win. If you are looking at 1495 and we subtract 1 from it, we are going to get 1494. Again, 94 is not a multiple of 4. So we know that 1494 is also not divisible by 16. So Arun can agree to even this. So this is also not the correct answer. Basically, we have to figure out which one of these should Arun not agree to. If you are looking at 1249 and you subtract 1, it is 1248. If you divide 1248 by 16, this seems to be a multiple of 16 because 1280 is 16 into 80. So 1248, which is 32 lesser, is equal to 16 into 78. So 1249 is of the form 16k plus 1. This is 78 into 16 plus 1. So this is the number that Arun should not agree to. Because if the number of coins are 1249, irrespective of how many coins Arun picks, Bipin can put a strategy in place such that Bipin will always win. So this is the correct answer. But just for completion's sake, let us look at the last option also. 1177 is equal to 1176 plus 1. 1176, if you divide by 4, this is equal to 294 into 4. This is equal to 147 into 8. So as you can see, 1176 is also not a multiple of 16. It is a multiple of 8 but not a multiple of 16. So this is also not of the form 16k plus 1. So of the 4 options, only 1249 is of the form 16k plus 1. So if the number of coins is 1249, Arun will definitely lose. So he should not agree to this number of coins. Let us look at the next question. If it is known that Bipin was the first person to pick up the coin. So Bipin picked up, Bipin is first and Arun is second. And he picked up 9 coins. Which of the following cannot be the total number of coins? So Bipin has to go first and Bipin picked up a certain number of coins. So Bipin picked up 9 coins. Now if Bipin has picked up 9 coins, Bipin knows that after picking up 9 coins, Bipin is definitely winning. So if say the initial number of coins were 16k plus p, after Bipin picked up 9 coins, the number of coins left will be of the form 16k plus 1. Because after Bipin picked up 9 coins, it is similar to the case that there are some 16k plus some coins left and Arun has to go first. Now if Arun has to go first and Arun is definitely losing, that is Bipin is definitely winning, it would imply that after Bipin has picked up his 9 coins, the number of coins that are left on the table is 16k plus 1. In every other case, if the choice or if the option is with Arun when he is going to pick up the coins second, then he can put in a strategy such that he will win. The only case in which Arun will definitely lose is when the number of coins left are 16k plus 1. So after Bipin has picked up 9 coins and when Arun is going to pick up his coins, the number of coins that are left should be of the form 16k plus 1. So the original number of coins should be of the form 16k plus 10. Now we'll look at all the options that are given and we'll try to identify which of these are not of the form 16k plus 10. So we'll do the same thing that we have done in the first case. We'll subtract 10 from each one of them. We will see if that number is divisible by 16. If it is divisible by 16, then that is not the correct answer. In the first case, the option is 250. If you subtract 10, it is 240. This is equal to 15 into 16. So this is a multiple of 16. So this is not the correct answer. If you're looking at the second one, it is 330. If you subtract 10, it is going to be 320. So this is also not the correct answer because 320 is 16 into 20. In the third case, it is 282. If you subtract 10, it will be 272. This is equal to 16 into 17. So this is also multiple of 16. So this is also not the correct answer. Finally, you have 500 coins. 500 minus 10 is 490. 490 is not a multiple of 16. because 480 is 16 into 30, so 490 is not a multiple of 16. What we can understand is that if there are 500 coins on the table and if Bipin goes and picks 9 coins, then there will be 491 coins. This is of the form 16k plus 11. Now Arun has to go and pick the coins. Now if the number of coins are of the form 16k plus 11 and Arun is going to pick the coins, Arun can ensure that Arun will always win. So the number of coins cannot be 500, which is actually the answer, because we have to pick which of the following cannot be the total number of coins. So this is 500. Let us look at the next question. The players agree to rework the rules of the game. The last player to pick the coin from the table wins the game. Bipin will be the first person to pick up the coin. So Bipin is first. All the other rules remain the same. If it is known that Arun won the game, so Arun, who is second, won the game. So the person who was picking second won the game. Then the number of coins on the table initially could be all but. So again we have to pick up which of this cannot be the number of coins on the table. Cannot be. Let's just remember that. So let us again first devise what are the rules of the game, as in what is the cyclicity that is being repeated here. If the number of coins on the table initially are 1, Bipin goes to pick up first and he will always win. So here we are going to look at winner. Who is going to win if the number of coins is 1? If the number of coins is 1, the first person will go and pick up all the coins, so he is definitely going to win, because in this case the person who picks up the last coin will be the winner. If there are 2 coins left on the table, again the first person will go and pick up all the 2 coins, so he will win. This will continue. If there are 15 coins left on the table also, the first player will go and pick up all the 15, so he is going to win. But if there are 16 coins on the table, here there will be a catch, because the player can't pick all the 16 coins, and how many ever number of coins that he picks, the second person can go and finish off all the coins on the table. So for example, if the first person picks up only 1 coin, then there will be 15 coins left which the second player will pick up. If the first person goes and picks up 10 coins, then there will be 6 coins left which the second person will go and pick up. If the first person picks up 15 coins, there will still be 1 coin left which the second person will go and pick up. So irrespective of how many coins the first person will pick up, the game will be won by the second person. Now if there are 17 coins left on the table, the first person can strategically go and pick only 1 coin. So he leaves 16 coins on the table. So the second person will now go, he'll see 16 coins on the table. Now irrespective of how many coins the second person will pick up, there will be some coins left on the table which the first person can pick up, because this is exactly the same as the case earlier when there are 16 coins left. So when there are 17 coins left on the table, again the first person will go and win the game. If there are 18 coins, the first person will go and pick up 2 coins. He will leave 16 coins on the table and the second player cannot pick all 16 coins, so again he is going to lose. So if you notice it, this is exactly the same. The cyclicity is also the same. The cyclicity continues for 16 numbers. Now the first person will win the game for all the cases except in the case when n is equal to 16. So when n is equal to 16 k, the second player will win. In every other case, the first player will win. Now we are given that if it is known that Arun won the game. So if it is known that the second player has won the game, then it would imply that the number of coins on the table is a multiple of 16. Then the total number of coins can be all but. So we have to identify which of these is actually not a multiple of 16. That we can easily do. You can even look at your calculator, divide each one of them by 16 and you will figure out which of them is a multiple of 16. So for example, in this case, 3792 divided by 16, this is 237, so this is a perfect multiple, so this is not the answer. In the second case, it is 3888 divided by 16, this is also 243 into 16, this is also a multiple of 16, so this is also not the correct answer. If you are looking at 3824, this is 239, this is also a perfect multiple of 13, so this is also not the correct answer. If you are looking at the last case, you would think that that is the answer because the first 3 are not the answer. This is 196.5. So this is not a multiple of 16, so this can be the correct answer. So if the number of coins is 3144, the person who picks the coins first will win the game because this is not a multiple of 16. So the first person can devise a strategy in which he will always win the game. Now let us go ahead and answer the last question. Now the players agree to rework the rules. Each player can pick a minimum of 3 coins and a maximum of 10 coins. So this is between 3 and 10. Initially it was 1 to 15, now it is 3 to 10. The last player to pick up the coin loses the game. This is same as the initial rules. So the last player who will pick the coin will lose. If the number of coins to pick up are less than 3, that is 1 or 2 coins are left, then the other player loses the game. Further, it is known that Bipin picks up the first coin. So Bipin is first and Arun is second. It is known that Arun has won the game. So the player who has won is the player who has picked the coin second. Which of the following could not be the number of coins initially on the table? So again we have to look at which of the following cannot be the number of coins on the table. So we'll do the same thing again. We'll try to figure out the cyclicity of the numbers of the rules. How many coins should be there on the table for the first person to win? How many coins should be there on the table for the second person to win? And so on. Let us start with 1. We are looking at the winner again. If there is 1 coin left on the table, then the first person is going to win the game. Because if there is 1 or 2 coins left on the table, the first person is going to win. If there are 3 coins left on the table, then the first person will obviously lose the game, because he has to go and has to pick up all the 3, and whoever has picked the last coin loses. Even if there are 2 coins, the first person will win. When there are 3 coins, then the first person will lose and the second person will win. When there are 4 coins left on the table, the first person can go and pick up 3 coins, and then there will be 1 coin left, and the second person will come, and because there is only 1 coin left, it would imply that the person who has picked the coins first will lose. So even in the case of 4, because the number of coins left after he has picked up his coins is less than 3, he is going to lose. If there are 5 coins, the first person can go and pick up 3 coins, which would leave 2 coins on the table, and the first person will lose. Or he can pick up 4 coins, in which case 1 coin will be left on the table and again the first person will lose. Or the first person can go and pick up all the 5 coins, and because he has picked up the last coin, again he is going to lose. So in all the 3 cases, the person who is picking second is going to win. When there are 6 coins left on the table, the first person can go and pick up 3 coins. Now there are 3 coins left on the table, and the second person has to go and pick up all the 3 coins. So when there are 6 coins left on the table, the person who is picking up first will win. When there are 7 coins left on the table, the first person will go and pick up 4 coins, and he will leave 3 coins on the table. So again the first person is going to win. If there are 8, the first person will pick up 5 coins and leave 3 on the table. Again he will win. This will repeat till, for example, there are say 13 coins. If there are 13 coins left on the table, the first person will go and he'll pick up 10 coins and he'll leave 3 coins on the table. Then who is going to win? The person who picks up first is going to win. If there are 14 coins left on the table, the first person will go and he'll pick up 10 coins. Now there are 4 coins left on the table. The second person will come and he can pick up 3 coins, which would leave only 1 coin, which is less than the 3 minimum that we need. So again the first person is going to win. If there are 15 coins left on the table, the first person will go and again pick up 10 coins. Now once he picks up 10 coins, there are 5 coins left on the table, and the second person goes to the table, there are 5 coins left on the table, and irrespective of how many coins the second person will pick up, he is going to lose. So the first person will again win the game. If there are 16 coins left on the table, things will change. If there are 16 coins left on the table, and if the first person goes and picks up 10 coins, there will be 6 coins left, and the second person can pick up 3 coins. Now if the first person doesn't pick up 10 coins and say he picks up only 9 coins, the second person will now go and pick up 4 coins. So irrespective of how many coins the first person picks up, the second person can pick up X number of coins such that he will leave 3 coins on the table. So if there are 16 coins left on the table, the second person will definitely win. So now you can see again a cyclicity. What is the cyclicity that you are seeing? In this case, because there are 3 and 10, the cyclicity will be for 13. So the first 13 are F, F, S, 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 and F and F. So if you divide the number of coins by 13 and you find the remainder, if the remainder is 1, the first person will win. If the remainder is 2, the first person will win. If the remainder is 3 or 4 or 5, the second person will win. If the remainder is 6 or 7 or 8, 9, 10, 11 or 12, the first person is again going to win. If the remainder is 0, that is if the actual remainder is 13, again the first person will win. When you have 14, it effectively means that the remainder is 1. So again the first person will win. If it is 15, the remainder is 2. Again the first person will win. If it is 16, that is the remainder is 3. Second person will win. If it is 17 also, when the remainder is 4, the second person will win. If it is 18, when the remainder is 5, again the second person will win. And again it will keep on changing. So here the cyclicity is for 13. So what we'll do is quite simple. We are given a list of 4 options. Now we want to figure out for which of these options the second person cannot win, or for which of these the first person has to win. So we'll again find out the remainder for all 4 of them. So option A, when you're dividing 1276 by 13, 1300 is a multiple of 13. So if you remove 26, so 1274 is a multiple of 13. So when you're dividing each of this, the remainder is 2, 3, 4 and 5. When you are dividing each of these with 13. When the remainder is 3 or 4 or 5, we know for sure that the second person is going to win. When the remainder is 2, we know that the first person is going to win. So if Arun wins the game, that is if the second person has won the game, which of the following could not be the number of coins on the table initially? So the number of coins initially on the table cannot be 1276. Because when you divide this by 13, the remainder is only 2, in which case the person who picks up the coins first will win the game. So the answer is 1276. In this question, we are told that there is a person called Ajay and he bought 6 dolls for his daughter. The dolls' names are A, B, C, D, E and F. His daughter's name is Sarah and he gave her different dolls on different birthdays. Now some clues are given and we have to identify which doll was given on which birthday, and some of the dolls were lost. So we also have to identify which dolls were lost, and then we can go ahead and answer the questions. So if you look at the clues that are given, we need to figure out which doll was given on which birthday and whether it was lost or not. There are 6 dolls, so there are 6 birthdays. So let us get started. So here we'll draw 3 lines. This will be the serial number, that is which was the earliest birthday. This is the year, that is whether it was the first year or second year or third year. And this is whether it was lost or not. And this is the name of the doll. If we can fill this up properly, then we are done. So this is for the first doll, this is for the second doll, this is for the third doll, this is for the fourth doll, this is for the fifth doll, and say this is for the sixth doll. So we need to fill this out. So the serial number 1, 2, 3, 4, 5 and 6. Now let us go ahead and look at the clues that are given. Initially we are told that the very first gift was given to her when she was 2 years old. So the first birthday, this is the serial number. So the earliest was when she was 2 years old. And the last one was given on her 10th birthday. So the last one was given on her 10th birthday. By the time she received her last gift, she lost 3 of them. So the number of gifts which are lost, the number is 3. So out of the 6 gifts, 3 were lost and 3 were not lost. The following information was also given. C was gifted 2 years after F was gifted. So this is the name of the doll. So in whichever year the gift C was given, that is equal to F plus 2, because it was given 2 years after F. Both the dolls given on her 3rd and 6th birthday were lost. So amongst the lost birthday gifts, the one which is given on her 3rd birthday and 6th birthday, both of them were lost. This will also let us know that the second serial number is 3, because the first one is 2 and 3 is greater than 2. There cannot be any birthdays between the second and the third birthday. We also have 6, which will fill up one of the 3rd, 4th or 5th birthdays, but we are still not sure which one it is. But we do know that one of them is 6. Sarah did not lose F, and if you are looking at the dolls which were not lost, F was one of the dolls which was not lost, but she lost another one in the same year in which she received F. So it means that in the year in which Sarah was given F, she lost one of the dolls which she had received earlier. This would imply that F is not the first doll that was given to her. A doll was given to her before F, and she lost one of them. She might have been given $3 before F, she might have been given $4 before F, or she might have been given $1 before F, but she lost one of the dolls which was given to her before F. So we know that F is not equal to 2. That is the only information that we can conclude by the second part. The next clue says that D was gifted 3 years after B. So D is equal to B plus 3, and exactly one of them was lost. So amongst the lost dolls, one of D or B exists, and amongst the dolls which are not lost, also one of D or B exists, because we know that exactly one of them was lost and one of them was not lost. Finally, we are told that at least one gift was given in every 2 years, and she did not lose her first gift. So the first gift was given to her in the second year, and this was not lost. We are also told that every 2 years at least one gift was given. So because one of the gifts is 6, was given to her on her 6th birthday, that cannot be the 5th gift that she received, because then the difference between the 5th and the 6th gift would be 4 years. That also cannot be the 3rd gift that she received, because between 3 and 6 there are 3 birthdays. So it is imperative that the 4th serial number, that is the 4th gift that was given to her, was given on her 6th birthday. This will also imply that the 5th gift that she received would be 8, because if it is 9, then the difference between 6 and 9 is 3, and if it is 7, the difference between 7 and 10 will be 3. So both these cannot happen, because the maximum difference between any 2 consecutive years is only 2. So the 5th birthday that she received it on her 8th birthday, the 5th gift. Now the only number that is remaining about the year of birthday is the 3rd one. Now there is another information that we have to fill out. We know that the gifts which were received to her on her 3rd birthday and her 6th birthday, both of them were lost. So the gift that she received on her 3rd birthday was lost. The gift that she received on her 6th birthday was lost. Now we need to identify which was the year in which she received her 3rd birthday. This can be the 3rd serial number. This can be either 4 or 5, because it has to lie between 3 and 6. So there are only 2 numbers. It is either 4 or 5. Now because 3 and 6, both of them were lost, 3 and 6 cannot be D and B. We do know that the difference between D and B is 3 years, but we also know that only one of them is lost. So 3 and 6, both of them are lost, so both of them are not D and B. Now if you are looking at any other pair which has a difference of 3, the only possibility is that the 3rd birthday has to be 5. Because if the 3rd birthday is 4, then you will not find any other pair of numbers which have a difference of 3, which will actually be D and B. Now because it is 5, there are 2 possibilities. The 2 possibilities are that D and B are either 5 and 2, or D and B are 8 and 5. If the number over there is 4, that is if the 3rd serial number is 4, other than 3 and 6, you will not find any other pair of numbers which have a difference of 3. So now that you know all the years in which the gifts were given, let us go ahead and try to identify the names of each of the gifts. Now if you look at C is equal to F plus 2, we do know that F was not lost. And we also know that F is 2 less than C. If you try to identify any of the possible numbers, F cannot be 2, because first of all we are already told that F is not 2, and we don't have 4 in the table because C is F plus 2. F cannot be 3, because even though we have 5 which is F plus 2, which is 3 plus 2, we do know that F is not lost. Therefore, but we know that the gift that was given on a 3rd birthday was lost. So F cannot even equal 3. F cannot equal 5 because 7 is not present in the years. C is F plus 2, so both the numbers have to be present. Again, F cannot be 6 because even though 8 is present in the table, 6 is lost, and we know that F is not lost. So the only possibility for F is that F is given on the 8th birthday, and because it is F, this is not lost. Now if we have concluded that F is given on the 8th birthday, because C is F plus 2, C has to be given on the 10th birthday. Again, because F is 8, the only pair which now remains, which has a difference of 3, is 2 and 5. Now out of 2 and 5, the smaller number is B, so this has to be B, and the larger number is D, so this has to be D. We also know that one of D and B is lost and one of D and B is not lost. We already know that 2 is not lost, so 5 has to be lost. This would also imply, because we have identified all the 3 gifts which are lost, we know that the 10th gift was not lost. Now can we identify which of them is A and which of them is E? We can't identify because no clue has been given about A and E. We just know that one of the gift that was given on the 3rd birthday and one of the gift that was given on the 6th birthday, one of them is A and the other one is E. But we don't know which one is which. So this is the table that we have filled out. Now let us try to go ahead and solve the questions that are given. Which of the following were lost? The gifts that were lost are A or E, D and A or E. These are the 3 gifts that are lost. So if you look at them cumulatively, we know that A is definitely lost, because whether A is present in the 3rd birthday, whether A was gifted on the 3rd birthday or whether A was gifted on the 6th birthday, it doesn't matter. We know that both of them were lost. So both A and D were lost, and even D is lost. So these are the 3 gifts that were lost, and the gifts that were not lost are B, F and C. These are not lost and these are lost. And now if you look at the options that are given, B is not lost, C also it is not lost, E on the other hand is present in lost, and the option D is more than one of the above, which is also not true. So the correct answer is C, which is gift E. This is option C. Now let us go to the next question. F was gifted on which birthday? F was gifted on the 8th birthday. So the correct answer is option D. Now let us solve the next question. If Sarah receives A after she received D, so she first receives D and then she receives A, then which birthday did she receive E? D was received on the 5th birthday, and we know that, or at least we are told that she received A after the 5th birthday. This would imply that A was received on the 6th birthday, because the only 2 possibilities for A to be received are on the 3rd or the 6th birthday. Now if you know that A was received on the 6th birthday, it would imply that E was received on the remaining birthday, which is the 3rd birthday. So the correct answer is 3rd, which is option A. Now let us solve the last question. Which among the following was lost by Sarah in the year she received F? We were told that she received one gift in the same year that she received F. So this would imply that she lost a gift that she had received before she received F. And the gifts that were lost before she received F are, because F was received on the 8th year, gifts A, E and D. These are the 3 gifts that she received. She received them in either the 3rd or the 6th year, 3rd or the 6th year and the 5th year. But we know that all 3 of them were received before her 8th birthday when she received F. So it can be either A or E. We cannot determine which of them she exactly lost on the year she received F. So the correct answer is cannot be determined, option D.